Terminal coding agents are taking over. Claude Code, Codex, Open Code. A new one drops every week. But have you ever wondered how they actually work? In this course, you're going to find out by building one yourself. This is Code, a Claude Code alternative built entirely from scratch. You will build the harness, wire up the tool calls, and understand exactly how these agents work under the hood. And here is the fun part. Once Code is functional, you can use it to help you finish the rest of this tutorial, or on any project you are working on, just like you would with Claude Code. Let's see it in action. I'll open Code in my project and ask it to refactor my authentication middleware to support role-based access control. The agent reads the codebase, identifies the right files, and writes the full implementation, all streamed token by token right here in the terminal. Now, if the UI looks familiar, that's because the design is inspired by Open Code. But don't worry, this is not a fork. We are building this entire project from scratch with a completely original implementation. That was build mode. In this mode, the agent has access to every tool. It can read, write, edit, and execute commands in your project. Now let me switch to plan mode and ask it to review what I just built. It reads the files, analyzes the architecture, and gives me a full breakdown. But notice what's different. In plan mode, the agent has no write tools, no edit tools, and no shell access. It can only read and search. That's not a limitation, that's by design. And once you understand how this works, you can create your own modes. A review mode, a test mode, a documentation mode. You control which tools the agent gets, and that changes everything about how it behaves. So how does this work? Code is a monorepo with 4 packages: a terminal UI built with OpenTUI, a backend server powered by Hono, a shared types and schemas package, and finally a database layer. The terminal UI uses OpenTUI's first-class React bindings. That means we build terminal interfaces with the same component model and syntax you already know from the web. Your existing React knowledge transfers directly. Each tool the agent uses, like bash, edit file, or grep, is its own module. You will build every single one of them. And every response streams in real time through server-sent events, with live reasoning on display. Now let's try something different. There's a bug in my credits calculation logic. I will point it to the file and ask it to find and fix the issue. It reads the file, identifies the problem, and applies a targeted fix. No full rewrites, no unnecessary changes. Just a clean, surgical edit exactly where it needed to go. Now let me explore the sessions command. Here are all of my past conversations. I can click into the one from earlier, the out refactor, and it's all still here. Every message, every tool call, every file change. I can pick up right where I left off. Now here is something interesting. Let me try one more generation. And there it is. Not enough credits. That's because Code is not just a coding agent. It's a complete software as a service business. We're building a full credits-based billing system powered by Polar. Every request costs credits based on the model and token usage. If you have ever wanted to monetize a CLI tool, sell inference for your own LLM, or ship a paid developer product, this will teach you exactly how to do it. Getting more credits is simple. Using the upgrade command, we can open the checkout screen from which we can purchase new credits. And just like that, we're back in business. I can check my balance anytime with the usage command. No webhooks, no complicated Stripe integration. Polar handles the metering and the credit system, and it all just works. And what's a CLI app without themes? Using the theme command, you can pick a color scheme and it will instantly apply across the entire UI. I can switch models on the fly using the models command. I can ask one question with Haiku, the next one with Opus, and the third one with GPT, all in one session. Nightcode is fully provider agnostic. The 6 models I've included are just a starting point. The Vercel AI SDK under the hood means that you can plug in Google, Mistral, Grok, or any other provider, and in this course, you will learn exactly how to add your own. And then there is authentication. Most CLI tools just ask you to paste an API key. Nightcode does it properly. Using the login command, your browser opens and you authorize through Clerk using an OAuth flow, and the session is communicated back to the terminal automatically. No copy-pasting tokens, this is real browser to CLI authentication, and it's something you rarely see explained anywhere. This isn't just a coding tutorial. We're going to follow a proper Git workflow with commits, branches, and real pull requests. Every pull request gets reviewed by CodeRabbit, our AI code reviewer, catching logic issues, best practices, and critical mistakes early on. Besides that, we're gonna get a preview deployment thanks to Railway, our deployment solution for this project. We're also going to get logs and error monitoring with Sentry. This has been one of my favorite projects to complete. Let's go ahead and build it together. Before we jump into the tutorial, I want to share something with you. Tutorials like this are great for learning how to build something step by step. But they usually skip over a lot of what real engineering actually looks like. You never see me do any debugging, refactoring, architecture changes, fix dead ends, or make technical decisions. And honestly, that's where most of the real learning actually happens. That's exactly why, for the first time, I made 2 different ways of finishing this tutorial. One is by watching this polished step-by-step YouTube tutorial. And the other one is the Cohort, where you learn how to code like me, not just copy what I type in a YouTube video. This YouTube tutorial shows you how to build a project step by step. But the Cohort is where I show you how I actually approach building projects like these from scratch, how I solve errors, refactor code, how I make technical decisions, and most importantly, how I think while building. If you want to learn that process, check out the link on the screen. In this chapter, we're going to set up our project and develop the initial component architecture. We're going to scaffold the monorepo using bun. We're going to add our initial package called CLI, and we're going to bootstrap it using OpenTUI's React template. That will allow us to build terminal user interfaces using a familiar React syntax. We're then going to evolve that simple example into a proper component architecture by having an app component, header, input bar, text area, status bar, and finally a quite complex component called command menu. Let me show you exactly what you will have by the end of this chapter. By the end of this chapter, you will be able to run this command in your project and you will open this home screen. You will have an ASCII code of your logo or your name of the project, and beneath it you will have this pretty looking text area. You will have a left border here that kind of indicates what mode we are on. Beneath it a text which tells you what mode we are on, hard-coded model that we are using, and you will be able to say something like hello world. Currently submitting does nothing, but you do submit with enter. If you want a new line, you hold shift and enter, all right? And if you enter a /, you get command menu. This one looks very simple, but that is because you are used to web applications. Keep in mind that this is a terminal, and this type of behavior doesn't exist in the terminal. So you're going to learn how to create it to build beautiful experiences for your users even within the terminal. When you select a command, you will be able to pass it along to text area, or if it has an action like exit, it will execute that action. So that is what we are going to have by the end of this chapter. Let's go ahead and start by creating a Nightcode folder or whatever is the name of your project. Let's go inside and let's start by initializing a Git repository. Then in here, I'm going to go ahead and open that repository. So open folder and that new folder we just created. Here it is. Inside of Night Code, I'm going to create a .git ignore file, and I'm going to add node modules inside. Then I'm going to add a readme.md, and I'm just going to add Night Code like this. So we just have these two files. Then I'm going to go ahead and run git add, git commit, and I'm just going to run initial commit. There we go. Then let's go ahead and create a new repository. So I'm going to call this Night Code. I'm going to make it private. I'm not going to add anything here. I'm just going to click create repository. And then I'm going to use the second option, push an existing repository from the command line. And I'm going to paste those commands inside of my Night Code folder, which has git initialized in it. What this is going to do is it's going to synchronize my local changes with remote, and here it is. Git ignore and readme are now on GitHub. Perfect. So now we can go ahead and develop knowing that our changes will be safe. So the first thing we have to do is we have to scaffold the monorepo. So for that, we're going to be using bun. If you don't have bun installed, you can install it using curl for macOS and Linux, PowerShell on Windows, or if you have npm, homebrew, or scoop, you can do it with those as well. Once you have it installed, you can run bun version to verify, like this. The reason we are using bun is for two things. Bun, when looked at as a package manager, has a feature called workspaces. Just make sure you change from runtime to package manager in the documentation. And then you can find workspaces here, which is exactly what we need. We are going to build a monorepo with multiple packages. We're going to have a TUI package or CLI package, a server package, database package, and a shared package. This can also be done with pnpm, but because we are going to be using OpenTUI to build terminal UIs, they also heavily rely on bun. So I would just suggest using bun for this project and then maybe switching later if you find it easier to work with pnpm. So let's go ahead and define a very simple package JSON in our project here. So I'm just going to create a new file, package.json, and I'm just going to paste this in here. I'm going to change this to be Night Code, aka the name of your project, and I'm going to remove dev dependencies and a trailing comma here because I don't need it. Great. So now that we have packages defined as our workspaces, let's go ahead and create packages, just like that. Now in here, let's go inside of that packages directory, and let's learn how to scaffold OpenTUI. So the cool thing about OpenTUI is while it's intended to be used like this, they also built first-class React bindings, allowing us to write it like this instead, which is exactly what we need because we come from web, or at least a lot of my followers do because I do web tutorials. So let's go ahead and run the following template here. So just make sure you are inside of your packages folder and run the following template and call this project CLI. Once this is initialized, you will have packages CLI in here. Open CLI, and now let's go ahead and copy git ignore entirely and let's paste it in the root git ignore. So let's improve this simplified git ignore that we had. Then I'm going to delete the git ignore, which was just added in the CLI because this is a monorepo and we only need one at the top. Let's also remove bun lock because the lock file will be kept in the root. Let's remove readme. We also have readme in the root. Let's go inside of package.json in the CLI and let's simply change its name from not just CLI, but let's make it an obvious extension, Night Code CLI, like this. So the reason I'm typing night code here is because that's what's typed here in the name, night code. So make sure it matches. For the TS config, this is a pretty good set of base defaults. So I'm going to copy it here. And in the root of my project, I'm going to add tsconfig.base.json, and I'm going to paste it here. I'm only going to remove these two because these two are OpenTUI specific. So I'm going to remove them. And then I'm going to go inside of packages, CLI, tsconfig.json, and I'm going to modify it a bit. So instead of it being all of this, I'm going to simplify it by extending our base config, which we just moved, and then adding those two compiler options, JSX and JSX import source. So that is what we've done now is we've gotten pretty good defaults thanks to this bun create TUI. But since this is a monorepo, it makes no sense that it has all of those options defined, since those are pretty good base standards for all of our packages. So that's why I am extending it instead of having it written all in here. So great, we now simplify the package JSON, the tsconfig, and the CLI is now much leaner. Now, what I want to do before we continue is go back in the root. So make sure you are in night code and just run bun install. And you can see one package installed, one removed. So obviously something was synchronized. And this is how we're going to install packages from now on. All right. Thanks to this simple package JSON monorepo, which we have established in package JSON using the workspaces, we can now keep track of all packages across all of our, workspaces or packages. So what do we actually have in the source folder? Well, nothing much. It's just a simple scaffolding here, which allows us to see an ASCII font and a text which says, what will you build? And it calls create CLI renderer, and it simply renders the root app component right here. So in order to see that, we have to change directory into packages. Let me just go back. My apologies, I keep changing where I'm going. So I'm just gonna go to work, night code. All right. So let's go inside of packages, inside of CLI, and then let's run bun run dev. So this is what you should have right now. The problem is right now, the only way you can run this is by doing this: change directory to packages, change directory to CLI, and then bun run dev. So instead, how about we add a script in the root of our package JSON, allowing us to do that. So I'm just gonna add a comma here and then some scripts: dev, bun run, watch, and my apologies, not this one. I meant this one. Here it is: bun run -- watch packages CLI source index.tsx. And now what I can do is when I am inside of my root project, I can run bun run dev CLI like this. So I no longer have to change directory. I can just do it from the root of my project, which is exactly what we wanted to achieve. Now let's go ahead and modify CLI source right here and remove the ASCII font. Let's also remove the text. Let's remove text attributes, and let's very simply render a text area here. So now when you run bun run dev CLI, you will be able to type just like that. And the cool thing about this command, bun run dev CLI, is that it has hot reload enabled. So if I add something like placeholder here, hello world, you will see it's immediately reflected. Pretty cool. So that is the initial step, scaffolding the monorepo. Now let's go ahead and evolve this into this more advanced component architecture. So what I want to start with is by creating a few components. I want to start with a header component because it's pretty simple. So inside of packages, CLI, source, let's create a new folder called components. And in here, I'm going to create header.tsx. Let's export the header component. And in here, I'm going to go ahead and render a box with justify content center, another box with flex direction, and then 2 ASCII fonts. It appears I'm having an error here. This could be just my IDE bugging up. There it is. You can see that the moment I changed something, it restarted the server and now it works. So ASCII font is a built-in component from OpenTUI. You can read more about it in the documentation actually. So if you find the components here, you can find ASCII font and you can see all the ways you can use it. This is my way of using it. And let me go ahead and actually render the header so that we can see this in action. So I'm going to go inside of index.tsx. And what I'm going to do is I'm going to clean the entire return here. And I'm going to start with an empty box with an align items, justify content, background color, width, height, and gap. And then in here, I'm just going to render my new component, header from components header. And here is the result, night code, just like that. So if you go back into header here, you can play around with these ASCII fonts. For example, you can hide this one, just have code and change the font to shade or to whatever else auto-completion tells you. You can have it huge, you can have it in a grid, right? A billion options for you here. Slick. I prefer having tiny, and I like to have a combination of 2 of them so that one can be a different color, and then the result is this. All right. So now that we have this developed, let's go ahead and develop another simple component. So at this point, what I'm going to do is I'm also going to show you what the end result is going to look like, because sometimes it's hard to understand what we are building without looking at the end result. Bun run dev CLI, this is the end result, okay? So right now we have this, okay? We're getting close. So what I want to build now is this component right here. I want to build the input bar, I want to build the status bar, and I want to show you how you can add this small little border, which kind of makes it cool because it matches the color of the current mode. So let's start with the status bar because it's very simple, okay? Let's go inside of packages, CLI, source, components, and I'm going to create a new file, statusbar.tsx. The status bar simply uses text attributes from OpenTUI core, export function status bar, and return a box, return a text with a foreground color of cyan, rendering the text build, and then text attributes.dim with a foreground of gray, rendering a chevron. Now, I'm not entirely sure how we can I'm not sure how to render these elements in like this type of format. Maybe something like this, I don't really know. You can basically search for like Unicode for chevron. Let me go ahead and try and find, here it is, HTML entity for it. So if you don't know how to type it, you can type it like this. And I think it should work. We'll see. If it doesn't work, yeah, you can basically just Google this, and I think you should be able to copy it from Google then, like an arrow, and then just paste it here. All right, so that is status bar. So if I go inside of index here and render status bar now, you can see how that looks like. Build and Opus 4.6. Basically, we are hard coding the current mode we are in, and we are hard coding the current model that we are using. So getting close to the end result here. Now that we have the status bar, let's go ahead and develop the input. So I'm going to go ahead inside of components, new file, input bar .tsx. Let's define the props. The props are going to be on submit and disabled. And then let's go ahead and export function input bar with the same props. And in here, I'm going to go ahead and return a box. Then in here, I am very simply going to open another box, and I'm going to add a little comment here to do add left border. So I'm purposely going to leave this box empty attribute wise, and then inside of this box, we're going to add another box with all of these properties inside. And then finally, we can render the text area. And let's go ahead and make sure that it's not focused if it's disabled. And let's go ahead and give it a placeholder. Ask anything, for example, fix a bug in the database. So now we can go and beneath the text area, render the status bar actually. So make sure you have added this import here. And now we can go back inside of the index here, remove the status bar, and instead open a box and render the input bar in here. So remove this, we just have input bar, and add on submit here. And for now, it can just be an empty arrow function. And as per the box, which is encapsulating the input, give it a width of 100 and some limitations on the max width. And you can see we are getting pretty close already. Good. So what I want to do now is I want to show you how you can add that left border. It's not as intuitive as you might think. So let me go ahead and show you. I'm going to go back inside of the input bar. So what I thought I was going to do is just define border and then left and then border color and set it to cyan. Let me see if that's even visible. And it looks okay, right? But it's not exactly this, right? In original open code, they have this thick line. If you're satisfied with this, you can leave it at this. I mean, this is just cosmetics talk, right? But if you really want to have it the same way they are having it, the way I found out is by picking at open code source code. And I found that they have this handy little util, which has this kind of thick pipe, which I have no idea how to render in Unicode. So if you want to, you can add that. If you don't care about it, you don't have to add it. It's just cosmetics. I'm going to do it to stay true to my original source code. So I'm going to add border.tsx, and I'm just going to render that inside. Okay. So now that I have that, I'm going to go back inside of the input bar right here. And I'm going to add the following: custom border characters, import empty border from /border, add vertical and add bottom left And again, this is an even shorter one, which I also found in their source code right here. I have no idea what character that actually is. So if you want to, you can add it, and then you'll have like a thicker line here, and it will be more similar to open code. If you don't care about it, it really does not matter, okay? Good. So, pretty cool, right? So, what are the current differences? Well, in my current implementation, if I try to submit, I have a new line. Whereas in the finished implementation, if I try to submit, it actually submits. So, the way we do that is by adding key bindings. So, you can actually go inside of text area here, and I think quite soon you will come across key bindings. So this is how you can make a combination of user pressing on return and control being pressed as well, trigger the submit action. So that's what we have to do now. We have to define the how should I say, bindings, right, that we're going to need. So I think that we should do this here in the input bar. And let's just import key binding from OpenTUI core. So return should trigger the submit action, same as enter. But if return or enter are held with shift, they should open a new line. And now that we have the text area key bindings, let's go ahead, key bindings, and pass along text area key bindings. And I think that this should now work. Let me check. Try to submit. There we go. Nothing happens because we don't have submit implemented, but it doesn't do a new line. But if I hold shift, then it does a new line, exactly as the end result. Great. I'm very satisfied with this. Now it's time to start developing the big one. Now it's time to start developing the command menu, which opens on /. So that is this. And it's a very complex one. So let's go ahead and have our app running here. And we're going to start with kind of a simplest thing we can do, which is just defining what commands should exist. So instead of source components, let's open a new folder called command menu. And then in here, I'm going to add commands.tsx. And in here, I'm going to export const commands. Okay. And then I'm just going to add some commands. Let's, for example, add new. And let's, for example, add an exit command. Now, right now, we don't have proper types for this. So we should add those as well. I'm going to add it inside of command menu, types.ts. And let's define the command context, which for now should only have the exit function, because it's the only command which we are executing at the moment. We can't really add any more types, but later this will have access to our toast provider. This will have access to our dialog provider. This will have access to our prompt config provider, which will encapsulate what model we are on, what mode we are on, right? But right now, the only one we have defined is the exit function. So that's why we are having such a shallow command context. And then let's create the type for a command item in general with name, description, value, and then an optional action. And then we can go ahead and define that. So command from types and then an array. And you can see the error has gone away because now exit is a proper function that is passed to every command. So every command can, access the context and exit. So that is how we're going to define what commands exist in our command menu. Now, let's actually develop the component itself. In order to do that, we first need to add a simple filter commands function. So what this is going to do is it's going to go over our commands array, and it's simply going to filter by user input, or should I say user's query. So if user's query is empty, it will fall back to returning the full list of commands. Otherwise, it's going to filter over them. If they start with lower, it's going to filter over them in a way that it lowercases the command name, lowercases the user's query, and uses a very simple starts with API to check if we actually have the command that the user is trying to search for. So right now, nothing happens in our code, but what is supposed to happen is this, right? It's supposed to query, okay? That's what that function is for. So now that we have that, let's go ahead, instead of command menu, and develop the actual component. So for the component, we're going to need ref object from React, text attributes, and type scrollbox renderable from Open2E core. And then our newly created get filtered commands and the actual commands array. In here we have a bug saying that types React isn't added, and I believe it is not. So let's go ahead and quickly add it. So I'm going to go inside of packages, then I'm going to go inside of CLI, bun add the types React, just like that. Then I'm going to go back, bun run dev CLI, and I believe this error has been solved now. And my CLI package JSON should now also have types React added here. I'm pretty sure this should be the same version, but I guess they are minor enough that it's not causing any incidents. Let's just focus on developing our command menu component. So let's define the maximum number of visible items, which is basically this. When you do a /, how many of these should be visible? So 1, 2, 3, 4, 5, 6, 7, 8. Everything else should be overflown. Okay, that's what this constant is doing. And now we have to define the command column width. Basically, we have to align all command names in a fixed width column so that their descriptions start at the same horizontal position for a clean tabular look. Again, simpler to explain by looking at this. Regardless of the length of the name of the command, you can see that all descriptions start at the same line, almost like a table. So that's what we're trying to do here, because it looks very weird if every single description starts like here, then here, then here, then one here. It just doesn't look as good as this. So I'm just trying to show you how extensive Open2E is and how much you can actually care if you want to. So let's define the command column width using this math-max, which simply iterates over the commands and simply finds the length of the command names and then defines like the maximum value of it and adds a buffer of 4. Then let's go ahead and define the command menu props, which is this component that we are building. Let's go ahead and export the component itself. And let's start by finding out which commands we should render. So what was the user's query? Should we render all commands or just some of them? Then let's go ahead and get the visible height. So now that we have filtered the elements, how many elements are visible, right? Should it be a maximum of 8 or can it be less than that if there's not enough results? Or if there are 0 results, should we show something? Yes, we should. we should say no matching commands with a simple attributes, text attributes dot dim. And then let's go ahead and return, and let's render scroll box here, which is another OpenTUI component with a ref and a height. And in here, we just have to iterate over our commands. So let's first check if the user is highlighting a certain command by using the selected index prop and defining that in the isSelected constant. And then in here, we can go ahead and return a box element. Let's go ahead and give this box element some attributes here. So the key is going to be the command value. It's going to have some flex, some padding, some height, overflow, and then it will change background color depending on if the user is hovering or not. Let me show you exactly what I mean. When I hover, it changes to blue. But notice that I also have to change the foreground color of the text so the contrast looks good. So right now, again, we don't have any of that, but let's go ahead and simply continue developing. So now I have to render the name of the command like this. So we define the width, command column width, which we have calculated above in a tabular-like fashion. And then we have a text attribute, and we change the foreground depending on if it's selected. So we create a contrasting color. And we simply render the command name along with a / to indicate that it's a command. And then beneath that, another box which is used to render the description, which does a very similar thing, but instead of black and white, it uses black and gray. Brilliant. So that is our command menu component. Now what I want to do is I want to check if we are able to already render it inside of input bar. Perhaps we cannot do it yet. I just want to try just in case. So let me go ahead and find this where I'm supposed to render this. All right, so we have to render it within the box which has a position relative. So just above the text area here. I'm going to go ahead and simply hard code true and because this will later be dynamic. And let's start by rendering a box. Let me go ahead and close the box. So a box with position absolute, bottom 100, left 0, width 100, background color and z index of 10. And then in here, let's see, can we render the command menu? So it's a self-closing component. And make sure you have imported it. And let's see, I'm currently having an error. So for the query, I'm going to start with just an empty string. And I think that that's enough. There we go. You can see new and you can see exit. Obviously, we need a lot more here, but I just wanted you to see how it's going to kind of like float above our text area. So right now you cannot click on it, you cannot control it with the keyboard, and it's always visible. So now we have to change that and we have to make it actually dynamic. And this is the most complex part actually. In order to achieve this, we have to develop use command menu hook. So let's go inside of source, components, command menu, use command menu.ts. In here, I'm going to add use ref, use state, use memo, ref object, scroll box renderable type, use keyboard hook, and get filtered commands along with the command type. Let's define the return type of this hook. So it's going to return all of these: show command menu, command query, selected index, scroll ref, handle content change, resolve command, and set selected index. Let's go ahead and map those return types to the actual hook so we can start developing it. I'm going to go ahead and start by defining all of the states and refs. So text value, selected index, show command menu, string, integer, boolean. And finally, a scroll ref with a type of scroll box renderable from OpenTUI with the default value of null. Let's go ahead and define the command query. So command query checks if show command menu is true, and it checks if text value starts with /. If it does, simply extract the part after the slash. Otherwise, fall back to an empty string. And then using that command query, we can filter the commands using getFiltered commands. Now that we have a list of commands that the user is searching for, we can develop the rest of our functions. So let's start with handle content change, which accepts text inside. The first thing we're going to do is we're going to change the value of text to that text passed. We're going to change the selected index back to 0, so it restarts whatever was highlighted again because user just entered something new. And then what we're going to do is we're going to jump back to the top of the list when the user types a new character. So we find the scroll box, and if we successfully found the container, we are scrolling back to the top. Then let's go ahead and check if the prefix starts with a / and then extract everything after the slash, exactly like we do here. And then let's go ahead and do an if else. So if the prefix is not null, and if the prefix doesn't include an empty white space after the /, let's go ahead and show the command menu. Otherwise, let's go ahead and hide the command menu. So what is that logic? Well, let me show you the finished result. If I type a /, we should open the command menu. If I go ahead and search for something that's filterable, I will continue showing this. If I search again, I will show empty. But if I add white space, we're going to assume the user literally means / and wants to send the / character to the agent. So that's why we developed that logic. Now, let's go ahead and develop a function to resolve a command. So resolve a command at a specific index. The way this is going to function is as follows. So the resolve command function accepts the index and returns the command or undefined. It will attempt to find the command from a list of filtered commands using the index. If the command exists, it's simply going to hide the command menu, and it's going to return the entire command to the provider. The entire command is basically this. So then the provider will see, okay, you have returned me this command. Does it have an action? If it does, I'm going to execute it. So that's how it's going to work. We are not going to make this hook know exactly how to execute every single command. We're just going to make it return to the provider. And now we get to, I think, the most complicated part, which is arrow keys to move the selection. So right now, you can't do anything yet. I'm showing you the finished result. But you can see how easy it is to, control the scroll box component from OpenTUI with your cursor. But we also want it to do with your keyboard. It looks simple because you're used to web components, but none of this is actually built in. We have to develop this experience from zero. So that's why we're now going to use the use keyboard hook. So let's first check if the show command menu is false, we can do an early return. If the key pressed is escape, we can do an early return. But if the key pressed is the up key, in that case, we should do something else. we can again prevent default, and then we should call set selected index and open up a function. Now in here, let's go ahead and define the new index. So using math.max, the first value is 0. The second value is the current number minus 1. And let's go ahead and add a little comment here. Keep the highlighted item visible when arrowing past the edge. Let's find the scroll bar. And if scroll bar exists and the new index is less than scroll bar, scroll top value, in that case, scroll bar, scroll to the new index. I'm not going to pretend like this is crystal clear. It's just easier to understand by looking at it. Basically, it's one of these two. Right now, we are targeting key up. So to demonstrate, I'm going to go to the bottom. You can see that when I go up after models, I scroll. I scroll again. And now we have to develop the same for down. So that's what this function is doing. It's just not that clear. It's complicated, scrollable calculation code. It's not really fun. And let's just return the new index. And now we have to do a similar thing for down key. So again, we are preventing default. We are going to open this set selected index. Let's first check if the filtered command's length is 0 and then return back 0. Otherwise, let's calculate new index again, but in the opposite way because we are scrolling down now. Let's find the scroll bar again. If we have the scroll bar, let's go ahead and define the viewport height. Then let's check if there is a visible end with the combined scroll bars scroll top plus viewport height minus 1, which is a buffer. And then let's do an if clause to check if new index is greater than the visible end. And finally, scroll to. Again, not fun to develop, but it is necessary to have a nice experience. And as I said, so this is exactly the opposite. This is if we are at the top and we go down, it pushes the thing down. That's what that is. Again, you don't have that yet. We're going to connect it in a second. And to wrap up the hook, we obviously have to return all of these. So make sure you return all of these. Brilliant. So now we can go back to the input bar and finally connect these. So input bar.tsx. Let me check what I am missing. So I'm going to import useRef, use callback, use effect. I'm going to import type text area renderable. I'm going to import use renderer from OpenTUI React. I already have command menu, but I don't have the command type, so I'm going to add that. And I'm also going to add use command menu, and I already have the status bar, so that's solved. Now let's go inside of the input bar itself, and let's add the following 3 elements: text area ref, onSubmit ref, and the renderer itself. So now what I want to do is I want to wire up the text area submit handler once, so it always reads the latest state. So this is a trick I came up with because whenever I was submitting text area, I just couldn't get the latest value from it. So this is what I ended up having to do to be able to read that. And we just have to register this on submit ref. So let's just do this on submit ref.current. If disabled, return. If show command menu, const command comes from resolve command, and then simply call handle command. Otherwise, handle submit. I will explain what this is in a second. I just want to get rid of the errors, and we can get rid of the errors very simply by just calling this big hook use command menu and just extract everything from it. All right. All right. Handle command is not yet developed, nor is handle submit. So what does this do? Well, first of all, if the user attempts to submit using the text area, what happens? Well, if it's disabled, nothing. If the show command menu is opened, then we're not going to submit, but we are just going to execute the command. But if the show command menu is not open, then we're going to submit, right? So when I go ahead and do submit this, it will submit it. But if I go ahead and press enter now, it doesn't submit it. It just executes the command. Okay. So now let's go ahead and develop these one by one. So how about we do handle command? I'm going to go ahead and do that here. So use callback. We need to define a function, and we need a dependency array. So what use callback is going to accept here is a command with a type of command or undefined. If we have no text area, or if we have no command, let's do an early return here. Then let's go ahead and change the text area text. And then let's go ahead and check if we have command.action. If we have command.action, we are going to execute that action. But in order for the action to work, we have to expand its context. For example, our current command exit expects an exit function. The reason there is no error here is because we have defined the command context to have it. But right now, the action doesn't really have the exit. So let's go ahead and add it for that command. So renderer.destroy. And just like that, we have added context to our command. And then our command can access that context and fire it. Let's go ahead and add an else here. So what if there is no action defined for a command? Because that's a type of command as well. Well, I'm just going to insert it into the text area and add a white space at the end. That's it. That's all I'm going to do. And let's add renderer here. And I feel like I'm doing something wrong here. Okay, no, all good. Handle command finished. Now we need handle submit. So I'm going to go ahead and develop that above handle command here. This one will be pretty similar as well, in a sense that it is also a use callback. It's not going to accept any props. It's just going to check. If disabled, let's do an early return. If text area ref not found, early return. If text value when trimmed is empty, early return. Otherwise, let's call the actual onSubmit function, which we are passing through the prop, and pass along the text. And once we submit, let's clear the value of the text area. And in the props here, let's add disabled and onSubmit. Great. So we now have pretty much all the functions we need, but we don't have a way to keep track of the value of the text area. For that, we need a function called handle text area content change. So let's go ahead and develop that one as well. I'm going to do it here. Again, it's a use callback. And I'm going to go ahead and again check if we have text area. If we don't, let's do an early return. And then let's simply call handle content change and pass along text area plain text. And then the handle content change here is going to do what it needs to do, meaning that it's either going to show the command menu or hide the command menu depending on what the user is typing. So we are just going to pass along whatever text area has received, and we're just going to go ahead and let the use command menu hook decide, should I open the command menu for that, or should I not open the command menu for that? Basically, it's looking for a forward slash. And the reason these functions seem complicated is because we have to access them through the ref to read their values, because otherwise the values keep being stale. At least that was the case for me when I was developing. So in case you're wondering, like, why am I doing so many checks of these areas? Like, why don't I just keep track of the value? It just caused bugs for me. So I'm just staying true to my source code. But obviously, feel free to experiment. It is encouraged. It is even better if you don't have the same project as me, if you have something different. Brilliant. So now that we have handle text area content change, we can actually add it to the text area. So on content change, handle text area content change, we have the key bindings, but we don't have the ref. So let's add the ref. And then we can extend our command menu here with all the props, except handle command execute. So we didn't develop all of them, my apologies. But all of these other ones come from the use command menu hook. Okay, so that's why we have them. Okay, let me see what this function is. Handle command execute. Okay, let's go ahead and just develop it. Const handle command execute is use callback. And let me just go ahead and add an empty array. All right. It's going to accept an index, which is a type of number. And then in here, it's going to find the command using the resolve command. And then it's simply going to forward it to the handle command, which can execute the command itself. So we're doing some jumping through the hoops here. Let me dive into the resolve command. So in here, it's just checking if we have it through here. I'm trying to understand why we are hooping through hoops like that here. I think there is a reason I ended up doing it this way, but I don't know how to explain myself at the moment. Let's just leave it at this. Okay, the only thing left to fix right now is this hard-coded true. So instead of the hard-coded true, this should be show command menu, like this. And I think that if I go ahead and type a forward slash, I can now see my commands. The only problem is we can't really demonstrate whether all of that keyboard things are working because our commands are pretty shallow right now. So I'm going to go ahead and just add every single one of them. So in between new and exit, we have usage, upgrade, logout, login, theme, sessions, models, and agents. Those are all of the commands we're going to have. Right now, the only one with action is the exit command. So if you try and use agents, you will just, have it added to your text here. If you try the arrow keys, all of them should be working. You can scroll with your arrow keys just as easily as with your cursor, your mouse. If you hit exit, it should immediately execute that, because that's the only kind of context provider that we have at the moment. Brilliant. That is, I believe, everything we wanted to achieve. That was the big one. I kind of purposely wanted us to experience a more complex implementation of OpenTUI, just so you can kind of get the feel of developing with it. But don't worry, not everything is this complicated. In fact, the command menu is one of the most complicated components in the entire app. I mean, simply experience-wise. It's not complicated in a sense that it has some magic functionality. It's just hard, to get that experience right. The entire UX and UI is obviously inspired by Open Code, and I've been so amazed by how much better Open Code's coding agent is in comparison to Claude Code or Codex, right? So you can definitely feel the high quality in their terminal coding agents, and that's what I want to teach you to do, or at least my way of how I would do it, because I'm really, really impressed by it. Brilliant. So I'm just going to go ahead and double check that we did everything we were supposed to do, and then we're going to create a new branch and commit these changes. So there is just one tiny thing we could potentially do. You don't even have to do it, but maybe we can. So inside of the create CLI renderer, let's go ahead and add target FPS to be 60. And let's add exit on Control C and set it to false. So now you can no longer exit with Control C. You can only exit with the exit command. But that's not going to be the case. The reason I'm turning this off is because we are going to implement something called a keyboard layer. Basically, a registry of which component owns the screen. Again, that's something you have to implement when working with a TUI app which has dialogues, right? You have to know which one owns the keyboard. On the web, all of that is solved for you with native elements, with HTML. But in TUI, you have to develop it yourself. So it's an interesting challenge for you to kind of re-implement web components from nothing, from scratch. So the way this is going to work, we are going to manually write code for what Control C is going to do. That's why I'm turning it off. Not because I don't want it to be able to close the app. It will close the app, but only after it confirms that, for example, nothing was written in the input. If it is, and if it presses Control C, it should clear the entire input. If the command menu is open and then the user hits Control C, it should close the command menu. If a dialog is open, it should close the dialog first, and only then, only when we are back to the base layer and then the user hits Control C, which would be now. For example, I'm pressing it now, but it's not doing anything. In the next chapter, or maybe in the subsequent chapters, we are going to implement programmatic code to actually close this. Brilliant. I'm super satisfied, and it looks exactly as the end result, which is exactly what we wanted, right? Why would there be any differences? Brilliant. Let's go ahead and commit all of these changes. So we do have a lot of our changes here. So the last thing that was here is just, git ignore and readme. So what I'm going to do now is I'm just going to go ahead and open a branch called project setup and component architecture. So let me go ahead and exit. Git checkout -b01 project setup and component architecture. The idea is that basically we have every chapter under a branch so that we can easily go back and see our progress. And so that you, when you're watching this tutorial and looking at my source code, you can see exactly when I implemented what. So if you want to go back to this branch, you can just select this branch and you will see all of these changes that we just did. And I would suggest you do the same, so it's kind of easier for you to keep track of what happened. So this is our chapter 1, project setup and component architecture. So I'm creating a branch here, and then I'm going to go ahead and add all of these. I'm going to commit, and I'm going to do the same thing, 01 project setup and component architecture, like this. And you can see that right now I am on this new branch, and you can also see the same branch here in my IDE. So now I'm going to do git push -u origin 01 project setup component architecture, which will push the branch to my GitHub here. And now I can create a pull request. If it's not appearing here for whatever reason, you can manually go in pull requests, click new pull request, select base main, and compare your new branch. and then create a pull request. And now we're just gonna review the changes. My pull requests are reviewed by CodeRabbit. CodeRabbit is an AI code reviewer which you can get by using the link on this screen. You can get it completely for free and connect it to your GitHub with a 2-click install, and every single subsequent pull request will be reviewed by CodeRabbit. You can use it to create diagrams, to find serious bugs, and even brainstorm off or teach it something new if it made a mistake. But what's most impressive will actually come to light later. The more pull requests we have, the better CodeRabbit understands our code base. So CodeRabbit will actually reference this pull request in maybe our 9th pull request because it knows that there is a potential conflict or something like that. So it's a really amazing tool that has become a daily part of my pull request reviewing. And when doing these types of project yourself, it's actually very important that you have another pair of eyes take a look at your code. So let's take a look at everything CodeRabbit found because it already found a major issue. So summary, we added a command palette interface. We introduced keyboard navigation within the command menu. We added an interactive input bar supporting command execution, and we implemented a CLI header with branding and status information display. And in here, we have a minor mistake. We shouldn't be returning commands just like this. Instead, it is proposing to return a shallow copy of it just in case something mutates the returned list. So that's a good tip. For example, this is minor, right? It's not something that's going to break the code, but it's a good suggestion. Down here, on the other hand, we have a major suggestion. It says that we have forgotten to add anything to our dependency array, which is true. We don't have anything in handle command execute, but I'm pretty sure handle command execute should have both resolve command and handle command added to its dependency arrays. Otherwise, it wouldn't work. In here, it told me that I should have a proper on submit, but we can skip this recommendation simply because we know that that's currently not what we are implementing. In here, it's warning us that we turned off a very standard exit mechanism, but I explained previously that we are going to enable it just in a different way. So this one is actually very, very important. I'm going to resolve it the following way. So if you already merged your pull request or decided not to follow pull request architecture, then you can just do it in the next session. It really doesn't matter. But for example, let me go inside of components here. Command menu, my apologies, not command menu. This will be input bar. And let's go ahead and let's find the handle. Where is it? Handle command execute. So we are missing resolve command and we are missing handle command. Blocked scope variable used before. Okay, I see what's going on. Let me move this below handle command. There we go, just like that. So one file changed. So I'm going to go ahead and do the following: git add, git commit, 01 project setup and component architecture PR fix. And then I'm just going to do git push because I'm already pushed the branch. And you can see that now that's going to re-trigger the pull request. And if you have added CodeRabbit, which I'm going to demonstrate now, you will see the updated or resolved comment. And after the review goes through, you can see that now this is set to outdated, meaning that it was addressed in a commit. So CodeRabbit automatically marks something as resolved. I could have technically fixed this as well, but I think it's okay. I don't think we ever mutate commands, but maybe in the next pull request, I'm going to do that as well. For now, I just want to close our first pull request. Let's go ahead and merge it. Let's confirm merge. I'm not going to delete my branch. I think it's very useful for them to be here. So right now, my main branch has all of the changes I have developed, but I can always go back to 0.1, which is now identical to main. It's one commit behind because that's the merge commit, but code-wise, it's identical. So then when we merge subsequent pull requests, in here we have a history and we can always go back to whatever state we want. What's important now is to check out main here and git pull origin main so that you are synchronized, right? There we go. And in here, you should see all of the files now are on the main branch. So packages, CLI, source, components, command menu, everything is here. Just confirm you're on your main branch and try running this. If it works, everything is fine. Brilliant. Amazing, amazing job. So that marks the end of this chapter. We implemented both steps. We got very familiar with OpenTUI and how we're going to build this terminal interface, and see you in the next chapter. In this chapter, we're going to develop the UI infrastructure. We're going to develop toasts, dialogues, theme system, and even a keyboard layer. We're going to develop this in 3 steps. Step 1 is going to be toast notifications. We're going to have a toast provider, a toast component, and several variants like success, error, and info. And we will be able to invoke them using toast.show and then some options inside. And the notifications will automatically dismiss after 3 seconds. In step 2, we're going to develop the dialog and the keyboard layers, which I'm going to explain more in a second when I show you the end result of this chapter. But it's basically a system to let us maintain which layer owns the keyboard and the shortcuts, in this case, Control C. We will also have a theme system in step 3. So we're going to develop the actual theme provider, a theme dialog, and we're going to add color presets, which I'm going to show you how you can add yourself, or you can just copy all that I'm going to add. And we're going to save them to Nightcode preferences so user can, well, save their selected theme and it will load the next time they open up the CLI. So let me go ahead and show you the end result, especially because of the keyboard layer thing. So what we currently have is the following. We have an ASCII logo here, and we have the command menu, which can be used to populate the text area with the command value. What we cannot do at the moment is quit the app using Control C. We also cannot close this command menu using any shortcuts as well. But in the end result, it's going to be a little bit different. So let me show you. This is what we're going to have at the end of this chapter. We will be able to trigger notifications like this. We will be able to open dialogues like this. And then we will be able to control which layer owns the keyboard. What does that mean? Well, for example, if I start typing something, and if I press Control C, that will clear the input. If I have command menu open, and if I type Control C, then it's not going to clear the input because there was a layer above text area which owned the keyboard at the time. Or if I open a dialog, again, Control C is not going to clear my input, but it's going to close the dialog instead. And only if there is no other layer that owns the keyboard, we are going to allow the user to use Control C to actually close the app. And one more thing I didn't show you are the themes. So we're going to develop all of these themes, and it's going to be quite simple. And the reason we are doing it already is so we don't spend time modifying hard-coded hex colors later in the project. So we are doing it relatively early into the project. All right. So let's go ahead and see how we're going to develop this. I want to start with obviously step 1, which is adding toast notifications. So I'm going to go ahead inside of my project here, and I'm going to go inside of packages, CLI, source, and then in here, I'm going to create a new folder, providers, and then another folder, types. Inside, I will create types.ts. And I made a little mistake with the naming here. It's not going to be called types, it's going to be called toast. I was thinking of types, so that's why I named the folder the same. So we are going to have a toast folder and then types file inside. The types are simply going to export everything we need to develop the actual toast components, such as the variant, which is success, error, or info, toast options consisting of message, the variant we defined above, and how long the message should be shown, as well as a default version of 3 seconds. Then let's go ahead and create the actual provider and the component within an index file. So in here, I'm going to go ahead and start with adding some imports. Whoops. So let's go ahead and import create context, use ref, use state, and use callback, all from React. Then let's import a type React node. Then let's import use terminal dimensions from OpenTUI. Let's go ahead and import our newly created types, toast options and toast variant from types. Let's export the default duration from the types as well. And then let's export the toast context value. So our provider will allow us to have the show method, which we can then trigger everywhere within the app as long as our app is wrapped within the toast provider. So now we're going to simply do the classic composition of React context. So let's develop the toast context and let's pass in the proper types inside. And then let's go ahead and develop the use toast hook, which will return toast context value, which is an object which has the show function inside. Inside of this hook, we're going to attempt to extract the value using use context and passing along the toast context. And then we're going to check if it's not available. And if it's not available, we're going to throw an error. Use toast must be used within a toast provider, because if it's not available, it means it wasn't initialized properly. And to make the TypeScript errors go away, we have to return the value itself. Now let's go ahead and define the actual props for the toast provider. And let's go ahead and export function toast provider with the props we just mentioned. Let's go ahead and create a state to maintain the current toast. The type of that is going to be toast options, so message, variant, and duration, or null. And let's go ahead and add a timeout handle ref. Now in here, you might come across this error. Maybe you will, maybe you won't. I'm going to show you several ways you can fix this. So as you can see, I have a problem with Node.js timer namespace. So my Node.js namespace seems to completely not exist within this project, and which is kind of odd because in my initial development, I didn't have this problem. So here's one way we can fix this. We can go inside of base config and we can add types and we can specify bun. And once you save the file, it goes away. That's one way of doing it. But since I didn't need to do this in the original project, I just couldn't figure out, why am I having a problem? And the way I debugged this is by opening this exact project in another editor of mine. And then I figured out, the problem is VS Code. Because if I open it in Z, for example, in here, I have no problem. This works. But in VS Code, there's a problem. And you can fix it by clicking on these curly brackets down here. And you can see that TypeScript version is 6.0.2. And if I click select version, it will allow me to use VS Code's version or to use my workspace version, my node modules TypeScript version, which is the one I actually want. So when I switch to that, it fixes it. So I think this would be a preferred fix. The only issue might be if you are working within a team and then all of you have to do this. So you would most likely have to add like a VS Code. I think it will automatically do this for you. .vs code settings.json, and then in here like specify what TypeScript version you're using, and that fixes those errors. Now let's go ahead and develop the clear current timeout function. So it's a use callback, which simply looks for the timeout handle ref, and it will clear the timeout and reset the ref, and it will have no dev dependencies. Now let's develop the actual show method. So this is going to be a use callback. Let me go ahead and define that. So what we are going to have here are options. So let's go ahead and pass that as the prop. It's a type of toast options. And then we're going to see if the user specified a duration. If it didn't, we're going to default to 3 seconds. And the first thing we're going to do is we're going to clear if we have any active timeout. So let's immediately clear it. And then let's go ahead and set the current toast. Let's give it a variant. Again, check if user passed a variant. If it didn't, fall back to info. And this should error if you type something incorrectly. So it will very strictly follow the toast variant that we have defined. So it can either be success, error, or info. And then we just spread the rest of the options and we pass along the duration. And now we have to start the timeout handle for this. So let's go ahead and add timeout handle ref.current equals set timeout, set current toast null, pass in the duration dot unref. And in the dev dependencies here, we need clear current timeout. So a lot of things we've written here will be an error if you don't have an incorrect TypeScript version in your IDE. You can see if I switch back to VS Code's version, set timeout is the problem, clear timeout is a problem, everything is a problem, right? So just make sure that you are using a workspace version or that you add types bun in here, one of the two. All right, now that we have that, let me go ahead and prepare the value that we're going to return from here. So value is a type of toast context value, and we pass along the show function we have developed here. And then finally, we can go ahead and just return the provider. So that's going to be toast context.provider, pass along the value, children, and then the toast component with current toast property of current toast. We don't have this component yet, and we're going to develop it now. Let's go ahead and give it a type, toast props. It is going to have a singular prop, which is the current toast, which is basically the toast options. Let's go ahead and develop the toast component. So here is that prop we were just talking about. Now let's see what the width of this toast should be using use terminal dimensions from OpenTUI React. Once we have the width, let's go ahead and check if we actually have a current toast to render, and if we don't, let's do an early return. And now let's go ahead and hard code these variant colors, and let's give it a strict object type, so it needs to match the toast variant. So if you type a typo like this, it's gonna show you an error. So you can only define colors for the variants that we have, which are success, error, or info. And then let's go ahead and do the same thing. Once again, I mean, not exactly the same thing. I meant to say, let's use this map into border color definition. So if we have a variant passed, let's go ahead and choose a variant from the variant colors. Otherwise, we are going to fall back to info coloring. And now let's go ahead and return the actual JSX, the actual look for this. So we're going to develop this within a box here, and it's going to have a bunch of attributes. So the first three are going to be position, justify content, and align items. Then we're going to have top and right. Then we're going to go ahead and calculate the width using mathmax. Let's go ahead and add some padding. So we're going to have padding left, right, top, and bottom. Let's go ahead and specify the background color. Let's go ahead and add the dynamic border color. And let's go ahead and specify the border, which is going to be left or right. And then inside of this box, let's render another box with a flex direction and gap as well as the width. And finally, a text element with foreground of this hex color, which is kind of a grayish white. Wrap mode word with 100% and render the toast message inside. And I'm going to go ahead and add a comment to do add split border, just so I don't forget about this. All right, now that we have developed the component and the provider, what we can do is we can go back instead of source index.tsx and we can import toast provider, and we can now render the toast provider and encapsulate our entire application within it. And I don't think that at the moment we can trigger it in any way, because what we have to do is we have to go inside of the input bar, and then inside of here, after the renderer, let's add toast from use toast, which we can now import from providers toast. And once we have it, we can find our command execution here, and here it is. So now I'm going to add toast here. As simple as that. And let's not forget to add toast to the dependency array. Now what we have to do is we have to go inside of the command menu and go inside of the types of the command menu, and we have to expand the command context and allow it to accept toast, which is basically toast context value, which you can import from providers toast. And now what we have to do is we have to actually make some commands trigger the toast. So let's go inside of commands.tsx, like the new one, and let's add an action context, and now we can access context.toast show message starting new conversation. Let's save the file and let's try it out. So if I click on new, there we go, starting new conversation. And you can go ahead and add a variant here, make it error, and then you will see that in action as well. So this is how it looks like when it's in error mode, and you can also try success mode. Let me go ahead and add success. Whoops. Here it is. Perfect. Works like a charm. I'm just going to bring this back to be a usual one, and then I'm just going to add a bunch of actions for all of my commands. You can do that if you want to, just so all of them are kind of doing something, because we don't really have any actions for them now. So we have login, then we have log out, then we have upgrade, and then we have the last one, which is the usage. So the only one that doesn't have an action at the moment is this one. So now every single one of your command should be showing you something. Great, pretty cool. Now I want to go back to my providers toast index.tsx, and I just want to show you what I meant by this right here. So to do add split border, so I'm not sure if you even notice, but the way this border is rendered and the way this border is rendered is a little bit different. This one is kind of thicker and it looks better. So it's basically the same cosmetic change that we did for this line right here. I purposely left it out to demonstrate that you don't have to add this at all, simply because you need to have border.tsx in your components, which includes this odd character, which I don't really know how you can find except by copying and pasting from my or OpenCode's source code. So I just want to let you know that it's completely optional. You don't need it. But if you want to make the border of the toast thicker, we have to import split border character from components border, split border, my apologies. It's split border like this. And then down here, let's add custom border, characters, split border. Looks like there's a mistake here. Let me just check what I'm doing incorrectly. All right, so I'm just gonna briefly modify the split border that I have here. I'm gonna simplify it like this, and I'm going to rename it to split border characters. Again, you don't have to do this. This is just cosmetics. And once you add this, you should have a thicker line here. If that's something you care about, feel free to do it. Otherwise, the current implementation works just fine. So that is step 1 finished. They are auto dismissing, and we are able to call them through commands using the context. Now it's time for step 2, which is basically the dialog and the keyboard layers. I'm going to start with developing the actual keyboard layer simply because we need some parts of it to develop the dialog provider. So let's go inside of packages, source, providers, and let's create a new folder, keyboard layer. And inside, let's add index.tsx. Let's go ahead and import React, and then create context, use state, use callback, use ref, all from React. And from Open2, we need to use keyboard and use renderer. Let's go ahead and define the type for a responder, which is basically a function which returns a Boolean. And then let's develop the type keyboard layer context value. Now in here, we're going to have push, pop, is top layer, and set responder. Basically a set of functions that will allow us to use this API throughout our app. We're going to use push to add something to the layer. For example, when you open a dialog, we're going to push the dialog to the layer stack so it's at the top of the layer. When we close the dialog, we're going to pop it from the array so it's removed from the layer, so shortcuts no longer work on the dialog. Is top layer is just a handy little util to help us define if something is a top layer, so we know whether the shortcut should be working on that layer. And set responder is a similar helper to help us set a responder. Now let's go ahead and define the keyboard layer context using create context, pass along the type or null. Then let's go ahead and define the keyboard layer provider. The only prop this provider will have are its children, which are a type of React node. And then let's go ahead and define the stack using use state. It's basically going to be an array of strings, and by default, it's going to be an array with a single element inside called base. This is basically the home screen. Now let's go ahead and define the stack ref using ref. And let's go ahead and assign the stack ref.current to be the stack. Let's go ahead and create our responders. And let's make that a map so there are no duplicates inside. So using a map is a very easy way to filter out any duplicates so that doesn't happen. Let's go ahead and define our renderer here. And then let's go ahead and define the push function. So this is going to be a use callback. So I need that. The use callback will accept an ID in the first argument and the optional responder in the second argument. So what happens when the user pushes? First things first, we check if there is a responder being passed. If it is, we're going to add it to the current set of responders. I mean, current map of responders. And we're going to map the key ID and the value of the responder. And then we do a very easy set stack here. And we are going to open a callback here. And basically, we're getting the previous value, or some like to call this the current value, previous, current, whatever. We are going to modify it this way. So we are going to check if the previous value already includes that stack. If it does, just return it. Otherwise, we're going to add it to the list, to the array. So if it includes, we're not going to add any duplicates because we have to do it this way. Because this is an array, we don't have to do it for the responders, as you can see, because there will be no duplicates here. So that's the way we do that, and nothing is needed in the dependency array. And now we're going to do a pop method which is even simpler. So this one only accepts ID. So what element do we want to remove from the layer? And we simply delete it from the responders, and we filter it out from our stack array. Now let's go ahead and develop the handy isTopLayer function. So isTopLayer is a use callback which accepts an ID, and it simply goes through the existing stack. And if the stack is 0, or if the stack dot length -1 is identical to the ID, meaning it's at the top of the array, so that way we can return a true value or a value of true back to this function. Great. Now let's go ahead and add a set responder here. So set responder is going to be a use callback. And in its arguments here, it's going to accept an ID, which is a type of string, and a responder, which is a type of responder. Let me go ahead and open this and an array. If there is a responder being sent, we are going to add it to the current ref, the current map, and map it as ID, and the value will be responder. Otherwise, we're simply going to delete it from the array, from the map. And now let's go ahead and develop a single Control+C handler that walks the responder chain. So this is what will keep track of what should Control+C be doing. That's why we turned it off from the index, right? That's why in here we set it to false, because we're going to programmatically do it now. So first things first, let's immediately close this use keyboard hook if there is no control key being pressed, or if the other key name is not C. But if it is, let's go ahead and load the current stack. And then what we're going to do is we're going to do a loop over the items in our stack in the opposite direction, because we need to go through the top ones. And let's go ahead and get the current layer ID. Then let's go ahead and get the responder for that layer. And then finally, if we have a responder and if it's executable, let's go ahead and do an early return. And finally, outside of here, no responder handled it. Let's go ahead and exit. So what does this mean? What's a responder? So responder is a way for us to define what should Control+C do so let me try and explain. I think I have to go back here. If I open the command menu and if I press Control+C, I want it to close. If I type something in the text area and I press Control+C, I want it to clear. Those are two distinctly different actions. So the way to maintain what happens for each element is by, when we add it, right, when we push it to the layer, we're also going to set the responder for that layer, right? So when we do pop, we're going to get the ID, and then we're going to register a responder with the same ID. And then we will be able to say, all right, so when the user presses Control+C, I want you to do this specific thing. So that's what we're doing here. Okay? We are simply executing the responder. So if we decide that when we mount text area, we're going to set a responder saying, when you press Control+C, I want you to clear the value. That's what I want you to do. I don't want you to close the app, and I don't want you to do anything else. Alternatively, when we open a dialog, we're going to register another responder where we're going to say, okay, when the user presses Control+C, I want to close the dialog. So that's what a responder is. I hope I cleared that up because I kind of went fast through this. My apologies. But I think this kind of cleared it up, right? Basically, whenever we register a new item in our layer, we are also going to register a responder so that we can customize the behavior. But if there is no responder being set, it means we can just close the app because nothing is currently owning the keyboard. Brilliant. And we can return back keyboard layer context with provider and pass along the value prop. The value prop should have push, pop is top layer, and set responder, and render the children inside. And then at the end, let's just have a little hook, use keyboard layer, which will read the context, keyboard layer context. And if there is no context available, it's going to throw an error. Use keyboard layer must be used within the keyboard layer provider. Great. So now that we have that set, let's go ahead and register this provider. So I'm going to go inside of packages, source index.tsx, and around the toast provider, I'm going to add keyboard layer provider like this. So now we can start registering our layer and registering the responders. And now let's go ahead and develop the dialog so we can see this in action. Or actually, maybe it would be a good idea. Let me see. Maybe we can already do this. Let's go inside of source, components, input bar. And let's go ahead and find where we... Here it is, input bar. Let's add use keyboard layer from providers, keyboard layer. Make sure you have is top layer and set responder. And let's scroll down here after, I think we can do it here. So before return, let's do the following. So let's register the base layer responder for Control+C dismissal. So we're going to register using useEffect because that's the equivalent of onMount, right? So when this component mounts, what should happen? Well, let's call setResponder. We're going to register a responder called base. And what I want this responder to do is the following. I want to first check if this is disabled. If it is, let's just do an early return. Otherwise, what I want to do is I want to extract the text area here, and then I'm simply going to check if text area container exists, and if I can read its value, and its length of that value is above 0, meaning something is written inside, the responder should clear the text area, and let's return true. Otherwise, let's simply go ahead and return false. And what's important is that we do an unmount function here. So let's call setResponder base and set it to null. So we clear that. And let's go ahead and add disabled and setResponder in the dependency array. So if I type hello world now and Control+C, you can see it clears the value. And after the value is being cleared, if you press Control+C again, it closes the app because nothing owns the responder anymore. So that is how we're going to develop this. If there is a value and we press Control+C, the responder is right now registered for text area and it clears it. If I press again, it's no longer registered. I mean, it is, but it doesn't match the conditions. What are the conditions? Well, these are the conditions. Text area plain text.length, right? So that's how that is going to work. It could be a good idea to maybe standardize useEffect and setResponder into one hook, like use responder, and then you can easily register components. But I mean, it's just like 2 lines. It's not too difficult. But yeah, that could be a good idea to standardize this. All right, so that's how I demonstrated that. And another cool thing that we can do now is we can do it because of this, because of is top layer. So down here, we are currently only using if not disabled to allow this text area to be focused. But what we can do now is we can combine it, if not disabled and if is top layer base, or is top layer command, like this. So what is the scenario when text area can be focused? If it's not disabled and if the top layer in our layer stack or keyboard layer stack is base. Right now, this is the scenario because the only responder registration we are doing is this one. So it's only base. So now I want to do the following. I want to go inside of the command menu. I'm going to go inside of index.tsx and I'm going to add keyboard layer from provider's keyboard layer. And I'm going to extract down here in the command menu. Let me see. Do I want to do it here? I think, or sorry, no, I don't want to do it here. Let me remove this. Not here. Use command menu. This is what I meant to do. So make sure you are inside of the use command menu hook and import use keyboard layer. Then after the scroll ref, add push, pop, and is top layer. And then what you can do here is you can find where we set show command to true, and then we can go ahead and also push the command layer. And let's go ahead and add a responder here, set show command menu to false, and then pop the command. So that's what happens on unmount, basically. Not on unmount, on like close. And in here, let's explicitly also pop the command. So whenever we open the command menu, let's push it, and then let's pop it. You can obviously see how this can be improved. For example, this is already sketchy. It's magic strings. If I add command 1 here, command 2 here, this is a broken component, so obviously it can be improved and standardized, but I think you get the gist, what we're trying to do. We're adding a simplistic keyboard layer responder chain here. All right, let's go ahead and find everywhere else where we close something. For example, after we select a command, let's also pop the command layer entirely. Let's go ahead and find some other examples. Right here, if we press escape, let's also pop the command. So obviously we could standardize this into a single function called close command menu, and then that will set show command menu to false and pop the command. Feel free to do those improvements. I'm here guiding you through a predefined path to completing this project, but that doesn't mean you shouldn't do any improvements. Obviously, feel free to standardize some things. I'm just going to stay true to my source code so it's easier for me to finish the project. Let's go ahead and see what else we have to do. I think that's all regarding popping. Now let's go ahead and see what we should do next. So instead of use keyboard here, when we define a key, let me go ahead and do this. So when should we do an early return? Currently, if the command menu is not shown, but let's also explicitly listen to the stack. So if the command is not the top layer, we also shouldn't register keyboard shortcuts as well. So that's the thing. This seems super complex because usually you don't think about these things on the web. But what does this mean? Well, it means this. When I open the command menu, I have keyboard shortcuts. These are the shortcuts. But if for some reason command menu is open and also a dialog is open, right now, this is a scenario that doesn't exist because even in the finished example, you can see when I open a dialog, the command menu closes. But let's say that isn't the behavior. What would happen is the command menu would still receive these events up and down, even though it makes no sense because we have a whole, dialog open. So that's why we have to prevent the use keyboard hook from registering any of these if it's not the top layer. All right, that is what we are doing here. And we added a pop command here, and I think that we are good. So now let's go ahead and let me demonstrate something to you. If we go back inside of the input bar and you go down here, And in the focused prop, if you remove this part, is top layer commands, just make it is top layer base. What will happen then is that you can, type here freely, but if I'm correct, once the command menu opens, notice how it's no longer focused. I can no longer type. So this just proves that we successfully created an API that allows us to keep track of what owns the keyboard. It's not perfect, but I think you get the general idea. We have to implement this because it doesn't come built in terminal apps. We have to develop our own responder chain. Great. So just make sure that you are allowing the user to type even if the command menu is open. And now let's go ahead and develop the dialog. I wanted to leave it last so we can kind of take in what we just developed and not just, go quickly through it. I hope it's a bit clearer now why we need it. I will go again through the changes just to kind of clarify, but I think this demonstration kind of cleared it up. Now let's go inside of providers and let's create a new one called dialog, and let's define types.ts in here. We're going to add the React node, dialog config with title and children. And now let's go ahead and implement the dialog provider. I'm going to store that inside of an index file in the dialog. So let's go ahead and add create context, use state, use callback, React node type, text attributes RGBA from open to a core, use keyboard, use terminal dimensions, dialog config from types, and our newly created use keyboard layer. Let's go ahead and define the values. So those are going to be open and close. This is the API that we will be able to use, for example, in commands. We will have context, and then we will do context.dialog.open, or we will have context.dialog.close. So that's what we are doing right now. We are defining the API. So just as we did 3 times already, let's define the dialog context. Let's go ahead and do a very simple use dialog function, which attempts to read the value. And if it doesn't read it, it will warn the user that it must be using use dialog within a dialog provider. Let's define the props, dialog provider props, and let's export the actual dialog provider. In here, I'm going to go ahead and define the current dialog in a state with the options of dialog config or null. This is super similar to toast index.tsx, so feel free to copy most of it if you don't want to type it. I'm going to go through it one by one simply because there are some differences because toast isn't interactive. So for example, for dialog provider, we need push and pop from use keyboard layer. Then let's go ahead and define the close method. So when we close a dialog, we're going to set the current dialog to null, and then we're going to pop the dialog altogether. And now let's go ahead and define the open function. So the open function will accept a prop called config, and is going to be basically title and children. And we're going to set the current dialog to that config, and then we're going to push the dialog layer with a callback of the close method right here and an early return. So use keyboard layer, and in here we have the push, and as you can see, this is the responder. So what happens on Control C, we are going to close the dialog. That's what the second argument in push is. It's a quick way to define the responder. On the, let me go ahead and find. In the input bar, we do it differently, simply because this is the base layer. So we are directly using the set responder API here. Technically, we could do it with push as well, but no, we couldn't. let me tell you why we are using set responder here. I was thinking of maybe changing it, but not. Because in the keyboard layer, what is the default layer? It's base. So if we did push, it would attempt to add base and then base again, which is incorrect. So that's why we are simply registering the responder without calling push. And everywhere else, we are using push because this is only a specific case for base. All right, so now we have close and we have open for our dialog provider here. And we are using set current dialog and then push dialog and a responder. So what should happen on Control C? Close. Great. Now let's go ahead and define the value. Dialog context value, open and close. And finally, let's do a return. So dialog context provider with the value, render the children, and render the dialog component, which we don't have yet, and we're going to develop now. And make sure you pass in the current dialog, which is basically the config, and the close, which controls the layer. So the dialog props are those two, which we just talked about. And let's go ahead and define the function current dialog and close. In here, I'm going to add is top layer from use keyboard layer. And then just as I did in Toast, I'm going to get the dimensions. I'm going to go ahead and open the use keyboard hook here. And I'm going to check if the current dialog is set and if the top layer is dialog. So if either of those is not true, I'm going to do an early return, meaning I shouldn't register any shortcuts because either there is no dialog open or the dialog is open, but something is owning the keyboard above it, right? Maybe an input within the dialog, right? So if I have an input within my dialog and I press Control C, maybe I want to clear that input and not close the dialog, right? So that's why we are doing that check. Otherwise, if the top layer indeed is the dialog, let's register the escape key here and let's close it. Before we render anything, let's check if we can render null. And otherwise, let's extract the title and the children from the config. Let's go ahead and return. We're going to add a box element here with position, left, top, width and height, justify content, align items, background color, and we are using RGBA from OpenTUI Core to create a transparent background color, kind of like an overlay. We are adding a Z index, so it is above everything, and on mouse down, we are calling close, which will automatically pop the dialog from the layer, so we don't have to worry about that. So this is basically what I maybe want to do in the use command menu, because on so many places we are calling set show command menu to false and then individually pop command, and then we do it again here and again here and again here, right? So maybe we should just develop the close one. Okay, let's go back and focus on the dialog here. Z index on mouse down. And then in here, let's go ahead and render another box. This box will control the width, the height, the background color of the actual dialog, because this is just the background, right? Padding, flex, gap, what happens on mouse down, which is just stop propagation. And then let's go ahead and add another box, which is basically just flex box with flex direction row, align items center, and justify content space between. In here, I'm going to add a text element. And then, so this is for the title with bold text attributes. And next to it, I'm going to add an escape kind of indicator. So we can either click on it and it's going to close using on mouse down, or thanks to use keyboard hook, we can press down on that button. And then very simply outside of this box, we are going to add a flex grow to the children. So that's the main content and that's what's going to be rendered in the end. All right, so now that we have that, we have to go back inside of CLI source index.tsx, and we have to add the dialog provider, but be careful. Make sure that you do it after keyboard layer provider, because dialog provider is using use keyboard layer. So if you were to render this above, it would give you an error because use keyboard layer must be used within a keyboard layer provider. Great, so we now have that. What I want to do next is go inside of the input bar. Let me go inside of my components input bar. I want to find my command execution, and besides toast, I'm now going to add dialog, and I'm going to go here where I add use toast, and I'm just going to add dialog use dialog, and I'm going to import it from providers use dialog. Now this is throwing an error because we didn't define the type. So let's go inside of the command menu, types, and in here I'm going to add dialog context value, just like that. And now let me go ahead and replace some of the commands. So in commands.tsx, I'm going to find agents, and I'm going to replace the action. Oh, whoops. I'm going to replace the toast action here with context dialog.open title select mode agent selection coming soon. Then in the models, I'm going to delete the toast, and instead I'm going to use context.dialog.open with select model and model selection coming soon. So if I go ahead and select agents, here it is. And you can see that if I press Control C, that closes the dialog. So let me try. I'm not sure, can I? Okay, I can't. Yeah, I wanted to demonstrate like a multiple scenario. But for example, let me show you why we need the keyboard layer. This is a good way to learn. Inside of source components input bar, I'm going to go down here on focused, and I'm going to remove this. So just if not disabled, okay? Like it was before. Watch what happens when I open a dialog. I can still type behind. This is broken behavior. As you can see, I can do new lines. This doesn't happen on the web, and you don't have to think about it because the responder chain is built in. It's native, it's the basics, right? But it's different here. In here, this concept doesn't exist. So we have to implement this, okay? Before I mark this step as completed, I really want to go inside of the use command menu, and let me just, develop a const close, I guess. Let me see. And in the close, I'm going to go set show command menu set to false. And then I'm going to do pop command. Let me see if that is correct. And can I now just call close? Can I call close again right here? Here. Here. Somewhere else as well, I think. I think that's all of it. I feel like this is cleaner now. So we don't have to repeat this 3 times because it's kind of, I don't want to say unsafe, but yeah. So let's see. This should clear that value. Control C should clear that value. Okay. Basically, a lot of things working properly now. It's up to you. Basically, I would recommend having that close button If you don't want to, you can also, just have these three. Let me see how many of them it is. Set show command menu to false. Okay, so it's three of them, right? So if you want to, go ahead and develop this. Let's go find the first one here, replace it with close, find the second one, replace it with close, find the last one, replace it with close. So now you should have only one set show command menu false and only one pop command. Great. So that is step 3 done. My apologies, step 2 done. And as we explained here, we now have a layer stack where the top always wins. And for example, we have a control C, which now walks down. We are able to quit the app using control C, but if there is a top layer, we are first going to look for the responder of that layer and decide what should happen. And then we're going to go down, down, down until we hit base. And once we hit base and there is no input in the text area, we finally close the app. Now let's go to step 3, the theme system. So I understand that for some of you who are watching this, you're purely interested in the agentic coding aspect of this. So if you want to skip the theming system, feel free to do so. But keep in mind that we're going to develop an important component in step 3. So I would suggest at least waiting until we do that. I'm going to tell you what component that is, and then you will be able to just skip this theming if you don't like it. So what component is that? Well, let me show you a finished example of this chapter. So when I go into theme, I am able to open a dialog which I can search through, I can select, and I can also, of course, well, I said it initially, search through, but I mean type, filter, right? And we're going to use this for various other dialogues, like for agents, for models, for sessions. All of those things will have the same search dialog. So that's the component that we're going to implement. Let's go ahead and do that first. So for those of you who don't want to add theming, you can just implement this component and then you can go to the next chapter. I would suggest at least staying till the end of the video, maybe fast forward mode, just so you don't miss like any important things. All right, so I'm going to go inside of components and I'm going to create dialog search list.tsx. I'm going to go ahead and import all the things from React, then from OpenTUI Core, then from OpenTUI React, then from our keyboard layer provider. And I'm going to stop here. So let's go ahead and set the maximum visible items to be 6. Then let's go ahead and set the dialog search list props to be items, on select, on highlight, filter function, render item, get key, placeholder, and empty text. Then let's go ahead and export function dialog search list. And let's add all of those props with default values for the placeholder and for the empty text. Now in here, I'm going to go ahead and create the selected index state, the selected value state, search value state, the input ref, the scroll ref, because we have to simulate the entire thing we did with the command menu. And let's go ahead and add is top layer. And I'm going to go ahead and add one thing, which I'm going to comment out because we don't have it yet. So we are later going to enable the theme here. Let's go ahead and implement, the handle content change method. In here, I'm going to go ahead and get the current text value through the input ref. And then I'm going to set the search value to be that. I'm going to reset the selected index to 0. And then I'm going to get the value of the scroll box, the container of the scroll box. And if it's found, I'm going to scroll back to the top. Beneath this function, I'm going to go ahead and add a filtered constant. And let me go ahead and collapse this a little bit so it's easier to look at. Here it is. So if we have search value, let's go ahead and filter the items according to that value. Otherwise, just return a list of all the items. Let's go ahead and calculate the visible height using mathmin, the amount of items we have rendered, and then limit by maximum visible items. Let's go ahead and open a use keyboard hook in which we are going to block if the top layer is not a dialog. And then let's go ahead and register the following key bindings. So if the user attempts to select something, let's attempt to find that item. And if we are able to find it, let's simply call onSelect, which is a prop. Then let's go ahead and develop the else if key.name is up. And this is now getting very similar to use command menu. So if you want, you can keep that open simply because we are going to do some similar calculations like this one. So back here, if key.name is up, we're going to set the selected index. We're going to define the new index. We are then going to find the scroll area. And if the scroll area container exists, and if new index is less than scroll top value of the scroll area, we're going to scroll to the new index. And then let's just go ahead and select what is that next item that we should highlight. And if we are able to find it through that new index, let's highlight it. And finally, let's return the new index. And now we're going to do the same, but in the opposite direction, if we are going down. So again, we go ahead and open the set selected index. We calculate what should the new index be. We find the scroll area. And if the scroll area is found, let's go ahead and get viewport height. Let's get the visible end by adding to scroll top value the viewport height -1. And then if the new index we have calculated is greater than the visible end, let's scroll to that new index. Once we have that new index, let's go ahead and attempt to extract an item from our filtered list. And let's go ahead and highlight it. And finally, let's return new index. There we go. So that's the hard part. Now let's go ahead and render the UI. So we're going to have a box, and this box will have an input with input ref, placeholder, focused value, and on content change, calling the handle content change. Now, if the user has attempted to search something for which we have nothing to show for, let's go ahead and render that and indicate that to the user. So we're going to add empty text attribute here. Otherwise, we're going to go ahead and use scroll box with a ref, scroll ref, and height visible height. And let's go through the filtered items until we find the one that our let's go and iterate over the filtered items that the user is searching for. So let's go ahead and find the currently selected index so we can properly highlight it. And then in here, we're going to go ahead and return the box element. let's go ahead and calculate the key using getKey, which comes from the prop. So we're using this function because we don't know what kind of data will be passed here. So perhaps it will be an ID, perhaps it will be a value. We don't know what it is, right? Because there can be many data types that we can pass through this. Then let's go ahead and add the following: flex direction row, height 1, overflow hidden. Let's go ahead and define the background color. So the background color will depend on is selected. If it is selected, we're going to use this, otherwise undefined. And let's go ahead and add an onMouse move function, which will set the selected index. And so which selected index? Well, itself, right? We don't need any prop. And if onHighlight function has been passed, go ahead and trigger it and pass that item along. And then let's go ahead and do onMouse down. And then finally, let's do render item inside. Perfect. So that's it. That is the important component I was telling you about. And I'm just going to add a little to-do here, replace with theme coloring. Obviously, if you don't intend to add themes to this project, you don't have to do that. Great. So we now have dialog search list, which is basically this. So we will be able to highlight on cursor movement. We will be able to calculate when we are supposed to scroll in both directions and kind of select the newest item from the list. And we are automatically able to search as well. So a pretty powerful component. Let's go ahead and see what we should develop next. So we should start with the theme configuration now. So I'm going to go inside of packages, source, and I'm going to create theme.ts. And in here, I'm going to go ahead and define the values for my theme colors, which are going to be primary, plan mode, selection, thinking, success, error, info, background surface, dialog surface, thinking border, and dim separator. And then let's go ahead and export type theme, name string colors, theme colors. And let's go ahead and export an array of themes. For now, I'm just going to go ahead and add the very first one, the basic one, which is what currently exists. The name of this theme will be Night Fox. And then in here, we have to define an array, or should I say an object of colors. So I'm just going to go ahead and paste all of them here. You can pause the screen and copy, or go into the source code, or ask AI to create a color scheme for you. It's surprisingly good at this. It's basically all the colors that I've been using so far in this project. This is like the base theme. All right, now what I want to do is I want to create the hook. So let's go inside of packages, source, providers, new folder, theme. Perhaps I'm going to move this theme to that folder. And let me get index.tsx. And now in here, I'm going to add a couple of file system and operating system and path imports so we can update our preferences file. Let's also add the usual React context things. Let's import the types here. And I believe that we forgot one thing in our theme.ts, and that is export const default theme. And in here, you can basically define what should the default theme be. I'm going to make it be Night Fox because that's the only one that we have. And now we have the default theme set up. All right. Now I'm going to go back inside of the providers theme index.tsx, and I can import default theme and an array of themes. I'm going to define the config directory by joining home directory and .nightcode folder. So it's going to be pretty similar to how most CLI tools store preferences. In the home directory, create a new folder .nightcode. And then inside, I'm simply going to append to that path a file preferences.json. Let's go ahead and define the theme preferences. Theme name will be a string. And then I'm going to define a function to get the initial theme. And I'm going to go ahead and try and get the theme. We're going to try to get the preferences using json.parse, using read file sync, theme preferences path, and using UTF-8 encoding. And I'm going to cast it as theme preferences. And if I'm able to extract something from this file, I'm going to attempt to use that value, preferences.theme name, and I'm going to attempt to iterate over my array of themes, and I'm going to try to find that name so I can find the saved theme. And if I'm able to find it, I'm going to use it. Otherwise, I'm going to fall back to default theme. Or if any other error happens, I will just default to the default theme. Now let's go ahead and create a function to persist the theme. So when user selects a theme, let's go ahead and store it into that file. So how do we do that? Let's open a try and catch. So we're going to do make directory synchronize, config directory recursive true. And then in here, let's go ahead and do write file sync with the theme preferences path. And then the content will be json.stringify theme name, theme.name. Satisfies theme preferences, and then just some additional properties here and encoding. And in the catch here, we need to do try and catch, and we're purposely gonna like kind of let it catch simply because we don't want this to break the app. So we're just gonna ignore any write failures. So theme switching will still work, but only for this session. It's not gonna work it's not gonna persist it basically. Now let's go ahead and define the theme context value with colors, current theme, and set theme. Then theme context. Then let's go ahead and define the use theme hook, a very familiar pattern by now. We've done this, I think, 4 times now, or 3. Then the theme provider props. And then let's go ahead and render the actual theme provider. Let's set the actual current theme. Then a callback to set the theme. So we are going to set the current theme in a state, and we're going to try and persist it. And the initial value of the state is this function getInitialTheme, which is trying to read it from the preferences.json file. Obviously, this is quite easy to turn off. So for example, you can just put, let me see, name Night Fox. I think you can, or maybe not. You can just do themes. Okay, that's not working either. Okay, let's just reset it to this. Basically, I'm not sure how this will behave on other machines because I only tested it on Unix or Mac OS. But, oh yeah, you can just do default theme. You can just do that if it breaks if it doesn't work on Windows or something like that. Great, so we have set theme, we're able to reload the initial theme, and let's just return the theme context provider, wrapping the children and passing along the value of colors, current theme, and of course, set theme. Perfect. Now, what I want to do is I want to create the theme provider. So the theme provider, the theme dialog, that's the one I want. Thankfully, it won't be difficult to implement it because we can reuse the dialog search list. So I'm going to go inside of source. I'm going to create a new folder called dialogs. And in here, I'm going to create theme dialog.tsx. I'm going to import callback, use effect, and use ref, use dialog. We don't have providers dialog? Did I miss that? Cannot find module providers. Did I forgot to export function use dialog? Let me see what I did incorrectly. What I did incorrectly is this should be inside of the components folder. There we go. So make sure the dialogs is inside of components, and then the path is correct. Great. And now we can also add use theme from provider's theme. And that reminds me, I forgot to add it to the index, the theme provider. Let's import our dialog search list. Let's import our array of themes. And let's import the theme type. So what I quickly want to do now is just encapsulate my entire app within the theme provider, but we have to do it carefully because, let me show you, in source index.tsx, the problem is we are already using some colors here. So I'm thinking of a way, because I can just add, for example, the theme provider. Let's add a theme provider. I can add it here, but there is no way for me to like initialize a hook used theme here so I can get the color here. So I have to extract this into its own root. That's exactly what I'm going to do. So above here, I'm going to define a function called themed root. I'm going to import use theme from provider's theme. And then I'm going to copy the contents in here. I'm going to return like this. And I can now replace the hard-coded background color with colors.background, like that. And then instead of this, I can render themed root, like that. Perfect. And let me just check. Okay, let's add the theme provider outside, like this. And let's properly indent all of that. Perfect. So now we have that. So let's go ahead and finish developing the theme dialog. So instead of components, dialogs, theme dialog, now that we have the theme here, we can export theme dialog content. We can add a hook, use dialog. We can then also add set theme and current theme from use theme hook. We can set the original theme ref and give it a value of current theme. So why are we doing this? Well, take a look at this behavior in the final result. When I open the theme dialog, highlighting automatically lets you preview the theme. So this technically calls set theme. But if I cancel, it reverts back. So we need a way to store the original theme, and we are using a ref for that. So we're also going to keep track if the user actually confirmed they want that theme. And now let's add that functionality. So let's revert to original theme if the user dismisses without confirming. We're going to use effect for that. So let's add an unmount function. If the confirmed ref is false, set theme to the value of the original theme ref, which is the value of the current theme that was loaded at the time the dialog was opened. So that is the best solution we can do at the moment. Let's go ahead and implement handle select, which is a callback, which uses the theme config, sets the confirmed ref to be true, sets the theme, and closes the dialog. So even if this unmount fires, the confirmed ref will be set to true, meaning that the user purposely selected that theme and didn't just highlight it. Whereas the highlight function is simply going to call set theme, and then this unmount will take care and make sure that it resets. And then finally, let's go ahead and add a return here. And we can now just use our dialog search list component. So the items that is going to render are going to be the themes. On select is going to call handle select. On highlight, it's going to call handle highlight. The filtering function is going to work in the following way. It will accept the T argument, the theme, the query, and then it's going to get the theme's name, and it's going to see if it includes the query that the user is typing. And we are lowercasing both so we don't make it case sensitive. And now we have to render the item. So how do we render this item? Well, we're going to render it within a text element, and we're not going to use any theme elements here. We just want black and white. And let's go ahead and check if theme.name is equal to original theme ref.current.name. And what do we want to do here? So we want to display that the current theme is selected. So for that, I'm going to go ahead and show this entity, this Unicode right here. So I found a way so that you can write it as well. Like that. And beneath it, render theme.name. Now let's go ahead and define the key, which will be the original theme name, because each theme has an original name, the placeholder, and the empty text. Great. So now we have the theme dialog ready. And now we can go inside of dialogs and create a barrel export here. And inside of here, let's just export the theme dialog content from theme dialog, like that. And now that we have that, let's go ahead inside of commands.tsx, and let's find the theme. And let's go ahead and modify this now. So this is now going to be context.dialog.open. Title is going to be select theme. And the children are going to be theme dialog content, which I can import from dialogs, the barrel export we just did. And if I've done this correctly, it should allow us to open the theme dialog, just like this. And if I search for something random, it will tell me that it doesn't exist. If I Control C, it will close the dialog, just as we developed. And what we have to do now is we have to add some more themes to see if this actually works. So I'm going to go inside of packages, source theme.ts. And what I'm going to do is I'm just going to add all of the themes that I have made for this project. And all of them were done with AI, simply because AI is quite good at randomizing these themes. So I'm just going to paste all of them here. All right, you can go inside of the source code, or just, I'm going to, pause the screen at some random theme and copy it, or just create your own, random theme. So a bunch of popular themes here that are found in various code editors and things. I mean, it's just random hex colors. I don't think they are exactly the same. And that should allow you now to As you can see, for now, only change the background. Why only the background? Because we haven't added the color hook to be used anywhere. But if we've done this correctly, we should now be able to select Dracula, for example. I should be able to exit. And when I do bun run dev CLI, I am still, let's check, using Dracula mode, meaning that the preferences were successfully saved. Now, if you're a Windows user or it simply doesn't work on your machine, you can simplify the theme provider entirely, and you don't even have to call persist theme. You can comment this out, and you can just set the default theme here. You can see that it will work exactly the same. So when I go in the themes, I can change it. But if you exit and re-enter, it won't be persisted. So that way you can avoid all of these write files, because I don't know if this works the same on Windows as it does on Mac OS and Linux. So, choose if that works for you or not. You can see that the moment I bring it back, it reads from the configuration. Brilliant. So what we have to do now is we have to find all the places where we should be using the theme instead of hard-coded colors. So let's start with command menu index.tsx. I'm going to go ahead and add my hook, use theme from providers theme, and in here, I'm going to go ahead and let me see, command menu. Here it is, background color is selected, will now be colors.selected. My apologies, selection. Like that. That's one. Now let's go ahead and go inside of dialogues. Actually, let's go inside of dialog search list. And let's do a similar thing here. So you can see I've prepared myself, right? I'm going to import used theme from providers theme. And down here, again, I'm not going to use this. I'm going to use colors.selection. And then I can remove this to do right here. Great. Now, let's see what else we ought to do. I'm going to go inside of input bar component. And I'm going to go ahead and add to top here. And I'm going to add const theme, use theme, execute. Make sure you've imported it from providers theme. And we can immediately extract colors because that's the only thing we need. We're not going to assign anything else. Let's go ahead and find where we mentioned cyan. And let's replace it with colors.primary, like that. Then let's go ahead and replace this background color here, colors.surface. Then let's go ahead and repeat colors.surface down here when we show the command menu, like that. And I think that is all regarding the input bar. Now let's go ahead inside of the status bar and let's do a similar thing. So const colors, use theme. And let me see, again, instead of cyan, it's going to be colors.primary. And instead of gray, it's going to be colors.dim separator. Let's go ahead and see what else we have to do. Let me close all of these other components. Let's go inside of, let's see. Let's go inside of the providers dialog index.tsx. And inside of the actual dialog function, let's go ahead and extract colors here. So use theme. Make sure you've imported it. And then let's go ahead and find the hex color. Here it is, background color. Colors.dialog surface. All right, we have that. Now let's go ahead and go inside of the toast right here, index. Let's scroll down to the actual toast component, const colors, use theme, and let's go ahead and replace all three of these with colors.success, colors.error, colors.info, so they all match. And let's also find this here and replace with colors.surface. Great. Now that we have that, let me see if there are any left. Let me see, did we do the command menu? Command menu index.tsx. We did. Perfect. And I think that should be it then. You should now be able to open theme, and they should be more vibrant now, more random. Very, very cool. And let me go ahead and just, do a search. Hex code. Looks like we do still have one. And it's this one. It's in toast.tsx. My apologies, toast index. I'm not sure if we have a color for this one. I think we can just leave it as is. I'm not sure. Let me see. Theme.ts. Info surface. I'm not sure. I'm going to leave it as is. Brilliant. So that is step 3 finished. We have the theme provider, keyboard layer, dialog provider, toast provider, and theme root. So a very big lesson in providers and more importantly in keyboard layers. I think this was kind of the most important concept of this chapter. So let's go ahead and review our code now before we merge everything. So I'm going to git checkout b02 UI infrastructure, git add, git commit 02 UI infrastructure, git push -u origin 02 UI infrastructure, like that. And then let's go ahead and open a pull request, UI infrastructure to domain branch. Let's create a pull request and let's review the changes. And here we have the summary by CodeRabbit. So we added a theming system with multiple color scheme options. Users can now switch themes via command menu. We enhanced the command interactions with toast notifications, providing real-time feedback for actions. We added dialogues for theme selection and upcoming features like agent and model management. We improved keyboard navigation with refined focus handling for better command menu and input responsiveness, aka the responder chain. We have a few comments here. Luckily, this time, not too serious. In here, it's telling me this path doesn't exist. So when CodeRabbit makes a mistake, you can actually simply tell it this is a valid VS Code settings, as VS Code itself filled this file from UI input. And once you leave a comment, it will actually remember this and it will not make the same mistake. It will kind of extend its learning. You will see at the end, if we have time, it will answer. In here, it's simply telling me that I have a missing semicolon for consistency. All right, this is a simple one. We don't have to resolve that. But in here, another serious issue here. Well, serious, I mean, it can cause bugs. We are missing dialog in the dependency array. So let me go ahead and quickly see if that is true, which certainly is. Inside of my components, I have input bar. And in here, I have handle command, which now uses the dialog. So yes, the dialog definitely needs to be here. Let's add it here. I'm not going to commit yet, simply so I see what other issues are about. In here, it's telling me that clamp dialog with a positive value for narrow terminals. So the way I tested this with is basically by not caring if the terminal becomes absurdly small like this. I don't really, I'm not going to make this TUI app support that. It expects a normal width. Everything looks broken in a terminal when it's small. So this is not exactly an issue for me. And now what I'm going to do is I'm just going to push this dialog fix right here. So I'm going to do git add, git commit, 02 UI infrastructure fix. And I'm just going to do git push because I'm still in that branch and I already pushed the origin. And what that's going to do is it's going to retrigger code rabbit, and then it's going to tell us that it's okay. And you can see that it responded to that comment of mine that this is a valid VS Code settings, and then it has a learning which is added. So it now knows that this is a valid, officially documented VS Code workspace settings. And you can see that this was automatically set as outdated and addressed in a commit I just pushed additionally. So we can go ahead and merge this pull request now. I'm not going to delete my branch, so I have a history. So I'm going to go inside of here, and you can now see that I can go back to my first chapter, or I can go back to the second chapter. Perfect. We are now on the main branch, which means that we also have to check out main here and then git pull origin main. So we synchronize that merge that just happened. And if you go ahead and simply do bun run dev CLI, and if you have your theme here, you should be able to, well, confirm that you successfully merged main back. Beautiful. Amazing, amazing job. This was a longer chapter, but we added some fundamental components that we need, which we're going to use further on, and we are not going to need to implement them again. We learned some important concepts, and we made our app look really, really good. Amazing job, and see you in the next chapter. In this chapter, we're going to add routing and screen layout to our project. We're going to achieve this in 2 steps. In step 1, we're going to install React Router, and we're going to replace our index entry point with create memory router. And we're going to move all of our provider composition into a new component called route layout. We are then going to use React Router's outlet component, which will allow us to inject these 3 screens within those providers. And the screens that we are going to create are home screen, new session screen, and session screen. And these are the URLs, quote unquote, that we're going to maintain them on. We will also have a very simple navigation functionality. Whenever a user submits using the input bar component from the home screen, we're going to redirect to new session screen, and we're going to demonstrate how we can pass along the data through the router. So we are going to take whatever message the user has sent, and we're going to send it along using the router. And then in step 2, we're going to add UI to the new session component by developing session shell, user message, bot message, error message, reusing the input bar, and finally a spinner, which is another package you will learn how to use. Basically, by the end of chapter 3, you will be able to send a message like this, and you will be redirected to a session shell, which demonstrates all components available like this. Great, so let's go ahead and develop that. Right now, if you run run dev CLI, nothing really happens on submit. Let's go ahead and fix that. So the first step is to install React Router into our CLI package. And while you can find on Bun documentation how to filter installing packages in their workspace, it just doesn't work for me. So what I do is I manually go inside of my CLI package like this. So Nightcode packages CLI, and I simply do bun add React Router. As simple as that. And let's go ahead and confirm. There we go. Package JSON, and I have React Router. Great. So now I'm going to go ahead and do some modifications to my existing components here. So inside of CLI source index.tsx, we have something called themed root. Let's go ahead and copy that. And let's go inside of source. Let's create a new folder, layouts. And in here, I'm going to create themed root.tsx. And I'm going to paste it here. I'm going to go ahead and export. I'm going to import use theme from providers. And I'm going to make it drastically simpler, actually. Let me go ahead and define the types first. So it will be more like a layout as it indicates here in where it is. So let me go ahead and pass this along. Let's go ahead and import the React node. And then let me remove everything from return, actually, because it's going to be simpler than that. And let's just have a box with a background color, with a full width, full height, and flex grow. And then in here, we just render the children, just like that. So that is our themed root. Now what I want to do is I want to go inside of the layouts and create a new file, root layout.tsx. In here, I'm going to import outlet from React router. I'm going to import toast provider. I'm going to import dialog provider, keyboard layer provider, theme provider, and finally themed root. And then in here, let's go ahead and export our root layout. And in here, we're going to do our usual composition. Theme provider, toast provider, keyboard layer provider, dialog provider, and then themed root wrapping the outlet like that. Great. Now that we have that set up, let's go ahead and create the actual memory router. So we have to go inside of source index.tsx. And in here, we can actually remove a lot of things. And let's go ahead. I removed too much, actually. Let's not remove all of it. Let me go ahead and see what we can remove. We can definitely remove the components, header, input bar, the providers. We don't need those. We don't need the entire function themed root. So we can remove all of this as well. So let's just leave create CLI renderer and let's leave create root. And then the imports that we're actually going to add are going to be create memory router and router provider from React router. We are then going to add a root layout, root layout, like that. And let's go ahead and create the memory router here. So this is where we are going to maintain our routes. Go ahead and open an object. So I'm going to go ahead and add a initial path here. And the element rendered is going to be root layout. And then the children of that path are going to be the following. So for the index, meaning for this path, and let me actually replace this with double quotes. We are going to use a specific element, which for now, I'm just going to add a box which says home. I think this works like that. I think this can be box directly. I don't think it has to have any other wrappers, but we'll see. And then let's duplicate this 2 times. And for the second one, I'm going to add a path attribute. And the path attribute will be sessions/new. And I'm going to replace this with sessions/new like that. And in here, I'm going to do sessions/ID. And let me fix this, sessions, and let me fix the key here. Let's make it path. And this will then be session/ID. There we go. So now we have our router. And then in here, we can return router provider, which is a self-closing tag, and give it a router prop. Just like that. Great. So before we proceed, I do want you to see the exact React router version I'm using. Just in case something doesn't work for you, you can use my exact version and have it working, even though I think it will work regardless of the version. So now let's see what's happening in our Banrun dev CLI. How about that? Let me go back to my root. Text must be created inside of a text node. Okay, it is because, yes, that's what I told you, that I wasn't sure if I can render it this way. Okay, one more text. And let's go ahead and end the element here. There we go. You can see that now we just have a text which says home. Great. So now let's go inside of packages, source, and let's go ahead and start creating some screens. How about that? So I'm going to create a new folder, screens, and in here I'm going to create home.tsx. I'm going to go ahead and import header and input bar, and I'm also going to import use callback from React and use navigate from React router. Let's go ahead and export the home function. Let's add the navigate hook. And let's develop a simple handle submit callback, which accepts the text the user has entered and triggers the navigate function to /sessions new, which is something we have registered here, like that. And we're going to pass along a text that the user has entered and submit. And let's go ahead and do a return here. We're going to render a box with all of these properties. And then inside, we're going to add a header and then another box encapsulating the input bar, like this. Now that we have the home screen, we can go back in here and we can import home from screens home. And we can replace this with the home element, like this. And just like that, you should see a familiar screen here. And when you type in hello world, it should redirect you to sessions /new, just like that. So let's go ahead and develop the rest of these screens now. So I'm going to go ahead inside, and I'm going to create new -session.tsx. I'm going to import use effect, use navigate, use location, and use theme. I'm going to export function new session. We're going to add the following hooks here. So navigate, use location, and use theme, from which we can already extract the colors because that's the only thing we're going to need. Let's go ahead and prepare the state using location.state, and let's go ahead and cast an object containing an optional message, or the entire thing being null. It's basically a way to access this right here. So now that we have that, let's go ahead and let's do like a little, I guess, redirect or protection. So let's imagine that this new session screen should only be rendered if we have location state. So if we don't have state message, let's go ahead and immediately return null. And what we can also do is we can redirect away from this, like this. If there is no state.message, let's navigate back to the root page. And usually this would make sense if we had a browser and the URL and everything, but let's go ahead and stay true to the web. So we are replacing the URL so you can't go back to it, right? That's how we are handling the redirect if there is no state.message being passed. So technically this scenario can never happen, but this isn't type safe enough. So we have to do it like this. And then in the return here, what we can do is just a box element containing two text elements. The first one saying create text, and the second one saying state dot message. And let me just see what is going on here. This shouldn't be color. This should be foreground. And let me just see. Oh, no, we don't have to do anything here. I think this will be just fine as is. Let's keep it simple. So that's our new session. We can remove theme entirely from here. And let's go ahead and register that now as well. So now, if I say a message, hello world, you can see I'm redirected to a screen creating session, and I have the text, hello world. Perfect. Now let's go ahead and copy this session, paste it, and let's rename this to be session.tsx. And this one will be, well, drastically simpler. It's just a session function here. Again, we can remove this. So super simple one, and we don't even have a way to access this at the moment. So let's just keep it as simple as it is. It's just going to render the ID that it's being passed here. So let me render session from screens session. So whatever is the ID that we decide to load this component from, we will display it in here. But we currently don't even have a way of doing it. I guess we can try. Let's go ahead and try replacing the handle submit. Instead of being sessions new, sessions 1, 2, 3, 4, 5, 6. And I think that now if you do hello world, you should see session 1, 2, 3, 4, 5, 6. There we go. So just like that, we enabled that. Now let's revert this back to new. And that is essentially step 1 finished. We have a memory router, we have a new root layout, which contains all of our providers and renders the outlet. And the outlet is then injected with all of these screens, home screen, new session, or session. And we are able to submit message and pass along the router state. Now let's go ahead and let's develop the session screen UI. So for this, we're going to need to install one package. So again, I'm going to go inside of my CLI package directly and do bun add open-tui-spinner, just like that. Let me go ahead and show you my package JSON. So I've added the React router and open-tui-spinner. Great. We can now bring this back. Let me go back here, bun run dev CLI. Great. So now we're going to be working on this screen right here. Let me go ahead and close all of these. And, well, we can start by creating all of the components which we're going to need. Let me show you which those are. So this is the finished state that I'm showing you now. When I send hello world, we need a user message, we need a bot message, and we need an error message. How about we create those 3 components? Because currently we don't have them. I'm going to start with the error message. That one is quite simple. So I'm going to go inside of CLI source components, and I'm going to create bot message.tsx. And in here, I'm going to import text attributes. I'm going to import use theme. And let me just see. How about we go inside of components here and change this bot message to be rendered within a message folder like this. And then this import path should be correct. So bot message is within message folder. And let's rename it to messages. There we go. All right, so text attributes and use theme. Props is just going to be a simple message. And let's go ahead and export the function error message. Let's extract the colors from the theme. And let's go ahead and render a very simple box. Inside of that box, let's go ahead and render another box. And let's go ahead and style it a bit. So I'm going to give it border left, border color, colors.error, and I'm going to give it a width of 100%. Then inside of that, I'm going to render another box with all of these content. Be mindful of background color, which is themed. And let's render the text right here, just like that. And this is more than enough, but I think you already know what I'm going to show you. So this will currently show a very, very thin border. How about we render it in new session here? Let me go ahead and render error message. Message will be, oops, like that. So if I go ahead and do hello world, there we go. It's quite thin, but perfectly fine. But if you want to, you can extend it, make it thicker by importing empty border and adding the following attributes to this box with the border. Custom border characters, empty border vertical, and then this weird Unicode and this one. And now it's going to be just as thick as all of these other ones. Let me check. There we go. It's much thicker now. If you care about those sort of things, you can add this. But know that it's completely optional. Okay. And now I'm going to go ahead inside of messages and I'm going to create a barrel export here. So I'm going to go ahead and export error message from dot slash. Oh, yes, this is an error message, not a bot message. Sorry about that. Error message. And if it asks you to update imports, you can select yes. And to fix this, I'm just going to go ahead and attempt to find it again. And in here, I'm just going to end this and start it again. Looks like I'm making some mistake. Oh, it's the new session here. So yes, make sure you update the new session to also read. Well, now it can read from messages directly because we have a barrel export. So we can just change it to that because this is now exporting here. So if I do hello world, there we go. Looks good. So now that we have error message, let's copy and paste this and let's add user message. This one will be quite similar. Let's go ahead and rename it to user message. This box will be identical. This will use colors.primary. This width will be identical, same as the custom border prop. The background color here is identical. And the only thing that's different is there will be no dim attribute on the text, which I believe means we can also remove the import from here. Okay, we have that. Now let's go ahead and develop the bot message. So the bot message will be a tiny bit different. If you want, you can still copy user message and then adapt it. So bot message. Just make sure you have renamed the previous bot message into error message because I made a mistake. It should have been error message, the first one that we did. So bot message, it's going to have two things. It's not going to have just this. It will have content and it will have a model. So let me just go ahead and update that. Colors will still exist. And the first box will be identical, but then the second box is quite different. So let's remove everything inside. So I'm going to add the following. We're going to add this box, another box inside. They have paddings, they're full width, and within just a simple render of the content. Then outside of this box here, let's add another one. Then let's add a flex with some gap. And then in here, I'm going to go ahead and render the following and render the model. Again, I have no idea what character this is. Let me try and find this for you. Here it is. HTML entity is just that. I have no idea. Fisheye Unicode character. So maybe try Googling this and then you will be able to copy it from here and then paste it here. All right, so that is bot message. Let's go inside of index.tsx and let's go ahead and change this to be user message from user message and finally bot message, just like that. Now that we have all three, we can develop the session shell component. So inside of components, let's create session-shell.tsx. Whoops, session shell tsx. And in here, we're going to import text attributes, React node, the input bar, and then let's go ahead and add the props. So it's going to be optional children, on submit, input disabled, and loading booleans. We can go ahead and export a function with those props now. Let's give some defaults to input disabled and loading. And let's go ahead and return. I'm going to go ahead and return a box with flex direction, flex grow, width, height, padding, and some gap here. And then in here, we're going to add a scroll box. And this is one of the coolest things ever. Usually it takes a bit of, trial and error. I mean, it's not difficult, but when you use scroll box with OpenTUI, these two attributes basically allow you to reverse the way scroll box works, which is perfect for LLMs because new content is appearing on the bottom, not on the top. So it's kind of doing sticky scroll in the opposite direction. So if new content appears, like during streaming, it will just automatically scroll for you. So it's saved us so much custom implementation. This is usually one of those things that we would have to do ourselves, like we did with use command menu, for all of this scrolling up and down. But thankfully, with just two props, OpenTUI library does it for us. Amazing. So inside of here, I'm going to go ahead and render the children. And now outside of the scroll box, let's render the input bar once again, pass along the onSubmit and disabled specifically for the input disabled prop. Now outside of that box, rendering the input bar, let's have another box, which is mostly a flex composition with some height, gap, padding, and width. And in here, we are going to go ahead and take up space on purpose because we have space between. So we actually need two elements here regardless. So this is the first element that will be rendered on the left side, and this is the second element that will be rendered on the right side. In this element, we are going to dynamically render something. So if we have loading, let's have a text which says loading. Otherwise, let's render null. But even if we render null, it will still take up space. And in this one, we are simply going to remind the user that they can switch their mode, their agent, by pressing tab, which we don't have implemented yet, but we will when it's time to do prompt config. So for now, let's just leave it like a little hint here. Okay, so now that we have the session shell, let's go ahead and use it. So I'm going to go ahead and close everything. I'm going to go inside of my screens. I'm going to go inside of new session. And in here, I am going to import session shell. I'm going to import user message and bot message. So I should have 4 new components now. All right. And now let's go ahead and do the following. Let's modify our rendering entirely here and render a session shell with a no op on submit, like a completely empty on submit, mark input as disabled, and mark it as loading. And then in here, let's render a user message with the state from the router. Let's render a bot message with content, which is kind of hard coding what an output from AI could be. And just for fun, let's render an error message so we are aware of how our components look like. So now when I do hello world, you can see that I am pretty much at the exact state as I should be in my end result here. So we have the user message, we have bot response, and we have the error message. We have reused our input bar. The only thing we don't have is the spinner. So this is how it's supposed to look like. It's supposed to be a spinner. Ours is just plain text. So let's go ahead and implement the spinner component. It's quite simple, really. We're going to go inside of packages, CLI, source, components, and let's add spinner.tsx. And let's import OpenTUI Spinner React, use theme, providers theme. And there are quite a lot of these spinners. So if you want to quickly test them out and you can't decide which all exist, well, one way is of just, going to OpenTUI Spinner documentation, and then you can see all examples there. But if you quickly want to try how it looks in your app, I recommend going on the home screen and just rendering it here like this, and import the spinner from components spinner. And now you can see exactly how it looks like. So if you go inside of the spinner here, you can see you have the name, aesthetic, and you can see all of these options. There are a lot of them. So you can, select something, save, and you will see how this spinner looks like. So there are a lot of them. Choose some fun ones. I like the initial one. Aesthetic looks cool. Okay, now remove it from home because that's not the place for it. And instead go into not new session, but go inside of session shell component. And then here, instead of the text loading, you will now render the spinner, which you can import from not type the component spinner, which you can import from /spinner. And now if you type in hello world, there we go. Great, amazing. And there is one more thing left to do here, and that is to go inside of screens session.tsx. And in here, we're just going to do a very simple one-line return of the session shell, for now completely disabled. And we can remove use params entirely, just like that. So a completely empty session shell. If you want to see how it looks like, go inside of home screen and change the redirection to sessions 1, 2, 3, 4, whatever. Do hello world, and you will just see a completely empty session shell. Switch back to new, and you should see your new session shell. So what even is sessions new? Why do we even need it? Well, the reason I want to do it this way, whoops, how did I open that? The reason I want to do it this way is because when the user submits something from this screen right here, before we can redirect to session ID, we have to create it in the database. And that can take a couple of seconds. But in a terminal user interface, I think that's a very bad experience. So because of that, we are using sessions new as an, let's call it, optimistic mutation. So the second I hit submit, it looks like it's already working on it, even though this will actually be the screen where it's going to initialize the post request to the database and create a new session in the database, and only then redirect to the actual session ID. And then session ID is going to start streaming the response back to us. And that is pretty much it for this chapter. So this was a simpler one after a couple of long ones, but we did some important things. We set up routing and screens, which we can now, of course, use throughout our app. We learned how to send the state along with the routing, the navigation, and we built a session screen UI. With just a few components, we managed to get very, very close to the end result. So I'm very, very happy about that. So let's go ahead and commit this chapter 3 routing and screen layout. I'm going to go ahead and check out 03 routing screen layout, git add, git commit, routing and screen layout, and then git push origin 03 routing and screen layout. And once we do that git push, we should be able to open a new pull request. So let's go ahead and do that. And since none of the code we actually wrote is complete, it doesn't really make sense to wait for any code review, simply because it's all kind of in a demo state or in a non-working fake state. So we are definitely going to get some comments, but I think we understand exactly what we have to do next. So I would rather we go ahead and merge this immediately and then do a code review when we have actual business logic going on. So just like that, we completed our third chapter. And once we've merged this, we have to go back here. So git checkout main, git pull origin main. So everything is up to date. There we go. You should have no active changes. You should be on the main branch, and you should still have all of the folders you've just created. And you can do one final check by running this hello world. There we go. Exactly as our end result. Beautiful. Amazing, amazing job. And see you in the next chapter. In this chapter, we're going to add server, shared package, and the database package. By the end of this chapter, we're going to have 4 monorepo packages: our CLI, our Hono server, our shared package, and finally, our Prisma client stored in the database package. We're going to start by building the shared package so that we can create the server package using Hono. Our Hono server is going to have the following session routes: get all sessions, get an individual session, and create a session, all with Zod validation coming from the shared package. We're also going to use Hono's app type, or should I say Hono's RPC. So even though we are in a monorepo, we're going to have end-to-end type safety. Once we have our server, we're going to go ahead and add our database, which will include Prisma for our ORM and Neon as our Postgres database. And we're going to build the schema, which will include a session, which has a message, and then some entities like role, mode, message status. Let me go ahead and show you exactly what we're going to have at the end of this chapter. So right now, if I go ahead and run run dev CLI, I can type hello world and I will just see this sample page. But by the end of this chapter, if you type in hello world, this is a new message, we are going to actually store this in the database. You can see how the loading at the bottom has finished, and it has actually redirected the user to the session ID page. And we're going to be able to run server, as you can see right here, and we will be able to run Prisma. And by the end of that, when you create a new message, you will be able to see it in your database. Here it is, hello world, this is a new message. So, and we should also have a session, we do. Perfect. So that's what we are going to have at the end. So let me just close those things and let's just focus on our build at the moment. I want to start by building the shared package, as it is the simplest one to do. I'm going to go ahead and go inside of my packages. And just like I've created my CLI package, I'm going to create a new folder called shared. So I'm not going to bootstrap this in any way because it's just re-exporting some useful things for us. So let's go ahead and create a package.json. and let's create a tsconfig.json. Let's go ahead and do the package JSON first. So in here, I'm going to go ahead and give this a name, nightcode shared. And then let's just go ahead and add a couple of other properties here, like type module, private, set to true. And let's go ahead and also add exports to be source index.ts. Then let's go ahead and add a tsconfig here. So the tsconfig is going to be quite simple. We're just going to extend the base config. So when you control click on this, you should open the base config. All right. Now that we have that, let's go ahead and go inside of our packages and go inside of shared. And in here, I'm going to do bun add Zod. And just like that, you should now have Zod inside of your nightcode shared dependencies. Now I'm going to go ahead and I'm going to create a source folder here. And then I'm going to create schemas.ts inside. I'm going to import Z from Zod. And in here, I'm just going to create a bunch of schemas and some, I guess, inferences of schemas so they can be turned into types, which we're going to use across our app to stream new messages, to validate our API inputs and even outputs, right? So let's go ahead and start with our tool calling arguments. I'm going to refer back to this when we actually end up using it. But for now, I just want us to have this entire file existing here simply because we cannot build anything without it. So I'm going to start with this tool call arguments schema. Basically, a super simple primitive object described in Zod. So we have the explicit key schema, and then we can use it later when we implement tool calling. Now let's go ahead and implement message part schema. So message part schema is going to be a type of discriminated union. So let's go ahead and open an array for that. And let's go ahead and add the first option, which is if type is reasoning. If the type is reasoning, a message is going to have text. Then if the message type is tool call, we're going to have an ID, name, arguments, and even the result. And then if the message type is text, we are once again just going to have text. Basically, what we're doing here is a Zod definition that will help us validate what kind of message is LLM streaming back to us. So is that a reasoning where we have to show the user what the AI model is thinking? Or is it a tool call where it's going to have some arguments like a file to read, a file to create, or a command to run, as well as the result? Was the tool call successful or not? And the ID to keep track of all the tools that we have. So this is actually the only complex thing that LLM can return back when we do streaming. Again, I'm going to come back to this file later, and it will be a bit more clear why we need it. And now that we have a single message part, let's go ahead and export message parts schema, in which we are just going to turn into an array a singular message part. And then from that, we can go ahead and infer a type. And make sure you're using message part, not message parts, because that's incorrect. So message part schema. Now I'm going to go ahead and once again define all the tool calling arguments that can happen during the chat stream event. So that is once again going to be a discriminated union. Let's go ahead and give it the first type, which is text delta, which only has text. Then we have reasoning delta, which also only has text. This is basically this, right? Reasoning and text. And then we're going to go ahead and define the tool call. Tool call will have tool call ID, tool name, and arguments, which are basically what we defined above, tool call arguments schema. Then let's go ahead and define the tool result type. We're going to have tool call ID and the result. Then let's go ahead and define done, which will have message ID and duration in milliseconds. And finally, let's go ahead and grab the error type, which will have a message. So what are all of these types? These types are what's possible to receive back from Vercel's AI SDK. So that's why they are more thorough than this, which is basically what we are going to keep track of. This is what we care about, right? And this is everything that Vercel's AI SDK can return. And we are going to need this in XOD form so we can easily parse against in a, should I say, industry standard way. So we don't just have to do JSON parse and then check if we have message ID and duration and then guess that that is a done type. So this will be much easier to work with in the future. And last thing, let's just export type chat stream event, which will infer chat stream event schema like that. And once we have schemas defined, let's go ahead and define our models. So what models can we work with? That's what we're going to define in the shared package here. Let's go ahead and define a type called model pricing. So we're going to keep track of input in US dollars per million tokens and output in US dollars per million tokens, because that's kind of a standard way of doing pricing for LLMs. Let's go ahead and create a type of supported provider. For now, we're just going to make either Anthropic or OpenAI. Later, you will be able to extend this and add Google and add Mistral or whatever, right? But let's keep it simple. These are the two most popular ones. So that's what I'm going to teach you how to support. Let's create a type for a supported chat model definition with ID, provider, and pricing. And this supported provider has to be used here, and model pricing has to be used here as well. Now let's go ahead and export an array of supported chat models. So in here, we are defining which chat models we are going to support for our agentic coding CLI. So the first one will be an ID, Claude Sonnet 4.6, provider Anthropic, and then we define the pricing. So I grabbed the pricing from their official pricing table. Keep in mind that I optimized this so that we are kind of always, I mean, when it comes time for us to implement billing, what I imagined is that we always stay profitable in a way, because it will actually be cheaper for us to run certain models simply because there's a concept of prompt caching, which we are not going to provide to our users, but our providers are going to handle for us. So technically, we're going to have it cheaper than our users, which is good for us because we are going to have a bit higher margins. Then in here, I'm just going to keep adding some models that I want to support, like Clyde Haiku, Anthropic, again, some pricing I extracted from their table. Then let's add Opus 4.6. Then I'm going to add some OpenAI models like GPT 5.4, GPT 5.4 Mini, and finally 5.4 Nano. And now, to not break this, let's go ahead and to not break this, to make sure that we don't add anything that we are accidentally not supporting, let's cast as const satisfies read only supported chat model definition, and then an array of those like this. So if I, for example, do Google here, you can see I have an error, right? The only thing we have to keep track of is the IDs, because the IDs cannot be confirmed. Well, they can, but the thing is, you will simply receive an error from Vercel AI SDK if you use something that isn't supported, but they don't exactly offer you the types for this, or more accurately, this can change. So you just have to keep track of what exists. This is kind of stable. This should always exist. But, there are like snapshots, I guess, like 2025, and then some month, and then some date. You've probably seen things like that. So that's why I tend to just add the simplest IDs, because these should always be available. All right, we have that. And then let's just go ahead and export a couple of useful types here. For example, supported chat model is going to be a type of supported chat models, and then simply one of them, right? So when we hover over this, you can see exactly which are our options. So later in the project, when we are verifying whether we are allowed to send a specific model and provider to Vercel's AI SDK, we are going to type check it against supported chat model. And if it's not in here, we simply don't allow it. And then let's go ahead and export type supported chat model ID. And let's create a simple function here, find supported chat model by the model ID. And finally, let's export the default chat model ID. Make sure it uses the proper type. So if we type something incorrect, we get an error. So I'm going to use Opus 46 as my default type here. Great. So we have now developed the models and the schemas. And now let's go ahead inside of source, index.ts, and let's re-export all of that. So from models, we need all of these things and types exported. And from schemas, we need all of those as well. So every single schema and all of the types. The reason we are doing this index here is because in package.json, we made sure that that is what we are exporting from this package. Great, so we have shared the package fully complete. So now it's time for us to develop the server package. Let's go ahead and scaffold the server package now. So inside of packages, I'm going to go ahead and create server. And then here, let's go ahead and create tsconfig.js. My apologies, tsconfig.json. And inside of here, let's just extend the base config. Then let's go ahead and create a package.json here. I'm going to open my shared, and I'm going to copy everything in here and paste it here. And I'm just going to remove the dependencies and the trailing comma. And for the package.json, what I really want here is first to change the name to be server. Private is true. Exports can stay the same. And yeah, let's just leave it at this for now. And then what I'm going to do is add Hono here, but also I want to add my shared package to the server so I can use these types of models and schemas I've created. And the way we do that is by adding dependencies. And then inside of dependencies here, I simply add nightcode/shared. And I simply make it use workspace like this. And then if I go ahead in the root here and run bun install, it should take care of it. Okay. So how do we add our Hono server here? Well, we can do that quite easily just by looking at Hono documentation. So in simplest terms possible, Hono is a fast, lightweight, I guess, Express.js alternative. I really like working with it. Whenever I need a server, I reach for Hono over anything else. And I really like its RPC, which you're going to see as use in this chapter. The reason I'm stuttering is because I see this new thing called LLM, and I just wonder what it is. So it's just the documentation. Okay. So how do we get started? Well, super simple. You can just click on Bun, which we're using. So they offer this, but since we are kind of using an existing project, we can just install Hono right here. So that's exactly what I'm going to do. Let's go inside of Packages, Server, Bun, add Hono, and you should have Hono installed, just like that. And then let's go ahead and add scripts here as well. So after exports, I'm going to add scripts. So our dev is bun run hot source index.ts. All right. And then let's go ahead and add this simple hello world here. So I'm going to go ahead and create source. And inside, I'm going to create index.ts. And let's just paste this and save the file. And then let's go ahead and do, so I am inside of packages server. Make sure you are here as well. And let's do bun run dev, and that should start the server at localhost 3000. And if you visit it, you should see hello bun, just like that. If you change this to hello bun hot reload and save, it should immediately reflect. So just refresh your browser, but you can see that the server is automatically refreshed. Brilliant. So that is all it took really to set up our server. Now let's go ahead and just add some more packages here. So make sure you are inside of your server here. Let's go ahead and add Zod. And let's go ahead and add @Hono Zod validator. So you should have Hono Zod validator and Zod itself. Great. Now that we have that, what I want to do is I want to make us able to start the server from the root. So let's go inside of our root package JSON here. Let's duplicate this script. Let's add a trailing comma here. I mean, just a normal comma. And let's run dev server. And for this, I'm just going to go ahead and change this to be bun run hot packages server source index.ts. I think this should be good. Let me check. Bun run dev server works. Perfect. So you might be wondering, why am I just not invoking the bun run dev command of each package respectively? You can do that, but I found it behaves odd when you add environment files into the mix. So because of that, I'm running it this way to kind of preserve the directory from which I'm running it. If you feel like this makes no sense and you want to do it just by like calling the packages bun run dev, you can do that. Also, you can also use watch or hot here. Honestly, I'm not sure what is the difference, but both are doing exactly the same. Let me try and do bun.com and maybe search here in the docs --watch. Watch a directory for changes. So that's watch mode. Okay, and --hot is hot reloading. I don't know. The documentation for Hono says to use hot, but I'm not even sure what the documentation for OpenTUI says, but this is working for me, so I'm just going to keep it this way. If you run into problems, try switching into watch or hot. Great. So that is what we need to start building the API. So what I'm going to do next is the following. I'm going to go inside of packages, server source index.ts, and I'm just going to change things up a bit. So let me go ahead and change this like this. So Hono, then let's go ahead and import HTTP exception here. Let's go ahead and change the app to initialize new Hono. And then let's go ahead and define the general on error here. The reason we are capturing on error is because I want to standardize all error messages which are being thrown so that I know how to display them in my CLI. So I'm just kind of making a structure that I want to work with right now. So that is if error is an instance of HTTP exception. Otherwise, let's log the unhandled error, and let's go ahead and return the following. All right. Now, what I want to do is I want to define the following. Instead of returning app, I'm going to do port 3000, fetch app.fetch, and idle timeout to this amount. The idle timeout is actually super important here. Let me go ahead and add a comment here. Idle timeout must be high, otherwise LLM tool calls might not complete. That's what happened in my initial build. The LLM was simply unable to complete any complex task because when it used grep or anything else to like search through the files, it kept timing out, and I couldn't figure out like what's the problem until I came across this. So you need idle timeout. Okay, and now let's go ahead and define our initial route, which will be called sessions. So I'm going to go ahead inside of source here and create our routes, and I will add sessions.ts. In here, I'm going to import Hono from Hono, HTTP exception, Zod validator, Zod itself, and then I'm going to use Nightcode shared to import find supported chat model. And you can see that when I control click on it, I get redirected to my package. So this is properly linked through the workspace tag right here. Great. For now, we are not going to have any database just yet. So let's define a mock message with ID, role, content, mode, model, status, parts, duration, created ID, and session ID. And let's go ahead and create a type for a mock session as well with an ID, title, the path, user ID, created at, and messages, which is an array of mock messages. So later, we're just going to replace this with real database. Let's go ahead and create an in-memory sessions table, I guess. Let's go ahead and create a primitive ID kind of assigner here. And now let's go ahead and create our sessions schema. So create session schema is going to be a Zod object. And what we are going to accept is the following. We're going to accept title. We're going to accept the path. And then we're going to have the initial message. And the initial message will be another object. And that object will have the role, content, and mode. And finally, we're going to have model. And we can do a cool thing with Zod, which is a refined chain, which can then call functions like this. So we are basically going to break in runtime if the supported chat model is not found. So if someone attempts to make a post request and attempts to kind of pass a model that we are not supporting, we're not going to have our API fooled. Instead, we're going to return back an error. Hey, we do not support that model. So that's a cool thing you can do with Refine here. All right. And the initial message itself will actually be optional. So let's just chain that as well. Now let's go ahead and create a very simple create session validator, which uses zvalidator, passes in the type, which is JSON, then defines the schema to use, which is create session schema. And in the third argument is a callback with the result or with the result and the context. So if the result is not success, meaning the create session schema has failed, which can be either because this is not passed as a string, this is not passed as a string, or maybe the scenario I was talking about, unsupported model was passed. So the model right now can only be this one or this one or this one or this one, right? That's what we are doing here. We are protecting our API from unwanted models. So this is the validator. And now that we have the validator and we are throwing properly structured errors if Zod fails, we can go ahead and create some routes. Let's start with a very simple get route. And in here, what I want to do on get is just load everything. So what I'm going to do is I'm going to go over my sessions. So sessions.map, I'm going to get ID, title, created at, and I'm just going to immediately return an object for every single session with the ID, title, and created at. So I'm basically going to use this sessions array right here. All right, we have that. Then let's go ahead and create another one right here. This one is basically used to get an individual ID. Oh, and I forgot to return the result here. Return c.json result. There we go. And when we want to get an individual session, the first thing I want to add is I just want to add these mocks so we can then later easily test an error or an exception. Let me show you how that looks like if it's hard to read through the comments. I'm going to collapse this so it's easier to see. So we are basically throwing a new exception here, mock error session loading failed. And in here, we are simulating a loading of 5 seconds. So I'm going to comment both of them out. So later we can easily try them and see how our UI behaves. So when the user wants to load an individual session, we have to extract the ID from the URL params. And then for now, we are just going to use sessions.find and let's match the ID. So this is just all mock now because we don't have the database yet. I just want to create some working example. And then let's go ahead and do the following. If there is no session, let's return c.json error session not found and back a 404. And let's go ahead and return the session. Now let's go ahead and create this, which is basically the endpoint to create a new session. In here, I'm going to copy this mock so I can easily test if session creation is slow and how it looks like. Then from here, I'm going to go ahead and extract initial message and then the rest of the data from cRequest.valid. What this is basically doing is not just reading your normal cRequest.json, but instead is using a validated version of JSON through the validator. That's what's really cool about Hono. It has really, really nice developer experience for us. So we now know that the initial message and whatever model is passed here has to be one of the refined models we have made a rule for here. So at this point, we can very safely use whatever the initial message is, and we don't have to worry. So let's go ahead and mock ID increment here. Let's go ahead and mock the date creation. And let's go ahead and assign our mock messages. If the user passed along the initial message, in that case, let's go ahead and push that to the message array. Now, inside of this push, we have to define everything we need. So let's increment the ID once again. Let's go ahead and add role, content, mode, model, and model. Let's go ahead and add status as complete. And then let's go ahead and add parts, duration, created at, and session ID. Now let's go ahead and create the actual mock session. So mock session has ID, title, path, user ID, hard-coded to mock user, created at, and messages. And then let's just go ahead and push this new session here. And let's go ahead and return c.json session with the 201 code. And let's export default app. Now that we have our sessions API, mostly mocked, but it will be an easy change later on. Let me just check. Okay. This HTTP exception is unused because we commented it out. Okay. So now that we have developed this sessions.ts, we have to go back inside of source index.ts. And in here, let's do const routes. app.route and then /sessions. And let's simply get the sessions. We can get the sessions from .routes sessions. Just like that, we have registered to our app all of these. So get, this is basically registering as sessions. This is sessions ID, and this is sessions post request. And now that we have the routes here, in order to use end-to-end type safety, what we can do is we can define an app type, which is a type of routes. And then when you hover over, you can see that we get an RPC, a fully type-safe way of communicating with the Hono API. And we will be able to import this, because we are in a monorepo, we will be able to import this through dev dependencies in our CLI package. And then our fetch requests are going to be that much more secure, simply because we're using the app type. So we're going to know exactly what input something takes, like the param has to be the ID, what output looks like. So we know exactly what kind of error to show to the user. We basically know everything through this super simple type of. That's another really cool Hono feature. And besides this, you can also use open API specifications. Great. I think that already we can try this. So if I go ahead into sessions, you can see it's a completely empty array. If I try sessions 1, 2, 3, 4, I get an error session not found. Perfect. So it's actually working. Really, really cool. Now, what I want to do is I want to how do I say this? I want to connect it to our front end, even though it's currently in a mock phase. I want us to be able to at least try and create some sessions. So when we visit sessions, we can at least see an array of some sessions. So we can see how our server and our CLI package is connected and how we are both using the shared package here. Let's go ahead and start instead of CLI, source, and let's create a new folder called lib. And in here, I'm going to create API client.ts. And in here, I'm going to import HC from Hono client. And then I'm going to import app type from Nightcode server. And then I'm finally going to go ahead and export the API client, which is basically going to use the Hono client. We're going to give it the type, app type. And we have to pass in the API URL. And if we don't pass it, I'm just going to fall back to localhost 3000 because that's where we are currently hosting it on. Great. So now that we have that, let's just go ahead and ensure that we have these packages in our CLI here. So let's go inside of CLI package.json. And let me see what the situation is. So the first thing I'm going to do is just add Nightcode shared in my dependencies here. Here it is. So Nightcode shared. Then I'm specifically going to add in dev dependencies Nightcode server. Now there is a reason I'm adding this to dev dependencies and not dependencies. Both would work just fine. The only difference is when you build it, right? So right now, the only reason I need my server package added to my CLI package is because of the app type. So this can technically be avoided during build. So because of that, so we don't unnecessarily bundle entire Hono, even though Hono is extremely lightweight. Why would we bundle our server into our CLI build if we don't have to? So I'm using a kind of a trick, I guess, so that our CLI package only imports it as a dev dependency. So during the build, it actually won't be bundled. That's why I'm adding server to dev dependencies. Okay. Now let me see what else I have to do. In my CLI, I'm going to go ahead. Let me see, what do I need to add? I have React Router. I think I need, okay, let me just go inside of CLI. bun add, we're gonna add Zod. And I'm also gonna add Hono, simply because I need Hono client. Let me go ahead and check. Yes, I need Hono client. So because of that, we need Hono installed in the CLI package. So kind of ironic because I just said we don't want to bundle Hono from a server, but I think you get what I mean. It's just safer to not couple these things together if they don't have to be coupled, right? That was kind of my point. Hono is extremely lightweight. Even if you bundled it, it wouldn't be a big deal. But, I think it's just better if we do it this way. So to conclude, in your package JSON, in dev dependencies, you should have Nightcode server from workspace version. And in your dependencies, you should have Nightcode shared from workspace. You should have Hono. And you should have Zod added, specifically talking about our CLI package. And I think that is all we need right now. So let me go ahead and focus on developing some more libs here. Instead of CLI lib, I'm going to go ahead and create HTTP errors.ts. Let me go ahead and add the error response type. And then I'm going to create a useful function here, which will help us extract the error message every time we receive our response. And that's going to be a lot of times. So let's go ahead and add this in a try and catch method. In the catch method, I'm simply going to add a comment to ignore invalid error payloads and fall back to the status text, which we're going to write in a second. And in the try method, I'm basically going to attempt to await response JSON, and I'm going to cast it what I think it's going to be, an object with an error inside. And then I'm going to add an if clause, and I'm going to check if it actually is data.error, and if it's a type of string, and if data.error is greater than 1, in that case, it's safe, and we can return it, we can use it as the error. Otherwise, let's go ahead and try to use response.statusText. But if that fails as well, then I'm just going to hard code it with request failed with status and then response.status. So I'm purposely wrapping this in try and catch so that this await, even if it breaks, doesn't break the entire CLI. We're just going to fall back and say, hey, something happened. We don't know why it failed, but we don't break the app. All right. Now, let's go ahead and see what we have to do now. So I want to amend my new session now. What do we need to happen? Right now, when we do this, whoops, let me go ahead, go back a bit. So bound run dev CLI in the root. When I do hello world, what I want to do is I want this screen, the new session screen, I wanted to invoke a post request and then use the router state of my message as the initial message. And then it will create a new session in this array and then redirect me to sessions ID page. Okay. So let me go ahead and see where we have that. In CLI source, we have screens, new session. So yeah, home, I don't think it has to be amended at all because home is doing all it needs to do, redirecting the user to sessions new, and there are no post requests being fired here. So the only post requests that are going to happen are inside of the new session. So because of that, let's go ahead and extend our imports from React here by adding use memo and use ref. Then I'm going to go ahead and import Zod. Then from Nightcode shared, I'm going to import the default chat model ID. I'm going to go ahead and remove bot message, and I'm going to remove user message because we're no longer going to need that. And then let me go ahead and add some more imports here. So let's add use toast, API client, and get error message. We created these two in this chapter, and this one is, I think, from like first or second chapter. However, you should have all of them. Now let's go ahead and create a new session state schema so we can properly validate this state right here, because We didn't do this initially because we didn't have Zod, but now that we have it, we can have a bit more industry standard checks other than random ifs and castings and just hope for the best. Let's go ahead and add the toast hook here. Let's go ahead and define the has started ref so that we can cancel double requests if they happen, because we have to do this from use effect, which is basically on mount. Let's go ahead and remove this state and let's replace it with a use memo. So it's a bit more memoized and better quality, because now instead of blindly hoping for the best, we are simply going to parse the location.state against new session state schema. And in here, we define what we expect. We expect a message. So if the home screen sends message to, this will simply fail, because safe parse will not allow it unless we change message to here as well. So make sure you're passing message from home. Make sure you're validating message in new session. Now that we have parsed, let's go ahead and simply check. Did parsed return with a success or not? So return parse.success, parse the data, otherwise return back null. And we have to add a dependency array, location.state. Great. Now let's go ahead and do a simple check here. Let's add a guard. Basically, if we somehow got navigated here without state, let's immediately go home. So for that, we can use this use effect. And let's just quickly check if there is no state. Let's just go ahead and return back home, just like that. And now let's go ahead and create the session on mount. So this screen specifically exists to do this. This is like an optimistic mutation, you could say. So the user rather hangs, because we have two options. When user hits hello world, we can either make them wait on this screen. So user hits enter and they just have to wait here with like a loading indicator here. Or we can give them a feeling of it already streaming. Okay, well, a bad example now. Let me just quickly fix this. Okay, I have to close that. Basically, you get what I'm saying. I'm picking the better option of the two. So let's create this session on mount. So again, we need a use effect here. And let's again check. If there is no state, or if has started the ref is true, meaning we already did this because we immediately set it to true. So if it already fires once, it will not fire twice. Let's go ahead and set another variable ignore to false. And then let's go ahead and create our create session function. The create session will be an asynchronous function, and it's going to have a try and catch inside. So let me go ahead and expand both. So inside of try, what we're going to do is we are going to attempt to get the result using await API client. And what's cool about API client is that we can traverse through our Hono API using type safe, SDK, you could say. You can see I can call sessions and I can choose which request I need. For example, I need a post request here. And then I can open options and I can select JSON. And in here, you can see I have autocomplete. I need the title. So what should the title be? How about we use the first 100 characters of the message the user has sent? Now for the path, let's go ahead and pass process.cvd. And for the initial message that we want with this session to be created is simply going to be the following. We're going to pass along the role to be user. We're going to pass along state to be message, mode to be build, and model to be the default chat model ID. So right now, we have no way of configuring any of that, so we're just going to leave it at that. So once we have the response, first things first, if we have ignore set to true for whatever reason, let's do an early return. And then let's go ahead and check if for some reason response was not okay. Let's immediately throw new error and let's go ahead and parse it through our get error message, which is simply going to check various ways of making this a structured error. So after we do that, we can finally get the newly created session. You can see it's type safe and we see exactly how it's going to look like. And after we have that, guess what we can do? We can navigate to sessions, session ID. So let me go ahead and collapse this so it's easier to look at. So we're using the navigate function and it will redirect to sessions, session 1, 2, 3. We're going to use replace true and we're going to pass the session through router state once again. And in the error, let's go ahead and catch that. Again, if ignore is present, let's return. Otherwise, let's go ahead and trigger a toast message, which will show a variant of error. And in here, it's going to simply show an error, failed to create session, or if we can read from the message directly. And if that happens to actually fail, we cannot leave the user on this new session screen. So let's make sure that we navigate back to the home page. Brilliant. So now that we have create session function defined, we have to call it. So right here at the bottom, let's simply call create session. And what's important is that we create the following. We have to do an unmount in which we set ignore to true. So the reason we need this is because create session, let's say it takes 5 seconds, and in the meantime, this component gets destroyed. We have to prevent anything from happening by adding ignore set to true. So even if we get an error, let's just do an early return, either in try or catch, because otherwise you would get invalid React usage, you could say, like an anti-pattern. You need to cancel your requests during unmount. And in the dependency array here, let's go ahead and let's add state, navigate, and toast. We now no longer have to check for the message. We can just check if there is no state, because if it's not properly parsed, it's going to be null. And we can now remove the bot message and the error message, and we can just show what the actual user sent. Brilliant. So this should actually work already right now. So my localhost 3000 sessions, let me refresh. Oh, couldn't be reached. Oh yeah, so let's try this. If I do hello world now, you can see I'm getting an error, unable to connect. Is the computer able to access the URL? And if I go ahead and do run dev server now, and it's running on localhost 3000, and I do hello world, you can see that now it's a completely different thing. The only thing I'm noticing is that my user message is not being shown. So I'm not really sure what's happening here. I think I know what's happening here. I think it's actually all good. I think it just redirected me to session ID screen, and that screen is not fully developed. But you can see that localhost 3000 sessions now has its first session, hello world. Really, really cool. So if I go ahead and end this and try again, and in here I do what is up, again, I'm going to get redirected here. And if I refresh, here it is, another one, what is up? Really, really, really cool. So let's go ahead and make the new, not new, let's make the session ID screen make sense now as well, because session ID now has to fetch the session by the ID. So let's go inside of session.tsx. You can see, yes, this is a completely empty session shell. So let's go ahead and make it actually fetch things. So besides the session shell, let's go ahead and add all of these from React. Let's add use params, use location, use navigate, z from Zod, and infer response type from Hono client. Then in here, let's add all three, which is the user message, bot message, and finally the error message. Then let's go ahead and add the use toast, API client, and get error message. Perfect. So we need all of those. Now let's go ahead and create a type, session data. We can use infer response type, and then we'll go through type of API client.sessions, and then we get the ID path, and we are specifically looking for the get request. So what is this super complicated thing? In the simplest way possible, we need the type that our server routes session returns for, where is it? Get ID, right? So we are creating the type so that we know exactly what will be returned. Okay, so we are using infer response type for that. And then we are reading through API client sessions. We are specifically choosing the session ID route, and then specifically the get one, the get request. And in here, you also have to specify which return code, because it can have multiple variations, right? So it's a very specific way to get the type that you need. Now, let's go ahead and define a constant, session location schema, which is a Zod object. The session is going to be a custom Zod rule. It's going to use the session data from above. And in here, we are going to make sure that it's not null and that the type of the value is object and that it has the ID inside. Now that we have that, let's go ahead and create a handy component called chat message. Now, chat message will be used to determine whether we should display the user message, bot message, or the error message. For that, our chat message needs to have proper types. So it will receive message. And let's go ahead and create the type for this. So I'm going to go ahead and open this. Message type is going to use session data, and then it's going to infer through messages. And then simply to select like an individual type of this array, you just type in number like that. And then when you hover over message, you can see that you see the exact type of the message that we need. Now in here, let's go ahead and check for the role. So if message.role is user, we can go ahead and return the user message. Let me just go ahead and properly do this like this, user message, and pass along the message. We don't need to do else if, we can just do this 3 times. The reason we can do it like this is because it will never be both user and something else. And we are using return, which ends the else if chain. So we can do if. I just think it's like cleaner this way. If it's error, let's go ahead and use error message. And then for the last one, we don't even need an if clause. That's just going to be like the default state, which will be a bot message, which uses content prop and model. So let's go ahead and pass it message.model. There we go. So that is our handy chat message component. Now let's go ahead and properly develop this session here. So we are going to need the ID from the params, the location, navigate, and toast. Now we have to go ahead and prefetch the value here using memo. So inside of here, what we are going to do is the following. We are first going to check if we can safely parse the location state. If you forgot, the location state is what we receive from new session. So when we create the session on mount from new session, what do? We redirect to sessions, session ID, and we pass along the newly created session from here. So the first thing we have to do here is that's what we call prefetched, right? Because there are 2 ways user can navigate to this page, the session page. The first one is if user opens up a sessions dialog, and simply selects one of the older sessions. In that case, we are not going to have this, okay? But the other way is that the user receives a redirect from new session with the state. Technically, we could make this simpler and not pass this at all and just load from the ID. We could technically do that. But why make the user wait twice? We can prefetch. So let's do it. So this is all it is. We're just checking if we successfully parsed whatever has been sent to us through location state. Basically, if parsed, is a success, it means that the session ID screen was loaded through the new session redirect because it's passing along the session here. And of course, very important, we need to pass this here. Great, so that is prefetched, and then we can go ahead and establish our session here and set session, use state session data, and give it an initial value of prefetched. So yes, technically, we could not have this at all and just make this null, and then every single time just fetch it here from the use effect. But that's making the user wait twice, because technically, we created here in the new session. This is technically fetching it. Why wouldn't we just pass it along and call that a prefetch, right? That's what the prefetch is doing here. I hope that kind of cleared it up. Now we do the usual path, right? The user loads this screen by simply selecting one of their older sessions. So in that case, first thing we do is we check if this was already prefetched. If it is, let's do an early return. So that's for the scenario above. Otherwise, let's go ahead and reset the session by using set session null. Let's go ahead and do another early return if the ID is missing. Let's prepare for unmount by adding the ignore variable. And then let's start developing the fetch session asynchronous function. As usual, we're going to have our try and catch here. Let's go ahead and start with try. So we are going to use our API client, sessions, ID, get. And inside of here, we can use our type safe configuration by passing along the param. Which param? The ID. If you try to, for example, pass ID 2, you can see you get an error here. Why? Well, because in our Hono, we specifically look for ID. Unless you change this to ID 2, you can see that now this is correct, but then you also have to change it here. You can see how cool this is, right? The moment you save it, the moment the entire app type resets. That is basically why I really, really like working with Hono. It's lightweight, it's fast, and it's really cool to work with. Now let's go ahead and handle the case if this component has unmounted. So do an early return. If the response here, the request has failed, meaning not okay, throw a new error and go ahead and parse it through get error message, which we developed. Otherwise, we can go ahead and set session to the result of await rest.json. If you want to, you can make this into constants like fetched session, or maybe better, resolved session, like this, or resolved. There we go, like that. And in the error here, first things first, we check if the component has unmounted. If it did, let's do an early return. Otherwise, let's go ahead and do a toast show variant error, and then go ahead and check what kind of message we can throw here. And if we do receive an error, let's navigate the user away from this screen back to the home page by using navigate / and replace true. And once we have that, let's not forget that we have to call fetch session. And of course, we have to make sure that we are properly unmounting by doing this. Let's not forget to pass along ID, prefetched, toast, and navigate. Now let's go ahead and do the following. If there is no session yet, let's return an empty session shell with nothing to submit for and input disabled. Otherwise, we're going to go ahead and still have a completely empty session shell, but this time it's not going to be loading or anything, and it's not going to be a self-closing tag. So let me just change this. Cool, it did it for me. And inside of here, I'm going to go ahead and iterate over each session message, and I'm going to use my chat message component, so it's going to determine what component it should render. There we go. So basically, now this session ID component has two ways of displaying data. Either if it's prefetched, if it's being redirected through new session, and then we have the new session fetched for us and passed along in the state. Or if we don't, we just have the ID. In that case, we technically skip this part and just call the fetch session. So let's try. If I do this is prefetched, you can see it immediately loads it. So it's a very fast experience. And if I refresh here, we have another one. This is prefetched. You might notice that it has been completely reset. That is because it's just an in-memory store. It's not a real database. So every time hot reload happens, your database clears. We don't have the real database just yet. Brilliant. So really, really cool. So hello world, you can see it works. So what should we try doing? I would recommend going inside of sessions.ts. Let's go inside of our post request. And let's try this. Let's try simulating slow session creation. So if I do slow creation, you can see how that's going to look like. For 5 seconds, it will display this. But the UX was changed immediately for the user. And you can see it's almost seamless when it redirects to the session ID. Now let's go ahead and try the error as well. So let me go ahead and just close this. Bun run dev CLI, hello world, error and slow. So now it's waiting for 5 seconds in the new session screen, and then it's going to error and it redirects me back to the home page. Great. So good UX so far. Let's make sure to comment these out. And now I'm going to go ahead instead of get ID, and in here I'm going to go ahead and make it slow again. And I'm going to make it throw an error, and you will see how that's going to look like. So, oh, actually, I don't think we can demonstrate that. Well, let me show you. If I do hello world now, this will work just fine, even though I specifically throw the error and I specifically tell it to wait 5 seconds. That is because we have prefetched it. So to demonstrate, if I go inside of CLI, screens, session.tsx, and if I turn off my prefetched here, actually just make, yeah, let me try, how do I make this return null? Like a hack, I guess. So I purposely not make it prefetched. Now, if I do this, you can see that it's obviously broken, right? Something is not behaving as it should. Here it is, session loading failed. So what happens is that it initially just loaded this, which I guess we have to do loading. I'm not sure why I'm not passing along that prop, because technically that's what's happening. Hello world. Yeah, now it's kind of simulating the new session state in the session ID state. So we are basically having this kind of trampoline, I guess you could call, of new session creation, but it's all with the purpose of creating a high quality CLI terminal user experience, because these are really hard to do. So let me go ahead and make sure that this one is loading, because I think it should be loading. And let me remove the return null here. So that's what prefetched is for. And let me show you one last example. I'm going to comment out this, and I will just leave out this. And you can see that now, remember how fast the initial creation was? Well, now, now it's still fast because of the prefetch, of course. But if I do the thing again, return null, now it will behave differently. So hello world, you can see that now I have to wait 5 seconds again. So that's why we do the prefetch. So it doesn't have to go through 2 API requests, both the post request and then another get request using the ID from the params. Brilliant. So that is it for this step right here, which is server and API client. And now what we have to do is we have to add our database. We have to connect it to Neon Postgres and define the schema and replace all of the mock things with a real database, a real persisted table. Let's start by creating the actual database package. So I'm going to go ahead and create a new folder, and I'm going to call it database. Then in here, I'm going to create a package.json, and I'm going to go ahead and do the usual. I'm going to give it a name, Nightcode database. I'm going to give it a type of module, which we actually need for Prisma. I'm going to make it private. And for the exports, I'm going to add two, the index and also the enums separately. I'm going to go ahead and add scripts, database generate, which is going to run Banex Prisma generate. And I'm going to leave it at that for now, because we're going to add the packages in a moment. So now we have our database package here. Let's go ahead and set up Prisma. So we have a new project. Now let's go ahead and install the following dependencies. So we need to add Prisma and types node as dev dependencies. So for that, I'm going to go ahead inside of my packages, database. Let's add those. And once those are added, I'm going to add the other ones. Prisma client, Prisma adapter Postgres, and dot environment. Once we have that, let's go ahead and I think we need tsconfig, but we can just extend our base one. tsconfig.json. Let me just jump into server and just copy the contents of this and paste it. I think pretty much everything that we need here. Module is ES. Module is preserved. Okay, I think it's completely okay. I didn't modify anything regarding my tsconfig, so I don't think that we need to do anything special. I'm looking through my source code right now just to see if there's anything special I did. I don't think there is, but if something breaks, yeah, we can easily just switch it. Okay, so let's leave this as is. We already have type modules, so that's fine. And now let's initialize Prisma ORM. So I'm going to go ahead. I'm not going to use the output command. I'm just going to run banex bun prisma init. So make sure you're running this within your database package. We already have the packages installed and initialized Prisma in your project. Let's see, did it do that correctly or not? Because I'm pretty sure I want this to be within my source folder, but in here I don't think it did it in the source folder. Yeah, it did it here, but maybe that's okay. Yeah, actually it's okay. It's perfectly fine for it to work this way. So now what I want to do is I want to go inside of my Prisma config here. And I just want to see if everything works. So we have define config, we have environment here, we have database URL here. And what we should start doing now is we should create a global.environment.example. And in here, let's go ahead and add API URL and database URL. Let's copy the environment example and let's go ahead and create just .environment here and save this file. And now let's grab our database URL by heading to Neon, create an account, and then go ahead and click new project. I'm going to call this night code development. And I'm going to leave everything as is, and I'm going to hit create. And just like that, in less than 30 milliseconds, let's go ahead and get the connection string. So I'm going to copy the snippet, just like that, and paste it here. There we go. So now we have the database set up. Let's go ahead and see what we have to do next here. We have this defined. And now we would need the Prisma schema. So let's see, database, Prisma, we have schema.prisma here. This is already set to Postgres. Let me check the config once more. Do I need anything special here? I don't think I do. I think this should work just the way it is. Environment from Prisma config. Yeah, I think it will not be able to read the environment file that I have in the root of my project. Yeah, you can see it wants to read the environment file here. Now, I'm not really sure what's the best practice with monorepos. Should you have .environment in each package? I'm pretty sure that sounds normal. That shouldn't sound too odd. but I'm just going to keep all of them in my root here. So I'm going to remove that environment file from the database package, and I'm just going to keep it and maintain everything here simply because my monorepo is very simple. So what do we need to do? Let me go ahead and just create my schema Prisma because I want to try and push what I need, and then we'll see if we're going to get any errors. So let me go ahead and create a role. A role of a message can be user, assistant, or error. Let me create an enum mode. The user can either be in build or plan mode. And let me go ahead and create an enum message status. So the user can either have a completed message or uninterrupted message. Same goes for the AI model. Then let's go ahead and create the session. The session is going to have an ID with a default CU ID, a required user ID, a required title, optional path, some timestamps, and a relation to the message model, which we don't yet have. And we're going to create an index over user ID. We are not going to have a relation to the user because we are not going to have the user model. We're going to use a third-party out provider, and then we're going to store just the user ID here. Now let's go ahead and create the message. Here it is. So a message is going to have the ID, session ID, which is basically a relation to the session as we define right here. Role using our enum, same for message status, model, content, parts, which is basically JSON. And these parts are going to be what we developed in shared here when you see schemas. These are basically parts. Text delta, reasoning delta, tool call, tool result, done, error. That's what we're going to store in the database. That's why we are using an ambiguous JSON. So we need mode, duration, and what we define here is that when we decide to delete a session, we're also going to cascade and delete all messages belonging to that session. So we are not going to have any orphaned messages. All right, so that is our, let me expand just in case you want to see how it looks like in one line. Here it is. So now what we should do is we should generate and we should push to our database. So let's see if we can do that or not. So I'm going to go make sure you are inside of your packages database, and let me do Banex Prisma generate. Let me try this first. And yeah, it's missing database URL. So again, two ways of fixing that. You can either maintain another .environment file within your database, which I think is a normal practice, or we can go inside of the config here. And what we can do here is, well, import .environment from .environment. And we can import path from path. And then we can do .environment.config and define the path and simply traverse back to the top folder. So outside of here, and aim at this .environment file. That's what I'm doing in here. And I think that now I should be able, let me try Banex Prisma generate, and just like that, it's now working. So again, two solutions, either what I just did, or if for whatever reason path is not working for you, again, Windows, Linux, Mac OS, all of them work differently. You can just maintain another .environment file in your database. Just make sure you don't accidentally forgot to upgrade it if you change something. Great, so we have that now. And now we should be able to also push. So if I go inside of my Neon database here, and if I go inside of tables, I currently have no tables in my public schema. But if I do Banex Prisma database push, I should be able to push to this Neon database. You can see it managed to read injected environment file. You can see it managed to do that. And the database is now in sync. So if I refresh this, I should now see message and session. Brilliant. So that is properly set up. And now that we have the schema and we have the config, let's go ahead inside of the database and let's create a new folder called source. And let's go ahead create client.ts. In here again, I'm going to import .environment config, Prisma Postgres adapter, and Prisma client. In here, it cannot find the module. And I'm starting to think that this might be because of the TS config here. Could be. I'm not sure. How about Prisma client? Let me see what I'm doing incorrectly here. Oh, generated is loaded at the top. So if I just go, okay, if I just go 2 back, then it works. Okay, my apologies. So Prisma client works fine. Let's get the database URL using process environment database URL. If it's missing, let's go ahead and throw the error. And let's go ahead and create an adapter. And finally, let's go ahead and export cons database, new Prisma client, and the adapter. And now let's go ahead and create enums.ts. And in here, I want to re-export all the enums that we need, role, mode, and message status. I'm going to explain why I'm doing this in a separate file in a second. So we now have a client, we now have enums. Let's go ahead and create one more, index.ts. And in here, I'm simply going to go ahead and export database from client.ts. And I'm going to export everything from generated Prisma client.ts. So let me check, do I really need this? I don't, but I think I do need it for this. Oh, I don't, cool. Actually, I think the reason I'm adding .ts is because my builds were failing without it. So I'm going to stay true to my source code and I'm going to import with the extension here. Now, if you remember, in my package JSON for the database, I added 2 exports. So one is just index and one is for enums. The reason is very similar as to why I added Nightcode server in dev dependencies of CLI. So now we will be able to specifically import Nightcode database enums, and I won't have to inject an entire Prisma into the bundle because we need enums both at runtime and for some validation, I think. So because of that, we cannot add it in dev dependencies. We have to add it in dependencies. And we're going to solve the tree shaking issue with a separate export of enums. Great. So we have that done. So let me see what we should be doing next. Now we should go inside of packages, server package.json. And in dependencies here, we should add Nightcode database workspace like that. And let's also do clear. Let's go inside of packages, server, bun add dot environment here as well. So you should now have dot environment inside of your packages server because we need to read from that environment file again. Okay. Now let's go inside of packages, server, source, routes, sessions.ts. And in here, I'm going to go ahead and import the database from Nightcode database. So now I have the Prisma client here, and I can finally get rid of the mock messages entirely. I can get rid of the mock session. I can get rid of this mock creation and everything. I'm going to replace the role here to be an enum, and it's going to be using role, which we can import either from Nightcode database directly, but since this is going to mess with the builds, so let's rather do enums. So role like this. And let's also add role, mode, message status. So this is z enum role. And for the mode, let's do z enum mode like that. Then let's go ahead and change the get request. So the get request is no longer going to be this. Instead, the get request is going to be an asynchronous function, which simply awaits database session find many order by latest created, and let's just select ID, title, and created at. And then we can go ahead and simply return that back. Now let's go ahead and, let me comment this out. So in here, we do need the ID param, but we're not gonna like filter through the sessions. Instead, we're gonna go ahead and properly fetch using Prisma. So we can find a unique session using database session find unique where the ID matches, and let's include all messages included in that session by newest created. Great. If there is no session, let's throw an error. Perfect. And now let's go ahead and do this one, which is the post request. So in here, we can delete this entire mock creation. None of that is needed. Let's only keep the initial message and data extraction. So completely empty post request now. And what we're going to do is we're going to initialize sessions create here. We're going to open data. And in here, I'm just going to spread everything data related. And I'm going to hard code user ID to be mock user because we don't have auth yet. And then I'm just going to spread this optional message if it exists. So if it exists, I'm going to go ahead and use their API, which allows me to communicate with the messages schema and call the create method on them and pass along the initial message data and give it a status of complete. And then at the end, since we are going to use this session as the prefetch for the session, we also need to include the messages. And then at the end, all we have to do is return c.json to a 1. Brilliant. So that is our sessions.ts fixed. And I think that now everything should be working as it was before. We don't have to change anything from the front end, I think. So let me just go ahead and check now. Let me go back here, back, bun run dev CLI. Let's go ahead and do bun run dev server in the other one. And let me try and do persisted message stored in the database. And let's see. Looks good on the front end side. How about we refresh our Neon database here, messages, and here is our message status complete, model Claude Opus, persisted message stored in the database, and the session created with the mock user ID and the title similar to, identical to the message. I even have my path passed along and the timestamps. Brilliant. So very, very simple to replace our mocked solution with the real deal. One thing I'm kind of not too satisfied about is like this .environment file and how I have to have .environment installed in server, and I have to kind of traverse in database. And also because I'm not sure if generated should be, oh yeah, see, I have a git ignore inside of this package. I'm not really sure like what's the norm. Should I have like one git ignore and then let me just check. Should I like copy the contents of this git ignore and then paste it like here? Let me check Prisma. Like, should I do that? I'm really not sure. And then if I delete this git ignore, yeah, it doesn't work. So let me check. How do you properly do this? Well, I'm just gonna revert it. I'm gonna keep the git ignore in the database right here, and I'm gonna leave it to be as is. I'm not gonna keep this. Okay, so yes, just let the database have its own git ignore. Again, if you want it, you can maintain the environment file within the database. I might research a bit, and if I see that the norm is that usually each of these has its own environment file, then I'm going to stop doing the hard job of making all of these packages use .environment to point to this environment file, which you can already do yourself. You can add .environment file into the server and .environment file into the database and make all of them point to the same database URL. And I think that it should work just as well. Great. Okay, and I found how you can control where generated is created. If you go inside of your Prisma schema, at the top here, you can see the output. So if you want it to be inside of your source, you can change it to this. Again, I'm not sure which one is better, but this one seems to be what gitignore was looking at. So I'm just going to keep it in generated. And it makes sense because everything Prisma related is outside of my source folder. So I'm just going to keep my source folder for the things I'm exporting. Great. I believe we are finished with this chapter entirely now. So let me go ahead and commit it. So chapter 4, server, shared package, and database. Oh, the one thing I want to do is just search for my HTTP exception and go here. Actually, I want to go inside of sessions.ts. So go inside of your server, source routes, sessions.ts, and let's just comment this out because we're not using HTTP exception anywhere. So let's shut this down. Let's go ahead and git checkout 04. And this will be server shared database. Git add, git commit 04 server shared and database packages. And git push origin 04 server shared database. Now that that is pushed, we can go ahead and create a pull request, and then we can go ahead and review our changes. Let's go through the review by CodeRabbit. So in here we have the release notes, some new features, some chores that we added, but more importantly, we have a lot of comments to look at. So the first one is that the title slicing can be a bit problematic. I'm going to rule this as okay, simply because this is a tutorial. So in production instances, I would actually recommend using AI to generate a nice text message depending on this message slice. In here, you can pause the screen to read the in-depth problem here. As you can see, many characters and other things can apparently make Postgres reject this because of invalid byte sequence for encoding in UTF-8. So we should probably tighten this, as you can see how they do it here. But I think for our use case, this is just perfectly fine as is, but definitely a good suggestion by CodeRabbit if it comes to production. In here, it's warning us that our session location schema is too loose and that it will crash on malformed state. So its proposed tighter validation is to also confirm that we have messages and that array of messages exists. But as it says, currently the only producer is new session, which means that we own what we send in location.state. So we are pretty safe, but it's warning us about history entries, hot reloads, or future call sites that can easily trip this. So with the current state, it's actually perfectly fine this way. But yeah, a very good idea to tighten it if you end up having multiple call sites that redirect with session location schema. Even though the only reason we even have location schema is because of the prefetching that we are doing. So the user doesn't have to wait twice. So very good comment, but since we own the only call location, I'm going to leave it as is. In here, this is very interesting and even marked as critical here. Toast is not stable across renders. We can add use memo to the context value in toast provider. So the toast dependency in the effect is problematic. Although the show function is memoized via use callback, the context value object itself is created fresh on every render of toast provider. This means that each call to use toast returns a different object reference. When toast provider re-renders from any parent update, the session effect sees a new toast object, reruns, aborts the in-flight fetch via ignore true, and triggers a new network request, cascading requests while the compound is mounted. So that's pretty serious and something I haven't noticed because I don't have a network inspect tab in my TUI. So let's go ahead and fix this. Let's go inside of toast provider and let's memorize our value here because it's problematic that we're adding it to the dependency array, which then does subsequent network requests. So inside of my CLI package, I'm going to go inside of providers, toast, and I'm going to go inside of index right here. Let me go ahead and find the value. Here it is. Here is the value. And I'm going to replace it by memoizing it. Let me go ahead and import use memo from React. No errors. Looks like everything is still good. Just make sure you import use memo. Let me confirm that that's the one. It is. And let me try bound run dev CLI. Works. Let me go ahead and do hello world. This seems to work just as fine. Perfect. So that works. I'm going to, well, I'm not going to do anything yet, just in case there are more of these. Okay, and here it's telling me to add more environment variants, but we don't need that because of our root git ignore, at least I think. In here it does a good comment as well. So use deterministic environment loading instead of path dependent import.environment config. So on line 1, import.environment config resolves environment from the process working directory in this monorepo, varying path from different script invocation points. So bound run from packages server or packager CLI causes this to fail to load the root environment, triggering line 8 throw even when the root environment actually exists. Okay, that sounds like something we should fix. So let's go ahead and do it. So we are talking about database source client.ts. Let me go ahead and check that out. So database source client.ts. So I'm going to change this to be .environment from .environment. Then I'm going to go ahead and import path from path. And then I'm going to go ahead and do this and just remove the diff change here. Okay, I think this should work. Not sure how we can test this. And why is it going so outside of here? Probably because it has to go outside of here to the source. That's 1. Outside of here, that's 2. Outside of here, that's 3. And then .environment. So 1, 2, 3. Okay, I think I get it. So let me just, I don't know, try bound run dev server. Oh, here it is. Injected environment from .environment. Multiple file paths. Okay. And then let me go ahead and do bound run dev CLI here. Hello world, testing if this works. Let's see. Looks like it works. Let me try and purposely break it. So if I pick environment 2 here, and then run this again. Okay, it says it loaded it. So if I try bound run dev CLI, hello world, it still works. Okay, I don't think I fully understand this, but I feel like this is just more explicit than what we had, so I'm just going to use it. It seems to not break our app. Seems to work just fine. If you're having problems, feel free to have multiple .environment files, like one in your database, one in your CLI, one in your server, wherever it needs to be to make it work, and just have the database URL. Okay, sure. I'm going to go ahead and do, okay, again, I'm not sure if that's all we need, but this looks fine. In here, yeah, it's warning us that we should probably have some automatic setup hook to ensure fresh environments can build and type check, simply because this is git ignored. So it entirely depends on the user's machine if they run Bonex Prisma generate. So if they don't run this, they're going to have stale data. I think this is more of a problem if you're working within a theme or something. So different people are going to have different problems. But ourselves, we are going to be aware that we have to run Bunnex Prisma generate every time we update our schema, and then this will subsequently update as well. So good comment, definitely, but for us, it's okay. In here, it's telling us to remove database from root export to prevent unnecessary client TS evaluation. Re-exporting database from the package root forces evaluation of client, which throws on missing database URL whenever anything is important from Nightcode database, even when only Prisma types or enums are needed. This makes the root export fragile. Oh, that's interesting. Oh, yeah, I like this. I like this. Let's do it. So remove database from root export. I'm going to go ahead and do that. Database source index. I'm going to remove that from the root export. And I'm going to go inside of my package JSON. And I'm going to add client export specifically, like this. And that changes things in my server file, I believe. Let me check if that's true. So in my server, source, routes, sessions, I now have an error here. And I have to import database /client, like this. I think that's the only instance I have. Let me go ahead and search for the database, not in bunlock, not in package JSON. Yes, that's the only instance, just for good. I'm going to check, can I run the server? I can. Can I do run dev CLI? I can. Can I do hello world? Looks like I can. Perfect. So we resolved that. And here at the end, it's just telling us that we are missing user scoping. That's because we don't have auth yet, so we are mocking users, or we are not even like filtering for user. We allow everyone to load everything, so we can resolve that ourselves. Very good changes. Let's go ahead and git commit. So same message, and I'm just going to append like fix at the end, and I can then just do git push. Has no upstream branch. That's interesting. Let me try doing git push set upstream origin 04 server shared database. See if that's going to fix it. Look like that fixes it. Let me see what command we actually run. So we run git push origin. I think I should have a flag git push -u origin, and then that would set the upstream. Yes, that sounds, I think that flag sounds like that should be it. So if you want to add subsequent commits, you have to add set upstream origin here. And that should re-trigger this. And let me just confirm. So I have two commits. That looks good. So the first one is the initial one, and the second one is the fix. And with that, we have resolved. Let me see. I can now close this one because I don't need that. This one already says outdated. Perfect. And everything else seems to be resolved. So I'm just going to wait to see if this one gets resolved itself, because we explicitly fixed that. I'm just going to wait a second. So since it wasn't resolving itself, I simply asked, is this resolved in the latest commit? And you can see that it confirmed that the latest commit fully resolves this, and file now uses deterministic approach. Perfect. And that automatically marked it confirmed as addressed by. Perfect. So all issues resolved. We are good to merge. Amazing job. Let's not delete the branch. So we have our history right here. What we have to do is we have to go back here, git checkout to the main branch, and git pull origin main. So we are up to date with all of our changes. Brilliant. Now let's go ahead and end this chapter. Amazing, amazing job, and see you in the next one. Now that we have a Hono server and the database, it's time to talk about monitoring. Right now, if something breaks on our server, we have no way of knowing that. Here's an example. We have a user who uses our Hono server, something happens, like an internal server error, and we have no idea in which route it happened. We have no stack trace to reproduce it. We have no request context, and we have no idea how often it happens. We don't know if this was a one-off event, if it only happened to one user, or if it happened to 1,000 users. This is problematic because we don't know what to fix unless we experience this ourselves. And that isn't how you handle errors in production. Instead, what you do is you add some kind of monitoring like Sentry. With Sentry, you are one step ahead of every single error that happens within your application, because you don't have to wait for your users to report the errors or wait until you experience them yourselves. Sentry is going to create a new issue for every single error that happens in your application. It's also going to create a full stack trace, allowing you to see which method, which route, how long did it take, and which status did it return. Using Sentry logging, you can filter by method, path, status, duration, and many more things. You can also keep track of frequency. How many times did an error happen, and how many users were affected? In short, you will know exactly what broke, where, and how often. This is an absolute must if you plan on having a production-grade application. The way it works is extremely simple. So usually we have a request, which goes into the route handler, an error happens, and we don't know about it. But by introducing Sentry middleware for Hono, we put it in the first place before anything else happens. So before any route handler execution is done, we add the Sentry middleware. So if any uncaught error happens, it is automatically going to throw it back inside of the Sentry middleware, meaning that we don't have to manually add try and catch methods everywhere. If something is truly uncaught, it's now being caught and immediately reported in the dashboard with a new issue created so that we know we have to fix it. Besides that, Sentry also gives us an option to manually log things. For example, if we just want to log what happened, like a successful request, we can use their logger.info API. This is used for normal operations and they can be used for every request. This is useful because once you have successful states, it will be easier for you to notice an anomaly. So something that was usually successful is now failing. Or something that you expect could happen, so you have this instead of try and catch, for example. In here, you could use logger.warn API. And lastly, we have the example we spoke above. This is logger.error. This is if something breaks and you don't know about it. Basically unhandled errors. So we have option to manually log all kinds of things in our server, but you don't really have to worry about that because the most important one, the unhandled error, is captured immediately, automatically with Sentry. Let's see how we can add it to our Hono server. Using the link on the screen or simply entering the code with Antonio when you sign up, you can get Sentry Team for free for 3 months, as well as 150,000 errors included. So go ahead and create a new account. Once you create a new organization, go ahead and create a new project. In here, choose Server as the platform, and you can see all of the amazing options it has. Down here, you can find Hono. So go ahead and select Hono. In here, you can choose your alert frequency. That's right, Sentry is going to alert you whenever some kind of internal or uncaught error happens. So this can be extremely useful if you want to be on high alert and immediately start fixing when something breaks for your users. You can also turn it off if you don't like it. And you can name your project whatever you want. So I'm going to go ahead and call this Night Code, and I'm going to put it in this default theme. And then I'm going to go ahead and create the project. Now let's go ahead and configure the Hono SDK. You can see that error monitoring is already selected, but besides that, you can add logs, application metrics, and tracing. Profiling is currently only available for the Node.js runtime. Since we are using Bun, I'm going to deselect that one. In here, I'm going to select Bun, and that gives me the exact installation and configuration steps that I need. Let's go ahead and install these two packages inside of our server. So I'm going to go inside of my packages, and then I'm going to go inside of server. And in here, I'm going to do bun add, and I'm specifically going to add Sentry Hono and Sentry Bun. Once you've added them, let's go ahead and confirm that they have been added in the package JSON of my server package, Sentry Bun and Sentry Hono. Now let's go ahead and actually register the Sentry middleware inside of our server. So go inside of index.ts and let's go ahead and import Sentry from Sentry Hono Bun. Then, right after we initialize our app, let's go ahead and register the Sentry middleware. This configuration right here can be different depending on your selection of options up here. You can see that I, for example, have logs enabled because I've selected them right here. And now let's go ahead and also modify our code to import this right below. And then let's add this explicit test to debug Sentry. So right after our middleware, I'm going to register an endpoint debug Sentry, which will use Sentry logger info, and we're going to use Sentry metrics count. And then we're just going to go ahead and throw one random uncaught error. All right, now that we have this, let's go ahead and actually run our app. So I'm going to do bun install here. And then I'm going to go ahead and simply start my server. Now let's go ahead and visit localhost 3000 debug Sentry. So it's this exact API route. And you should get back error, internal server error. So why are we getting our error structured like this? Well, it is because we already have one middleware here on error, which basically standardizes the response output from that. But this doesn't actually capture our errors. It just standardizes the output. So they all return the exact same API structure. So make sure you hit this endpoint and get back an error. And now you should be ready to click Take Me to Issues. And here it is, 47 seconds ago. You can see that now for every single error that happens within your API, you will be aware. Not only will you be aware, you can see the exact URL where it happened. You can see the level of this issue. Is it an error? Is it an info? Or is it a warning? You can see the exact backend. You can see the exact machine where the server is hosted. You can see the highlights. You can see stack trace. You can automatically create issues for that. And this is extremely useful, right? So this is stack trace. Right now, it's extremely obvious because we purposely throw this error. But imagine how useful it would be to see this when you didn't expect an error to happen. So this kind of stack traces are extremely useful, so you can exactly understand where this was called from and how did this error happen, and then you can immediately go and fix it. In here, you even have the breadcrumbs, so you can see exactly how it started. The first thing we did is we visited the development server, and then we hit the faulty endpoint. Now again, all of this is very simple now, but imagine as it grows more and more, when we have all of these huge endpoints and our users start getting all kinds of errors, how will we know what to fix? Well, unless we experience those errors ourselves, we wouldn't know. But with Sentry, we can keep track of absolutely everything that is happening. Every error on every single user for every single event. And the best part of this all we had to do was register the middleware. We didn't have to do any special try catch here. So literally anything that gets thrown, whether that's from the database or if we just had some kind of faulty query, whatever happens, we no longer have to worry about it being hidden from us, but instead it will be captured and immediately reported. From here, we can resolve it. We can assign someone from our team. We can set the priority of this. We can even connect it to GitHub and automatically open a pull request. So many options you can do from here. Let's see how else we can use Sentry, specifically Sentry logs, to improve our application. So I want to focus on this handler that we have here, on error. In here, we obviously have some kind of HTTP exception, meaning that this is actually a handled error. So what should we do here? Well, let's visit the whiteboard. This would be an expected problem, right? So this is something we would expect. So the right thing to use here is logger.warn. So let's go ahead and add that here. Handled HTTP error. And in here, we can pass along the error status. We can pass along the error message with the fallback, the C request path, the method, everything here under warn. So we don't have to console log. Every time we want to console log, we can now do Sentry log instead, and then just throw this to the user. We actually don't have to do anything here because it's going to be captured anyway. But if you wanted to be explicit, you could remove this console log entirely now, and you could add Sentry logger error with all of these issues here. But let's go ahead and visit our sessions.ts so we can see some more useful ways of using Sentry. So I'm going to copy this Sentry import, and I'm going to go inside of my routes sessions.ts. There are many useful places where we can use Sentry logging here. For example, in here we have the create sessions schema, and down here we have the create sessions validator. So whenever this isn't successful, this is an expected error. So what we could do here is throw session creation validation fail. Now you might be wondering, but why would we even log this? Well, if it happens too often, you probably have some kind of UI that allows submitting invalid API body. That's why it's important for you to log these things, because otherwise your users would just be getting 400 errors back, and it could be that they are doing something wrong, but you also want to be aware of that. Perhaps you have some kind of bad user experience implemented, and by seeing an increase in these logs happening in the create session validator, you can go ahead and improve your application. So you don't have to think about this only for uncaught errors. You can also think about this for improving user experience. Let's take a look at this. This is a successful request, right? Nothing wrong is really happening here. Well, what we can do is we can add Sentry logger, and we can go ahead and display how many sessions we have successfully loaded. Again, not too useful at first, but useful for you if you start noticing an anomaly here, right? If you start noticing that all of your listed sessions count becomes 0 all of a sudden, you probably have some kind of database bug. Perhaps the database is down or something is corrupted, right? There are many, many ways where logs can help you. Let's take a look at this ID once again. So if there is no session, this would be a warn error, right? Because it is technically expected. We are throwing this error back, but it's also useful for us to keep track of this. So this is session not found, and I don't think we have to track anything other than session ID. Later, when we have a user ID, we can add that as well, right? Except mock user, you will replace it with the actual user ID. So you can then track and filter by that user. Perhaps only that user has some kind of problem. And then you can notice, is that user in some organization? Is that user premium? Is that user on a free tier? As much context as possible for you to deduct why some errors are happening for your users. Because sure, this is a very simple error. Session wasn't found. But how was this user able to access an invalid ID in the first place? That is your job to figure out, and that is where Sentry can help you. So once again, Sentry isn't just for errors. Sentry is also for improving user experience through various logs, whether they are successful or if they are not successful. So outside of this error, we can go ahead and log a successful session, right? And you can also load the message count if you want, or you can just mark this session ID as successfully loaded. There are many, many ways you can do this, right? You can also down here mark successful sessions, right? Every time you successfully create a session, go ahead and log them like this. Session ID, title, right? You don't have to log the paths. So just session ID and title. All of this is very, very useful information. And just by adding these few changes, you will start to see useful things here. So if I go inside of my logs here now, let's wait a second, and then we're going to start seeing all of this information which we just logged. So give it a few moments to load. What I'm trying right now is localhost 3000 and then sessions and then 123. Basically, this is the URL I just visited, right? Something I know is going to fail, a random session ID. And you can see on the return side, everything looks perfectly fine, but you can see that something is happening in the logs here. So in my logs, I can see a normal listed sessions log, but I can also see that user triggered the test error. So, okay, this is the test error. This isn't as useful, of course, but this is your dashboard where you will keep track of all the logs happening on your application. For example, here is session not found. So you can see it's not exactly a critical mistake, but you can see the exact session ID which was attempted to be loaded and which user loaded it. This is already useful information because if you start seeing an uptick in these sessions here, you can then deduct, oh, okay, so this user somehow has some stale information in their UI. How is that happening? And then just think about it later. When you improve this, you could also log which version of the CLI application they are using. And then you will have that information displayed here as well. So that is how you handle monitoring and errors for production grade applications. And I can guarantee you that Claude Code, Open Code Codex all have this kind of thing added. So they are actively monitoring anything that happens when they try to load a session that was deleted, when they successfully delete a session, when they successfully load sessions. All of that is logged. And you should be doing that as well. In case you were not successful in enabling logs or error monitoring for whatever reason, you don't have to worry about not being able to complete the rest of this tutorial. So this is simply a bonus chapter that I wanted to show you, which will greatly improve the production grade quality of your application. If you choose to use this, feel free to commit these changes and merge them into main. But if you don't want to use them, feel free to discard all of the changes and simply go to the next chapter. Amazing job, and see you in the next lesson. In this chapter, we're going to implement AI chat streaming, basically a way for our LLM to finally talk back to us in our terminal. The way we are going to achieve this is by using the following flow. Our CLI client, our terminal, is going to make a post request to a new API route we're going to develop called chat. That chat route is going to use Vercel's AI SDK, which allows us to use any provider we want. So it's completely provider agnostic. I'm going to showcase Anthropic and OpenAI, but you can use any of their available providers, and there are a lot of them. And yes, there are completely free ones like Google or Grok. And we're going to then persist the output to the database while simultaneously using server-sent events to stream back to our terminal what is happening. And if you're worried about hearing the word Vercel in Vercel AI SDK, let me go ahead and explain what that is. So AI SDK is not a Vercel lock-in. A lot of times I recommend to people to use this tool, and they are afraid of some kind of lock-in. That is not what this is. This is an open source tool by Vercel that allows you to basically have provider agnostic, model agnostic toolkit. And it's perfect for an app like ours where we want to support thousands of providers if needed. It's basically the same as Tanstack AI or Pydantic AI. Basically, it's model agnostic and it supports virtually every model and provider. It's kind of the same idea with all of these packages. And AI SDK is by far the most popular one, and that's why we're going to be using it. I'm going to be using version 6, and we're mostly going to focus on their streaming functionality. So what is streaming? Well, this right here. So you don't have to wait for the entire output. Instead, it will immediately start writing something back. So this will help us a lot because they have this stream text function. And then we're going to combine that with Hono's streaming helper so that we can, add that streaming event to our Hono server. We're then going to implement something called use chat hook, which will be able to parse the results of the stream. Now, usually, if you were working on the web, you wouldn't have to implement this yourself for a very simple reason that Vercel's AI SDK actually has use chat for that specific purpose. The problem is it uses some API that isn't available within OpenTUI. So that's why, at least that's to my knowledge and my testing, I could be wrong, but still it's like an extremely good practice to learn how to build your own use chat, which is able to parse these stream events like text delta, reasoning delta, tool call, tool result, done, and error. And then we're going to wrap it up by implementing stream interruption. Basically, in the middle of streaming, we will allow the user to press escape, and then we are going to capture that event on the front end, and we're going to persist the interrupted message on the back end. Basically, a very nice user experience by the end of this chapter. Let me show you exactly how that looks like. You will be able to send hello world, and you will get back a response from AI any second now. And if you do something like write me a longer message, and let's wait for its response, you can see that I can interrupt it like that. That is what we are going to achieve. So let's go ahead and do it. I'm going to start by adding some packages to my server package. So let's go inside of packages, server, and I'm going to do bun add AI SDK / Anthropic AI SDK / OpenAI, and finally the AI package itself. So these three packages have just been added. You can even see the exact versions that I am using. Let me go ahead and confirm that they are here in package.json. Here they are. Perfect. Now that we have that, we have to go ahead and set up a util for our models. Let's go ahead inside of server here, inside of source. I'm going to go ahead and create a new folder called lib. And in here, I'm going to create models.ts. Let's go ahead and start by adding the imports of our newest two packages. And then let's go ahead and import all of the helpers we developed using Code shared. Then let's go ahead and import a type language model from our AI package. In here, I'm going to define the Anthropic model ID. Let me expand this. Anthropic model ID, which is going to use our supported chat model type, and it's going to specify the provider being Anthropic, and then it's going to look for ID, and that is going to filter it to only the model IDs that we have defined that we are supporting. So a really cool TypeScript way of making this only these three models. And if we ever want to expand that, we can go inside of our shared package here, inside of the models, and we can just extend it. So let's go ahead and, for example, add another Sonnet version. Let me duplicate it. Let's call this 4.7. I can save it. And immediately here, you can see it's added as a supported version. Let me remove it now. And you can see how it filters by the provider Anthropic. So it doesn't even mention these ones because that's provider OpenAI. And the same way, we can do OpenAI model ID by searching for the provider OpenAI and focusing on the ID of the models. Let's go ahead and create a type for the resolved model, which is going to use the types we imported above. And now let's go ahead and create a little function. Assert unsupported provider. Inside of here, we are simply going to create a little helper that throws the error for this. And you're going to see why we need it, simply because it's going to be so common to do. And we want to do it inside of a closure like this. Now let's go ahead and create a function to resolve an Anthropic model. So resolve Anthropic model accepts model ID, and it returns a type of resolved model. And it's simply going to return an object, which is a model, which calls Anthropic from up here. and passes along the model ID. And you can see how there are no errors here because Anthropic messages model ID is supported, or should I say, matches what we have defined here. Now that I think of it, perhaps we could find a way to use Anthropic messages model ID type from AI SDK Anthropic and maybe somehow combine it with our shared package so that we don't exactly blindly write these IDs, right? For example, we could always do a cast check, but I'm gonna keep that for later. But I'm pretty certain that if you add something wildly incorrect, let me see, it doesn't show an error here, even though this is obviously incorrect. Perhaps it's not able to type check like that. Let's just continue with our development then. So this is to resolve the Anthropic model. Now I'm going to create one to resolve OpenAI model. The reason these are identical and I didn't unify it in one function is simply because later when you add more and more providers and models, they can start to verify with their config files. And this is kind of more explicit, so that's why I'm separating it, even though it's almost identical code. Now let's go ahead and create a function that will help us resolve the supported chat model. So I'm going to go ahead and first grab the provider from the model prop. And then depending on the provider, I'm going to use a switch case to choose. If it's Anthropic, we're going to use the function we developed above for Anthropic. For OpenAI, this. And default is simply going to be assert unsupported provider. Throw an error, like that. Let's go ahead and add another helper function here. Is supported chat model using the model ID. We're going to check if model ID is in supported chat model ID, and we're going to return find supported chat model and verify that the function doesn't return null. Perfect. And by the end, let's add resolve chat model function. Resolve chat model also accepts a model ID and returns a resolved model. It uses the same function as above to find the model. If there isn't one, we throw an error. Otherwise, let's resolve supported chat model. Perfect. So that is the helper that we need. Now, let's go ahead and develop the chat route. We now have all the helpers here. So how about we go inside of server? Let's go inside of routes and not new folder. Let's go ahead and create chat.ts. And in here, let's go ahead and add some imports. So we're going to start with everything we need from Hono. Then let's go ahead and add Zod. Then let's go ahead and add our new package AI and use it for streaming. Let's import the database. Remember, we now have to use /client here. That was the change that we did because of our CodeRabbit requests. And now let's import the enums separately. And let's import type chat stream event from Nightcode shared. And from our new package, new lib models, some functions like is supported chat model and resolve chat model. In here, I'm going to define a submit schema that is going to help us verify whether the user can actually submit this into the chat. So it requests the content to be string, the mode to be one of the two modes that we have, which is plan or build, and finally, the model to be a supported chat model. So the user cannot fool our API. And using the submit schema, we can build the submit validator using the Z validator, specifically validating the JSON field of the post API request using the submit schema above. And if it's incorrect, we are going to standardize the error like this. Now that we have that, let's go ahead and create a little util that is going to help us build the conversation history. The conversation history is important so that, for example, where I showed you this, if I go ahead and do what were my last two messages, it will understand what my last two messages were because of that database context. There we go. See, hello world, write me a longer message. So that's why we need a function to help us build conversation history, but we want only specific messages to be passed here. So let's go ahead and add a prop instead of build conversation history. So inside of here, we're going to add messages, and we're going to define the type as this. So messages is basically going to be an array of an object which has a role, which can be user, assistant, and error, and content, and status, which is message status. Now in here, let's go ahead and run a flat map over our messages. Whoops. Okay. Instead of the flat map, let's go ahead and do the following. If the role is error, return an empty array. If the role is assistant and the content length is empty, return an empty array. And finally, return an array and check if the role is user, then map it as user and cast as const here for type safety, where we're going to need this function in the future. And if it's assistant, then cast it as assistant and pass along the content. So let me go ahead and separate this like that. Great. So that is our function to build conversation history. It basically strips error messages and empty messages from the conversation. So the token usage is lighter. Great. Now that we have that, let's go ahead and develop a type stream params. That's going to accept session ID, model, history with a role, who can be either user or assistant, and content, which is a string. And it's going to be an array of those. So basically what we helped build right here. We're going to have mode, and we're going to have an abort controller in case of interruption. And now we're going to go ahead and create a function to stream AI response. In the parameters of this function, we are going to accept stream with parameters type of stream server sent events, and then the first one, and then, the second one, and then the first one. This is kind of an ugly type, but it's a way to get this. Perhaps there is a way to extract that from Hono directly, but I don't think I was able to do it. Maybe we can do it, but I'd rather leave it like this and then check if we can change it later. And the params are simply going to be stream params. Now in here, I'm going to go ahead and extract the session ID, model, history, mode, and abort controller. And I'm going to define the start time of the streaming so I can calculate when it's going to end. Then let's go ahead and let's add a resolved model using the resolved chat model. And in here, let's go ahead and define the full text. Now let's go ahead and open a try and catch method here. In the try method, we're going to go ahead and generate the result using AI stream text from our AI package. We're going to pass along the resolved model, the history of the messages, and the abort signal so that we can cancel it if needed. Now that we have the result from AI stream text, we have to iterate over every possible tool call that happens. Every possible type of event that happens. So for each part of the result, full stream, let's go ahead and capture it. For example, let's first do an early break if stream is aborted. And then, for example, if we have a part which is text delta, let's simply append that text to the full text constant we defined above. Then let's go ahead and define this event, which we are going to use chat stream event type for. I'm not sure if you remember, but this comes from our shared package. And in here, we basically defined all of these tool calling arguments using a discriminated union. So if it's text delta, we expect a text. If it's reasoning, we expect a text. If it's tool call, we expect tool call ID, tool name, and some arguments. If it's tool result, we expect result and tool call ID, etc. So that is what we developed, I think, in a few chapters before. And now we're using it here to specify, using the results of the AI stream text function, how we want to store each part that happens. And now that we have the event, we have to use Hono's write SSE and simply send back the event, which is text delta, and then data JSON stringify event. Now let's go ahead and check if part type is error. Let's throw back that error. Then let's go ahead and check the following. If stream happens to be aborted, or if abort controller signal is aborted, let's do an early return. Otherwise, let's go ahead and calculate how long this took. So we're going to use date.now minus the start time that we defined up here. And that's how we know when the streaming has finished. And once we know that, we can go ahead and write the assistant message back to the database. So in here, let's go ahead and pass along the following data. Session ID, role assistant, status, message status.complete, model, content, using the full text, which we are appending through the streaming events, mode, which is plan or build, and finally the duration, and we are just going to prettify it so it's easier to work with later. So the reason this is overcomplicated at the moment, or should I say seems overcomplicated, is because we are only using the text delta. But later we're going to have all of these, I think I closed the tag, but basically we're going to have a bunch of different ones like done, tool call, tool result, and we have to stream them in a different way. So, and we also have to group them to display them properly on the terminal. So that's why we are preparing in advance by doing this. And now we can finally store the result in the assistant message. And what we should do then is we should fire a done event with a message that was created and the duration in milliseconds. And let's go ahead and stream that back to the terminal. Event is done and data JSON stringify done event. Now in the catch here, let's go ahead and grab the error. And what we are going to do again is check if an abort controller has been aborted. Let's go ahead and attempt to extract the error message by checking the instance of the error. And once we have that, we also have to persist this into the database, so the user has complete history of the session. So we are going to create a message, role, error, status, message status is complete, meaning it's no longer streaming, so it's finished, but it's errored. The model that happened, the content of the message, the mode, basically everything, so the user knows exactly in which session the error has happened and has complete history. So we are treating both events exactly the same, right? The only thing we don't keep track of here is how long it took. And now that we have that created in the database, we can go ahead and create an error event, and we can stream back the error event. And this is the function that we are going to extend going forward for any subsequent streaming parts that we need. Now let's go ahead and use this function. So let's define a new Hono app, and the first thing I want to build is the actual chat session ID route. So we call this just session ID because this will be registered under chat in the server index.ts. So in here, we're going to have chat, and then we're going to pass chat here. So that's why you don't have to write chat session ID here. You can just do session ID. So the first thing we're going to do here is we're going to extract the param session ID. Then we're going to use Prisma ORM to find this unique session by its ID. And we're going to include all of the messages in that session. If the session wasn't found, we're going to go ahead and do an early return with a 404. Otherwise, let's go ahead and attempt to deconstruct the data that was passed. And again, we're using this pattern of using validated JSON, which means that data is a completely valid content, mode, and model that we can use. Why is that? Because of the submit validator. So we are passing along the submit validator, which we defined above here, which uses the submit schema, which requires content to be string, mode to be one of the two types, and model to be one of the supported chat model IDs. So we can count on this data being fully correct, because if it isn't, this part has already thrown an error back to the user. And now what we can do is we can store that message immediately in the database, right? So this is basically a user sending a new message here. So let's store that in the database: session ID, role user, status, message status.complete, model data.model, content data.content, and mode data.mode. Now, once we have that, we have to start streaming back the answer to the user's message. So we have to rebuild the history. So we're going to use our function build conversation history. And inside of the messages array, we're going to open a new array. We're going to load all of the messages from the session that we have loaded here. If you want to, you can, to do maybe limit to last 5 messages. Simply, if in production this becomes too heavy, you would probably do something like that. And then you append a new message, which is basically what we just stored in the database. And that's how AI knows, okay, I have the entire context and I have your newest message. Now we have to prepare the abort controller here in case something gets canceled. And let's simply return stream server sent event. In the first argument, we have to pass along the context. And then in the second argument, we are writing a function. So this is going to be an asynchronous function. And inside of here, we are going to start by capturing the onAbort event of the stream and calling abort controller.abort. Otherwise, let's go ahead and simply stream the AI response. In here, we pass along the stream, and then we pass along session ID, model, history, mode, and abort controller. Basically, that is this function which we have developed, which is going to look at each part of the stream. It's going to call Vercell's AI stream event here and carefully emit every type of event that we need, which includes the text delta, the error, the finished event or done event, and the error event. So we are now using that in here, stream server sent events, and we don't have to write the entire function here. We can just reuse it here. Okay, and then let's go ahead and add a third callback here, which is in case of an error. So in case the error happens, let's try and deconstruct the message using its instance. And what do? Well, we just go ahead and create another error event, and we simply emit that event back. So this is for something completely uncaught, unrelated to stream AI response, because in here we have our own catch function, which does that. But you never know. This can break in many other ways. So let's just make sure that we are properly communicating back with the user what happened, right? Something broke. All right, let's export default app here. And then let's go ahead and map this function in our server source index.ts. So in here, I'm going to go ahead and chain another route, chat, and I'm going to add chat. And then we just have to add import chat from routes chat, just like that. Let's go back inside of our chat routes now. So what we implemented here is for the first time the user sends a message, right? But there is another route that we have to develop, which is basically to resume something. So I'm going to go ahead and do that at the end here. Actually, let me do it at the top. So another post request. And in here, we're going to add another session ID, resume. There will be no validator here because there is nothing for the user to pass along here. Instead, what we're going to do is we're going to grab the session ID. We're going to find the unique session and load all of its messages. We are then going to return early if session wasn't found. We are specifically going to look for the last message. Then let's go ahead and check the following use case. if there is no last message, or if the last message role is not from the user, that means that there is nothing to resume. The resume endpoint only works if the last message is something like this, assistance message. But that's not the only criteria, of course. We're also going to check if the last message message status is not complete. So in case there is no last message, and in case the last message role is not user, it means whatever happened is finished, right? And now we have to be careful. We can't just allow the user to resume something. We have to check again if this is even supported. So let's go ahead and do another check. If not supported chat model, then pick at the last message and choose the model. In that case, we have to throw the error. This session uses an unsupported model. Perhaps this is a session from the last year and when we deprecated that model. So we have to be careful. And then again here, we have to reconstruct our history using build conversation history. We have to add the abort controller. And then we do what we usually do what we did before. I mean, we stream SSE event. So let's go ahead and write an asynchronous function here. And in here, we are first things first going to handle the abort from happening. And in here, we do stream, not context, sorry. Then let's go ahead and use our stream AI response once again. This is why we wrote it like that, because we can now use it multiple times, both in our initial chat and in our resume chat function. And this resume chat is actually going to be crucial for us to have, even if you want that feature or not, because of the optimistic mutation that we are doing when we send a new message. This is actually going to be used quite intensively. So you need the resume method here. Okay, so after we stream back the continue response, right, like the resume, let's go ahead and just handle the error once again, because again, something can go wrong, right? Maybe network connection is bad or our database failed or something. So we have to handle the errors as well. Basically, the exact same line we have below this one, right? It's the third argument of our stream SSE. This is the first one, this is the second argument, and this is the third argument that we just added, which handles sending back the error event to the terminal in case something fails, unrelated to stream AI response, because again, stream AI response handles its own try-catch, so it will catch any errors, and it will send that and persist that in the database. So yeah, the only difference is that the errors happened in here are not going to be persisted in the database, which is okay because they are mostly like temporary errors. Anyway, brilliant. So that is everything we need for our API route, which marks this part as complete, this entire thing, in fact. And now we have to implement the use chat hook, which will be able to parse this entire API endpoint on the front end, or should I say in the terminal, so it can actually stream what happened. Let's start by adding some packages that we're going to need to develop the use chat hook. So we're going to have to add packages inside of CLI here. So let me go here, CLI, make sure you are in here. Let's add event source parser, so it's easier for us to parse these events on the front end. Another helper util pretty milliseconds, and let's just keep it at that. So those two packages, and you can see the versions that I'm using. Now inside of here, you should see those two, but let's add another one. Besides Nightcode shared, let's add Nightcode database. And oops, one thing I want to do is I want to go back to my root and just run bun install just to make sure everything is linked properly. It looks like it is. Great. So now that we have that, let's go ahead and let's build use chat hook. So inside of packages, CLI source, let's create a new folder called hooks. And inside of here, let's add use chat.ds. Let's import everything we need from React. Let's import event source parser stream from our new util, pretty milliseconds from our new package, client response type from Hono client, our API client, which is an RPC communicator with our Hono server, our util to properly parse error messages on the CLI. Let's go ahead and grab an enum from our Nightcode database package. And let's go ahead and add chat stream event schema and type supported chat model ID from Nightcode shared. Now let's go ahead and define some further types which we're going to need. Client message part, type text, text string. And now let's go ahead and create a discriminated union message type. So the first thing it can be is the following, which is a role user, content string, mode, and model a supported chat model. So that's if the user is sending a message. Then we have a second scenario, if the assistant is sending a message. Let me go ahead and be consistent and just collapse all of these so they're easier to look at and consume. And so you can see the differences more clearly. So we have user, in here we have assistant, and in here you can see we have parts, and we also have duration, because this is streamed back to us. And then we're gonna have the last one, which is the error, if something goes wrong. Now let's go ahead and do another discriminated union for the streaming state type. So streaming state can either be idle, or it can be in the middle of streaming. So for that status is going to be streaming. Parts are going to be a type of client message part, which is an array. And finally, we're going to have mode and model like we usually do. Great, so we just defined those two discriminated unions. Now let's go ahead and define the type for an active stream, which has a request ID, a controller, which is a board controller, mode, model, which is supported channel chat model ID, and parts, client message part. Now let's go ahead and define submit params, which are user text, mode, and model. Let's go ahead and create run stream params, which is mode, model, and the request, which has the controller. And now let's go ahead and export function use chat, the actual hook. So the params of use chat are going to be session ID. And besides session ID, we're also going to have the initial messages, which is just an array of our messages type. Let's go ahead and store them in a state. Let's go ahead and keep track of the streaming state, which we're going to keep track of this in an object like this. So use state for streaming is going to be an object with a status property inside. And also, I mean, it's a discriminated union. If the status is idle, it's just status. But if we change this to streaming, we're also going to have to keep track of the parts which are being emitted, mode, which is build or plan, and the model that is writing back to us. So that's why we needed that discriminated union. Now let's go ahead and define a ref, active stream ref. Then let's go ahead and create a callback to update the messages as they appear. So I'm going to go ahead and try and collapse this a bit. I'm not sure how it's easier for you to look at it. There we go. So update messages is a use callback, which accepts the updater, which is another function, which simply returns an array of messages. And in here, we call set messages with the current value, and we pass it through the callback call updater, which we are going to assign later. Now let's go ahead and create another function here, is active request, which again is a use callback with a request ID, and it will simply use our active stream ref to see if that is a currently active request so that we don't do any duplicate requests. Now let's go ahead and create a callback to emit parts. Let's start with a function, and let's not forget the dependency array. So the emit parts needs to take in some params. The first one will be request ID, and the second one is going to be parts coming from the server. So what it's going to do here is first it's going to check if the request ID is already active. So if it is not active, let's go ahead and do an early return. Now let's go ahead and create a snapshot from our parts. Let's go ahead and set the active stream to the ref. My apologies, we are not setting it here. We are extracting it. And if it doesn't exist, we do an early return. And then we set the active stream parts to our parts, which we've created a snapshot of here. And now we can go ahead and change the streaming state to streaming. And because of that, we also have to pass along these three, otherwise it's an error. So we need snapshot, parts. We are doing a snapshot, so we don't pass mutable objects here. So that's why we are doing a shallow copy. Mode, ActiveStream.mode, model, ActiveStream.model. And very important, let's go ahead and add isActiveRequest to the dependency array. Now let's go ahead and add another use callback, which is used to clear the stream. So clear stream, use callback, accepts a request ID, again, checks if it is not active request, let's do an early return, and then simply resets the active stream ref and sets the streaming back to idle. And don't forget the dependency array. So it's just like a reset button. And now let's go ahead and develop the actual handle stream callback. Let's go ahead and prepare dependency array. And let's start with the arguments here. And let's go ahead and make this asynchronous. So it's going to accept a response, which is a client response of type unknown, and then the active stream as the second argument. Again, let's go ahead and check if we are attempting to modify a request which is not currently active. So let's do an early return if it's not active. Now let's go ahead and check for the scenario if the fetch response is not okay, because in that case we have to read and extract the error message from the response, and then we have to update the messages, and we have to spread the existing messages and simply append the last message at the end, giving it a mock ID, a role of error, and content message. So this is like an optimistic update instead of refetching all messages when an error happens. And what's important here is an early return. All right. Now let's go ahead and do the other scenario, which is if everything is okay. So in that case, we have to prepare the parts that are happening. Now let's prepare the stream. So from response, we're going to go ahead and try to access the body. Then let's go ahead and do pipe through. And let's do new text decoder stream. And let's go ahead and add an exclamation point here. So we always expect the body at this point because we do an early return if there's an error. Let's make sure to execute the text decoder stream. And then we have to pipe through once again using the new event source parser stream, which we have added the package for. And this will heavily make it easier for us to iterate through the stream response. So let's do a for loop here. So for await const, and then we extract through the stream part data of each stream. Again, let's do a check here. If it's not active request of the active stream request ID, let's do an early return. Otherwise, let's add an empty variable event. And then let's open the try and catch here. Try, catch. In the try event, we're going to simply assign to the event chat stream event schema dot parse json.parse data. So we are basically just going to make sure that whatever we received is exactly what we expect. Text delta, reasoning delta, tool call, tool result, or done, or error. And in case of an error here, let's go ahead and get our message using its instance. And then again, let's do an optimistic update of the messages here. We spread all existing messages and we append the last one with a fake ID, a role of error, and the content of what happened. What's important here is to break. All right. Now that we have that, let's go ahead and decide how we are going to display each stream type back to our terminal. For example, if we have a case of text delta, what should we do? Well, let's go ahead and group them together. So we're going to get the last variable here using the last part of all parts that we receive. And we're going to check if that last part exists and it's a type of text. Let's simply go ahead and append it. Else, if that's not the case, I'm just going to go ahead and push it to the parts like that. Then let's go ahead and let's call emit parts, active stream request ID, and pass along the parts. And this is where we're gonna add additional cases for any tooling or things like that. Let's go ahead and add our done request here. And of course, we need a break here, otherwise it's gonna fall through. In the done request, let's go ahead and do protection here if it's not an active stream. And then let's go ahead and again attempt to construct full text using the parts. So we're going to filter to only get text parts using the part.type. Then we're going to map again and simply return the text value of each part. And then we're going to join it all together. And that's how we get a single string value here and not an array of strings. And now we have to go ahead and update the messages with that full text here. So we call update messages, we preserve the previous messages, and we inject the latest message, which is coming back from the assistant. So we have to preserve event message ID, role hard-coded to assistant, content is the full text we just constructed here, mode is ActiveStream.mode, model ActiveStream.model, and then we use the pretty milliseconds function, and you can see how that looks like. You can pass along the timestamp, and it will return a human-readable string, just so we don't have to develop that function as well. And we do a shallow copy of the parts here so we don't accidentally mutate it. And after we update the messages, let's make sure that we break. And now let's go ahead and do the last case, which is very simple, the error case. I just did it incorrectly. So here, in case an error happens, we're just going to update the messages optimistically like we did a few times before with the fake ID, role of error, event message, and a break. Great, so we have that resolved. And now we have to make sure our dependency array here has all of the proper functions, update messages, emit parts, and is active request. Now we have to go ahead and develop another function called run stream. So let's go ahead and develop that. First things first, let's go ahead and make sure it's an asynchronous function, and let's add the parameters it's going to need. So it's actually going to be one parameter, but we are immediately going to destruct it. Whoops, like this. We're going to have mode, model, and request all coming from a single parameter here, and it's going to be a type of run stream params. Now let's go ahead in here and let's get our controller first. Now let's go ahead and define the active stream object. It's a type of active stream. We pass along the request ID, controller, mode, model, and an array of parts. Then let's go ahead and assign that active stream to the ref. And let's go ahead and change the status of the streaming to streaming. But let's just go ahead and make it empty for now. So empty parts, default mode, and default model. And now let's go ahead and open a try and catch block here. And in the try method, all we have to do is we have to get the response and pass along the controller in the request. And once we get the response, we can simply pass it along through handle stream function, which we have developed up here. So it's automatically going to construct the stream events, update the messages, update the streaming state, everything else it needs. in case the error happens. Let's just go ahead and check what kind of error has happened, because if it is an abort error, we can just do an early return. We don't have to display the error to the user because we purposely did this. Then let's go ahead and do some protection. If it's not active request, let's do an early return. And now let's go ahead and extract what was the error if it wasn't abort error using its instance. And then we do another optimistic update using update messages where we preserve the previous message and just simply append a fake error message at the end. And let's add a finally clause here where we clear the stream at the end. So it's no longer active and it's no longer connected. And let's not forget to add all of the dependency array items we need, which are clear stream, handle stream, is active request, and update messages. Now let's go ahead and build a simpler function, which is the resume function. So yes, we need to handle all of those cases that we just developed on the backend here. So this is a huge function. That is because we are trying to replicate AI SDK's use chat, which has all of those features. Yes, it can resume, it can capture events like on finish, on error, on data. We are kind of doing that for our scenario. So we have handle stream, we have clear stream, and we are going to return all of those functions from this hook. So the user can then just easily call run stream, for example, or call resume, whatever the user needs depending on what's going on at the moment. So this will be an asynchronous function, and again, just a single parameter here, which we are immediately going to deconstruct. So we're going to get mode and model from the submit params, but we're going to omit user text so we don't get the error here, because this is technically submitting it, but we are not allowing the user to add any new text. The user can technically trigger the submit method by rejoining a session which was interrupted. So we can reuse the submit part because technically it is a submission, but we are going to extract the user text because user is not passing any new text. And in here, we just have to call our runStream function again. And we have to pass along the mode, we have to pass along the model, and then we have to pass along the request. And this will be asynchronous function, which has the controller, and it's simply going to call our API client.chat session ID.resume, which is a post request. And in here, we have to define the param. Let's go ahead and make sure that is session ID, not sessions, session. That's why we are getting the error here. And then we also have to pass along init signal controller.signal, because user should be able to interrupt the resume method just as easily. Okay, we have that. Let me just see. So that is resume here. Oh, yeah, let's go ahead and just do a return here, like this. Great. So that is it for run stream. And then we just have to add the dependency arrays here, run stream and session ID. Now, there are a couple of more functions we have to develop. Since we just developed the resume, let's go ahead and invent the logic to auto-resume when conversation ends with a user message that has no reply. So if this use chat hook is loaded with that scenario, we're going to trigger the resume method from above. So has auto-resume, the ref will be false by default, and then the only way we can resume automatically is by using useEffect here. So first things first, let's check if we have started the auto-resume. If we have, we can do an early return. Otherwise, let's go ahead and grab that last message to see what we have to return. So just like we do on the back end, we're going to do some check here. If there is no last message, and if the last message isn't from the user, it means there is nothing to resume. So we are not even going to attempt to do the resume. But if we manage to pass this if block, let's go ahead and initiate into the ref that we have started the resuming process, and let's go ahead and trigger our resume method, which we have developed from above. So pass along the mode and model from the last message that we found that we have to resume. And let's go ahead and pass in the dependency array here, which we mustn't forget, initial messages and resume. Now let's go ahead and develop a second to last function, which is the submit function, another important one. I did this incorrectly, I believe. So our submit method is going to be asynchronous, and it's going to have a single parameter which we are going to deconstruct. So user text, mode, and model, which are submit params. And we are going to construct the user message with a message type. We're going to prepare it with a random ID, role of user, content, user text, mode, and model. And we're going to go ahead and do an optimistic update here to update the messages with that user message. So we are not refetching the messages just because we submitted a new one. We are going to manually append it. That's why we are mocking the user ID here. And now let's go ahead and call the runStream method, which is going to do the following. It's going to call chat session ID. It's going to persist to the database, and it's going to start streaming back. So we need mode, we need model, and finally we need the request. Since we've already done it once, let's do it again. So request, it's an asynchronous function which has access to the controller. And in here, let's return API client, chat, session ID, not resume, but immediately post, because this is the chat ID route. And then in here, we have to pass along the first argument, which are the params and the JSON. So pass along the param, which is session ID, and pass along the JSON, which expects content, which is user text, mode, and model. And then we have to pass the other argument, which is the controller signal, so we can abort this early on if it needs aborting. Okay. And let's not forget to add to the dependency array runStream, session ID, and update messages. Now let's go ahead and develop the last one, finally, which is abort function. The abort function will not take any arguments, and it's just going to attempt to find the active stream using the ref, do an early return if it is unable to find it, reset it to null, reset streaming to idle, and go ahead and call the abort from here. Brilliant. And now from here, we can finally go ahead and return the messages, the streaming, the submit, and the abort. Now that we have the ability to stream back messages, we have to adapt our bot message component to that. So let's go inside of messages and let's go inside of bot message. We're going to have to extend the content it receives, which is no longer going to be content at all. It's actually going to be parts of a message, and we can import the client message part from our hooks use chat. Then let's go ahead and add mode from Code database enums. Make sure you add / enums for tree shaking, so when you build, it doesn't bundle it together. And now we also have duration, how long a message took, and we also have streaming as a Boolean. So let's go ahead and modify those props here as well. So parts, model, mode, duration, and streaming, which we're going to hard code, default to false. Now let's go ahead and build or reconstruct the text that needs to be rendered back. So that's simply going to look through the parts that we have. It's going to filter by text. It's going to map all text, and it's going to join it all into one string. And then we can replace the context here with text. Now we have to go ahead and improve this. So what this is actually going to do is it's going to change the color depending on the mode, right? So if the mode, let me just see mode. Oh, do I have to import it as enum? Let me check. Import type. Oh, I don't want to import it as type. So don't import it as type, just import it from enums, but not as type. All right, so yeah, if mode is plan, we use colors plan mode from our theme. Otherwise, we use colors.primary. If you ended up not implementing the theme, here's what plan mode is, and here's what primary is. So you can just hard code those hex colors. And in here, we have the same bullet point dot Unicode that we had before. Okay. And now for the model, it's going to be a little bit different. So let's remove the model. And instead, let's go ahead and open a box with flex and gap. And now let's go ahead and decide whether we should display plan or build here. So if it's plan, display plan, otherwise display build. Then let's go ahead and create a little separator. And we have to import text attributes from open2eCore. Uses colors dim separator. If you don't have that, it's this color. And in here, you can use a normal chevron. Yeah, this one, like GT. If you can't find the arrow ones. Then let's go ahead and render the model that was used after that. And only if we actually get the duration, let's go ahead and render a fragment. And then let's go ahead and copy this. So it's kind of like breadcrumbs. And finally render the duration. All right, so those are the changes needed in bot message. And now let's go ahead and go inside of screens and let's find session.tsx because this one will now need modification so it works with the new implementation, right? Because you can see content is no longer accepted here. So first things first, let's go ahead and import pretty milliseconds from pretty milliseconds. Then let's go ahead and import from Nightcode shared default chat model ID and type supported chat model ID. Then let's go ahead and import use chat from hooks use chat. And finally, let's import types message and client message part from hooks use chat. So now what we have to develop is a function to map database messages before we display them here. So let's go ahead and develop that here. Map database messages accepts messages from the session. Let's go ahead and return map database messages. And for each message, we're going to see what we have to return. For example, if a message is a type of error, let's go ahead and return an object with ID, role of error, and a simple content inside. Now let's go ahead and do, if the role is user, return role user, content, mode, and model. And finally, we have a scenario if it's the assistant message that's being returned. So in this case, we do pretty similar thing. We pass along the ID, the role of assistant, the content, the model, and the mode. But there are also other things we can do here, which are now very important, which are parts. And we also have optional duration. So let's go ahead and do optional duration here. So if duration is not null, in that case, open an object and pass along the duration to be pretty milliseconds and do this calculation. Otherwise, an empty array. Great. Now let's go inside of chat message here. And let's see all of the changes that we have to do. So if message role is user, render user message. If message role is error, render error message. And for the bot message, we now have to modify all of the props. So let's go ahead and do that. There we go. We're going to see what the error is about. Let me just fix this first. And let's fix the indentation here. So let's see what is currently happening. So let's modify the chat message here to not use session data messages, because this at this point is no longer, that's why we did the function above, to remap from session data messages into a digestible model that we can use to render here. So this is no longer that type actually, it's now using the message type, which I think I somehow made even worse. Oh, because this now needs to be error, my apologies, lowercase user, error. Yeah, we have to change the role here, because it can be either error or assistant, because that's what we map it as here. If you change this to uppercase user, you could continue using it. So just make sure that it's all in sync. Great, so we now have that, and now we have to develop another function called session chat. Which accepts the session, and that session is a type of session data. Let's go ahead and grab the initial messages using map database messages. Then let's go ahead and add our use chat function, pass along the session ID and the initial messages, and we can extract the messages, the streaming, submit, and abort. Let's go ahead and stop any pending replies if user leaves the session. So we manually call the abort first. And now we can simply reuse a bunch of components that we already have here. So let's go ahead and render the session shell, but instead of making it useless as this example where it's actually not submitting anything or doing anything, we are going to go ahead and make it do something on submit. So on submit, it will receive the user text, and it's going to call the submit method from use chat, pass along the user text, hard code the mode to build, because we currently cannot modify it, and hard code the model to the default chat model. And then let's go ahead and make sure that it displays the loading state if it is in the streaming status. And then very simply inside, it will render messages and display our chat message component from above. And the only exception is going to be if it's currently streaming. If it's currently streaming and streaming parts have begun, meaning they are greater than 0, in that case, we can render the bot message and pass along the parts, the model, the mode, and the streaming. And then when the streaming completes, this message gets hidden. But at that point, it will already become persistent in the database and updated optimistically, so it will be rendered in that component anyway. So it's a very seamless user experience. Great, and now we can drastically simplify our session here. Down here, we no longer have to do this at all. We can just do a one-line return, actually. Session chat. Pass along the key, so we can easily destroy the component if the session ID changes, and pass along the session object. Just like that. All right, now that we have that done, the only thing we have to do is add our API keys. So I'm going to show you in the environment example. So you will now need to obtain either Anthropic key, or you can obtain OpenAI API key. If you don't know which one you need for your provider, using the AI SDK, you actually go, let me go to the, how do I go to the root page? Basically find providers and models. And in here, find the one you're using. So if you're using Google, for example, because it has a free API, you can go ahead and find the documentation here, and you can see what it's going to search for. So you need to add Google Generative AI API key here, if you're using Google models, for example. Just make sure that in your models.ts, in the shared package down here, you replace the default chat model to one of the Google models you have added here. For example, I have the Anthropic key, so I'm going to go ahead and use the Anthropic key. So let me go ahead inside of .environment and let me add my Anthropic key here. You can obtain them from the official Anthropic website or OpenAI website. And once you add the key here, we should be in business. Let's go ahead and do, first of all, let me close the finished example. And let me close the finished example server. So night code, run dev server. Let's check if that works. Works. Run dev CLI. And the moment of truth. Hello, how are you? And let's see if we connected everything correctly. It is loading, it is loading. And we have streaming. It took 4 seconds to stream this. Let's do an interruption test. Write me a long message, for example. And let's see what that's going to happen. And if I press escape, nothing is happening. Yes, because we didn't implement the interruption just yet. We're going to do that next. And it is not as complicated as any of this. You don't have to worry. But yeah, we can now stream. Amazing, amazing job. In order to implement the last step, which is stream interruption, we have to go ahead and go back inside of our chat router, and we have to add the functionality to actually interrupt something. So we have a lot of things in place like abort controllers, but we don't really have the ability to interrupt and persist an interrupted message, which is maybe even more important. So let's go back inside of the server, source, routes, chat.ts. And let's go ahead and find where we start. About here, build conversation history. What I want to do is I want to have an in-memory active resume session ID set here. The reason I'm going to do this is because it is technically possible for useEffect to fire twice, and then it's going to persist the same resumed session twice. And by keeping track of in-memory here, we can prevent that on a very primitive level, but it drastically improves the experience and reduces the amount of bugs that could happen. So after the build conversation history function, let's go ahead another function here called get resumable user message. Now the messages prop is basically an array of objects. Let me go ahead and collapse this. And the messages can have role, model, and mode. We're going to go ahead and get the last message. And we are simply looking for a last message that exists and the last message whose role isn't user. So like a handy little util, so we don't have to write this function every single time. Now, let's go ahead and scroll down here until we find full text. And I want to add a function called persist interrupted message and make sure it's an asynchronous function. The first thing we're going to do is we're going to check if the full text length is 0. In that case, there is nothing to resume. Otherwise, we have to, nothing to resume. There's nothing to persist. So what we have to do now is we have to capture a message that was interrupted, and we are going to calculate how long it took to generate whatever it generated, and then we have to store it into the database, right? Even though it was interrupted. So let's go ahead and pass in the session ID, role assistant, but let's keep track that it was interrupted. Pass along the model, the content, full text, mode, and the duration. So the identical thing that we do if it's a successful one, which is this one. But instead of message status complete, we do message status interrupted so we can display the proper UI for it and so that we can know if we have to resume it later. Okay. And the only thing we don't do, if the text is empty, we don't store it, right? The user interrupted at a point where not a single letter was written, so we don't have to store that into the database, right? And now let's go ahead and find our try. Scroll down until we find stream aborted here. And we're going to go ahead and now extend it by also calling persist interrupted message. So if stream is aborted or abort controller has been called, we can persist the interrupted message like that. Now let's go ahead down here until we find catch and do the same thing before a return. Great. Now let's go ahead and scroll further down in the resume method here. And in here, let's go ahead and rename this last message into resumable message like that. And instead of calling session messages like this, what I told you before, we can now simply call our function get resumable user message, which technically does that, but returns null if it's not correct. And then let's go ahead and simply, we don't have to check for the user, we don't have to check anything, we can just check if there is no resumable message, throw the error. Otherwise, let's go ahead and check the supported model from resumable message.model. Make sure you don't accidentally use mode. And again, update this to be resumable message.model. Down here, we now have to add another if clause. So after we check for supported chat model, we also have to check what I told you in the beginning, which is the in-memory map in which we track if there is an active resume in progress. So if active resume session IDs has a session ID, let's return the error. Session already has an active resume because the use effect fires active resumes. So if it fires twice, which can happen, we are going to be protected from that. So that's the map which we developed initially. So just after you do a check if the resumed message has a proper chat model, also do a check if active resume session already has this session ID, it means that we are already streaming in progress. So we don't want that to happen twice. And if it successfully passes this if check, it means that there wasn't any resume in progress and we can successfully add that resume to in progress. So the next time it knows exactly what to happen. Now let's go ahead and wrap our return try stream SSE inside of try and catch. Let me just find the last one here. Here it is, catch. There we go. Let me go ahead and properly indent it here. And let's see everything we need to change. So stream is okay. And now what I'm going to do here is I'm going to open try and catch here as well. So try, catch, like that. Let's replace last message with resumable message. And in the finally, actually, yeah, this isn't going to be catch. It's going to be finally. Let's go ahead and delete that from our in-memory map. So basically, this resume has ended. In here, let's see what we have to do. We have to delete the session ID from here as well, even if it errors. The message extraction looks fine, the error event looks fine, and we stream SSE back. I think all of that is perfectly fine. And let's go ahead and just do catch error here. And in case the error happens, let's also make sure that our in-memory map knows that this session has successfully resumed or ended the resume. Now that we have updated our chat API route, we now have to update our use chat hook so it supports the same. So I'm going to go inside of CLI source hooks use chat. And I'm going to go ahead and find my type message. And in here, we have to extend it, the last part, the assistant part. Sorry, so not the last part, the assistant part, with an optional interrupted Boolean part. And then let's go ahead and find active stream type. And let's do the same thing here, interrupted captured Boolean. Now, let's go ahead and let's see what we have here. Submit params. Let's go inside of use chat. We have emit parts here. Yeah, let's go ahead and do it here. So I'm going to go ahead and develop a new function called capture interrupted message. Let's go ahead and prepare this callback. And in its parameters, it's going to have a single one, active stream, which is a type of active stream. The first thing we're going to do is we are going to check if active stream has interrupted captured, or if active stream parts are 0. And let me just, whoops, I messed this up. I don't like doing returns like this. I like to explicitly open the clause. And then I'm just gonna collapse this. There we go. Basically, so if the active stream is already being captured, or if active stream parts are 0, let's go ahead and do an early return. Now let's go ahead and set it to true, meaning that it wasn't the first scenario, but now it will be. Let's go ahead and shallow copy the parts. Let's generate the full text by filtering the types of text, mapping them together, and then joining. And let's then go ahead and do an optimistic update using update messages, preserving the previous messages and appending the new one with the role of assistant, and simply marking it as interrupted. So we are storing it just as we would if the message was successful. I think we have an example somewhere down here. Here it is. So this is like a successful message. But in this case, it was interrupted. So we store it in the same way. Here it is. This is what we just added. The only thing we don't do here is we don't do duration. Now let's go ahead and find, let me see where this is. Down here we have active stream, which seems to be erroring. Property interrupted captured is missing, so yes. Inside of here we have to add interrupted captured and set it to false initially. Great, we have that. And now after we do this, let's go ahead and add one more callback here. And in this callback, we're going to add the ability to stop an active stream. It's going to take a single prop, capture partial, which is a Boolean. It will first attempt to find an active stream. If there is no active stream, let's go ahead and return. If capture partial has been set to true, we're going to call capture interrupted message function, which is going to then add it to our optimistic update state. And then let's go ahead and set the active stream back to null because we just interrupted this one. Let's set the streaming state to idle. And let's go ahead and call active stream controller abort. And let's pass along the capture interrupted message in the dependency array. And just a few more things we have to do. Let's go ahead and find the submit method now. Here it is, the submit method. And in here, before we define the user message, let's go ahead and make sure that we show partial answer before sending the next message. So just set the stop active stream and set it to true. So we persist the message that we just submitted. And now we also have to add this to the dependency array here. Great. Now let's go inside of the abort here, and we're gonna have to modify this a bit. Actually, it's much simpler now. Okay, it's easier if I just clear everything here. So we're gonna start by calling stop active stream like that, and simply add that to the dependency array. And then we need one more function, which is super simple, interrupt function, which stops the active stream but sets this to true. Basically, we are distinguishing between wanting to persist a interrupted message or not persisting an interrupted message. And let's go ahead and make sure we export the new interrupt. Great, so those are all the changes that we need to do with use chat. Now, let's go ahead and go inside of our session shell. So inside of packages, CLI, source components, let me find the session shell component. We are simply going to extend it by expecting interruptible. Basically, this will decide whether we are going to show an indicator to the user that the user is able to interrupt something. So let's go ahead and find the loading spinner here. And let's extend this by not just displaying the spinner, but displaying a fragment with both spinner and, if interruptible, a text escape to interrupt. So the user knows that they can do that. Okay. Now let's go back inside of the bot message. And in here, we have to maintain the UI if this was interrupted. So let's add interrupted. Let's go ahead and add interrupted here and make it false by default. And let's see what we should do now here. So besides maintaining the color of this little bullet point for plan mode or build mode, we also have to maintain it now if it's been interrupted. So we're going to go ahead and do it the following way. We're going to render a text. It's going to have attributes. And if it's been interrupted, we're going to use text attributes.dim, otherwise set it to 0. And the foreground is also going to check if it's been interrupted, then it's going to fall back to undefined. Otherwise, it's going to check if the mode is plan, and then use colors plan mode, otherwise fall back to colors primary. So basically a combination of what we had before. Now, inside of here, where we have the mode plan build, we have to kind of do a similar thing. So it's exactly the same in here, but what's different is that we add attributes and make it dimmed if it was interrupted. So basically just working on some indicators so the user knows this was interrupted. Now down here, let's go ahead and extend this not only for duration, but if duration happened, if duration exists, if it's greater than 0, and if it's been interrupted. In that case, so if any of those two are true, then let's go ahead and open this. And then what we're going to do is we're going to decide what to show. So if it's been interrupted, we're going to show the text interrupted. Otherwise, we're going to render the duration. And I believe there is just one more file that we have to modify before we are done. And that is the session itself. So CLI source screens session. So let's go ahead and just import use keyboard from OpenTUI React. Then let's go ahead and import message status from Nightcode database enums. And let's go ahead and import use keyboard layer so that we can properly decide who owns the keyboard. So let's go ahead and find the map database messages function here. And I believe somewhere here we are missing the interrupted state. So it's going to be interrupted if message status is message status interrupted. So we have to maintain that in the UI view as well. Let's go ahead and find the chat message here. And let's go ahead and find bot message. And let's go ahead and keep track of the interrupted state as well. Now let's actually implement the hotkey, which will cancel the message while it's streaming. So I'm going to go ahead and add is top layer from use keyboard layer. I'm going to go ahead and extract interrupt from use chat, which we just added. And then after my use effect here, I'm going to go ahead and let the user cancel a reply even before this first stream chunk arrives. So use keyboard, looks for escape, checks if top layer is base. So if you don't have any models or command dialogues, so only if it's at the base layer and hits escape, then we're going to call interrupt. But also only if it's streaming. Otherwise, we have nothing to interrupt. Perfect. And then at the bottom here, besides loading in the session shell, let's also keep track if the session shell itself is interruptible by passing along the streaming status. And I believe those are all the changes that we have to do. Let's go ahead, moment of truth. Write me a long message. And then once it starts, I'm gonna hit escape. And just like that, we are able to interrupt it. And let me go ahead and do what were we talking about. Let's see if it has any persistence. Again, this will depend on the model. And you can see it understands. You asked me to write a long message. I had just begun writing before you followed up with this question. Perfect. So the interruption works. The messages are being persisted in the database. And yeah, it works. You can see the UI is grayed out. You can see how it looks when it's complete. Brilliant. Truly amazing work. Really, really, really amazing work. I believe it looks like we have some unused variables here. I'll see what's up with that. But we've done so much work here. There's just one more thing I want to do now. I want to go inside of my inside of my server source package JSON, and in here I want to add a build script so that we can start having proper CI/CD, which is going to be super simple. Don't worry. So that we can start getting close to production instance rather than just a development instance. So the build script is going to look like this: bun build source index.ts out dir dist target bun. But we also need a post install script because we are using Prisma. So let's add post install bun run. Let's change directory to database. So it's going to find the directory database and call database generate. Though I think, do we have that? We do, database generate. So just make sure you have that script in here. Great. And that is all we need right now. So let's leave it at that. And let's go ahead and git checkout B05. This is AI chat streaming. Okay. Git add, git commit 05 AI chat streaming, git push u origin 05 AI chat streaming. Brilliant. Let's go ahead and open a pull request now. And let's review it. Here we have the summary. We added streaming chat responses with real-time messages, ability to interrupt in progress, support multiple AI providers, enhanced messages display showing model, mode, generation, duration, and interruption status, and we added API configuration for Anthropic and OpenAI providers. And we only have 2 comments, which is great considering the amount of work we did, meaning not a lot of bugs were introduced. In here, we have a minor issue. Again, a missing dependency in use callback. I should probably add update messages here, but the good news is that update messages is pretty stable. It has empty dependency array, but still, I don't like the fact that we have a missing one. So let's go inside of use chat. Let's go ahead and find interrupted message, capture interrupted message, and let's simply add updated messages to the dependency array here. Let me see if that's the fix. It is. And in here, it says not to use non-null assertion on the response body, which is typically safe after checking response.ok. So yeah, that's kind of why we are doing it. So I'm just going to leave it as is. Yeah. I mean, we could technically do this, but it's okay for our use case. It's completely okay. So I'm just going to go ahead and commit a fix for the updated messages here. So git add, git commit, incorrect. So this is 05 AI, what's the name of the chapter? AI chat streaming fix, git push. And this time I can just do git push because I had a -u flag. Otherwise you have to set upstream to push. If you have the error, it will tell you exactly what you have to do. Or you can look at the previous chapter where I had the error with git push and how I resolved it. Great, and that will definitely fix our issue. So let's go ahead and merge the pull request. And let's go ahead and do one important thing. So we currently don't have CI/CD in place. Let's go ahead and head to Railway and let's add our current project inside of here. Using the link on the screen, by the way, you can get $20 in free credits. So let's just go ahead and open a new app, GitHub repository. And I'm going to go ahead and select Night Code here. And it will immediately recognize that it's a mono repo and it's going to add all of them here. So what I suggest is that we go inside of the server one and we focus on the variables. Let's click on raw editor here. And let's copy everything that's inside of .environment. So I'm just going to copy all of that and paste it here. Accept the API URL. Technically, API URL can be replaced with whatever is the production instance. But I'm not sure API URL is even used anywhere in the server. So I think if I search in the server package, yeah, it's not used here. So it doesn't matter. We can leave it anyway. So make sure you add those. And technically, you don't need CLI here. You don't need database here. Both are going to fail. But let's just go ahead and hit deploy so you can see how that happens. Basically, we added a build script for Nightcode server, but our Nightcode CLI is not properly aligned to be built, and our Nightcode database isn't even intended to be built, right? So it's completely normal for these two to fail, but this one is what we want to succeed. You don't need to do this to complete the project, but if you are planning on going to production, you will need your app hosted somewhere. And what I want you to show is how easy it is to do it with Railway and how easy it is to actually add CI/CD with Railway as well. So while this is building here, let me go inside of project settings. Let me go inside of environments here. And one cool thing you can do is you can enable PR environments. And once you do that and select the production as the base environment, it will automatically create a preview every time you open a pull request. So we're going to see that active in the next one. Just make sure you select production as the base environment. Cool. So let's go back to our architecture. This failed as expected, but we are focusing on the Nightcode server here now. And there we go. Deployment has been successful, meaning our scripts are all working. And now what we have to do is we have to go inside of settings, networking, and we have to click generate domain. Let's see. It automatically found port 3000. So if you didn't have the generate a domain button, you probably had to enter the port. So the port is 3000. And then you can copy this and you can go ahead and try adding it and you will see 404 not found. But if you try and go to /sessions, for example, or which one is it? Is it API sessions? Let me go ahead and find a route that works. Yeah, it was sessions. It just didn't load the first time. And you can see that now in production, we can see all of our routes, my apologies, all of our sessions. So we have successfully deployed our server on Railway now, and you can actually get rid of these other services like CLI. This can come in handy later. For example, you can connect this with Homebrew or something, and then it will automatically create a binary for your CLI app. But for now, it's just taking up space. So I'm going to remove CLI and database from here. I'm going to type in this to confirm, and that will just delete those two because we only need the server one anyway. Beautiful. So it was that easy to do. And from now on, any subsequent pull requests that we open are automatically going to be generated in its own instance using the environment keys from the production instance that we have added here. So you will be able to test every single time if it's working or not. Brilliant. So that marks the end of this chapter. We have a working interruption, working streaming. We even have the build script, and we added CI/CD. So many things we did in this chapter. Amazing, amazing job, and see you in the next one. One thing we forgot to do is switch back to our main branch and git pull origin main. So this way we are completely synchronized with our main branch. In this chapter, we're going to add session management and prompt configuration to our project. In step 1, we're going to implement session management by creating a session dialog, which is going to use our existing dialog search list component, which is filterable and navigation is working through both keyboard and your cursor. And that component is going to call our existing API sessions route. So we are not going to have to implement anything on the back end. This will be quite a simple implementation. And once the user selects one of the existing sessions, we are simply going to navigate through that session. We're going to add a package called datefns so we can nicely format timestamps for each of the sessions. And we are going to enable a command called new to simply redirect back to the home page. That's going to be step 1. And step 2 is going to be prompt config. We're going to implement a prompt config provider, which is going to maintain mode and model that the user chooses. Mode can either be build or plan, and it can be switched using the tab key or by using the agents dialog. Model can be whatever you yourself define as a supported model. We used Opus, Sonnet, GPT models, but you can of course add Google models, Grok models, whatever you prefer. And they can be changed using the models dialog. Both model and mode will be wired up to the status bar so that they show the relevant information. Now I'm going to show you exactly how that looks like. So this is what we're going to have by the end of this chapter. Using the tab key, you can switch the mode. And if you manually type in agents, you will be able to switch that as well. And for the models, you will be able to change them here. Let's go ahead and implement that. The first thing we are going to do is we're going to go inside of our CLI package. So make sure you are inside, and we're going to add datefns. This is the version that I'm using, and I'm just going to confirm that I did this correctly by looking at my code here. And as you can see, inside of my packages, CLI package JSON, I have datefns added to my dependencies. Great. Now, we're going to go ahead and implement the dialog component that we need. So this is going to be called sessions dialog. Let's go inside of packages, CLI, source components, dialogs. In here, I'm going to add sessions dialog.tsx. Let's go ahead and add all the imports that we're going to need. So use callback, use effect, and use state from React. Text attributes from Open2E Core, format from our newly installed package, use navigate from React Router, and then from the providers, we're going to need use dialog from dialog providers, use toast from toast provider, API client from our library, get error message from our library, and dialog search list from our dialog search list component. Let's go ahead and create a type for this session here, ID, title, and created at. And let's go ahead and export this content here. So I'm going to go ahead now and create a state to maintain my sessions that I load. The reason I'm typing the type here manually instead of inferring it is because it's a specific type. As you can see in my routes here, when we do get, we only select ID, title, and created at. So this is like a quick way of doing it. If you want to, you could use infer. I think we do this in CLI. Yeah, you could technically do this, infer response type. For example, you could do that. I just want to show you. You could import this API client sessions ID get. And is that really it? Oh, yeah, not that one. Not get by ID, just get. And then you will have to specify, I think, like a number. And then that would be session. So yeah, technically you could do this as well. This is like strictly inferring that. And let me just check. In here, we import this from Hono client. In here, we import it from Hono. I guess it's better if we use Hono client. I think 3-shaking works better that way. But yeah, basically, whatever one you prefer. If you want to infer it, which is technically more correct, we could do that. And then the state is exactly the same as if it would be if we manually typed it. Then let's go ahead and add loading. And then let's go ahead and add the ability to close the dialog. And finally, let's add 2 more, the navigate and show for toast. Now we have to open up the use effect, which we're going to use to fetch all of our sessions. So inside of this use effect, first things first, let's go ahead and maintain the ignore constant. I mean let, which we can use in case of an unmount. So when it unmounts, it's going to turn it to true. And then we can break the API call early if that happens. So let's develop the asynchronous fetch sessions function. It's going to have a try and catch method. In the try method, we're going to use the API client to call sessions.get, which is exactly what we are inferring here. And if the response is not okay, we're going to go ahead and throw an error and standardize it. Otherwise, if it is okay, let's go ahead and destructure the data. And if not ignore, let's go ahead and assign that data to the state and set the loading back to false. So we have to be careful to not do any set states if we have already unmounted, as that is going to cause an error in React. Let's go ahead and handle the error now. So again, it only makes sense to do this if not ignored. And what we're going to do is just go ahead and show a variant of error and a message and close the dialog. And we must not forget to actually fetch sessions like this. In the dependency array, we're going to go ahead and put close and show. Because of that is why we destructured it, because usually we do dialog and then we do dialog.close, but since we have to put it in the dependency array, we destructured it. And just like that, we can fetch our sessions. Let's go ahead and create a handle select function, which is going to close the dialog and navigate to sessions session ID. It's going to navigate here because we defined that route. Instead of CLI source, I think it's index right here. Here it is, sessions ID. So make sure you don't misspell that. Great. Let's go ahead and add a very primitive loading state, which will simply in dim text say loading sessions. And finally, let's go ahead and render our dialog search list. Our dialog search list is going to have the following attributes. We're going to add items. We're going to add onSelect. we're going to add a filter function to query by the title of each session. And then we're going to add the render item function, which is going to render a fragment. And within that fragment, we're going to render the session title. If it is selected, it's going to be black. Otherwise, it's going to be white. We are then going to make a purposeful empty box, which is simply used for spacing. And then we're going to render the timestamp when that session was created, again with dynamic selection of the foreground color and some attributes here. And we are using datefns format to format this date. And we need 3 more attributes here. Get key, so we know which is the unique key of our data, placeholder, and empty text. And it's actually a self-closing tag, so we can remove everything else. And that is it. That is our entire dialog. Not that difficult to implement. Now let's go ahead inside of the dialogs index.tsx, and let's go ahead and do a barrel export here. Sessions, dialog, content, sessions, dialog, like that. Now that we have that, we can go ahead inside of our source components command menu, commands.tsx. We can copy the action from our theme action, and we can find our sessions. And let's replace this action, and let's go ahead and change the title here to be sessions, and let's use sessions dialog content, which we can now import from the same place as theme dialog content. And just with those 2 changes, if I run run dev server and run dev CLI, let me go to the root. And if I run models, my apologies, sessions, I should be able to load all of my sessions. Let me go ahead and try and pick one, and let's see what happens here. You can see that it auto-resumed. That could be because it's one of the older ones that we have. Let me try one of the newer ones, like write me a long message. You can see that we exactly have all of my interrupted messages, and when I asked it what were we talking about, to prove that it had the context. So we are successfully proving once again our previous branch is working correctly. And if you try any of your older ones, it will most likely automatically start to respond to something simply because it assumes it's waiting for an answer. That's our auto resume functionality. So before we had the streaming functionality, we just stored user messages in the database. So if we revisit those sessions, they're going to automatically start streaming back to us. So just like that, we finished step 1. Let's just not forget to add the new command here. So in order to do that, we actually have to do the following. We have to go inside of command types here. And besides exit, toast, and dialog, we need navigate, which is a function which accepts a string and returns a void. And once we have that, we can go back inside of the commands, find new, and inside of this action, let's simply do context.navigate, and let's go ahead and navigate to the root like that. We are not done just yet because we have to go inside of the input bar right here, and we have to provide navigate here. The problem is we don't yet have navigate, so let's make sure that we first add the proper import. Use navigate from React router like that, and then let's go ahead and let's just render it somewhere just like that. And let's not forget to add it to our dependency array. So renderer toast dialog, we are talking about handle command function where we just added navigate, and let's add navigate to the dependency array. And just like that, that should be completely finished. So if I now go into one of my sessions here, perfect. And if I type new, back to home screen. Beautiful. That is step 1 finished. And now we have to go to step 2. In order to implement the prompt config, we have to create the provider. So let's go inside of CLI, source, providers. And in here, let's go ahead and create a new folder, which we are going to call prompt config. Inside of the prompt config, let's go ahead and create an index.tsx. I'm going to go ahead and add all of the imports that we are going to use. That's going to be create context, use state, use callback, React node type, default chat model ID, and type supported chat model ID from Nightcode shared. And finally, mode from Nightcode database enums. Let's go ahead and define the type for this provider. So what's the value of it? It will maintain the current mode, the option to toggle a mode, the option to set the mode. It will maintain the model, which is a type of supported chat model ID, and it will have a function to set the model. Now let's go ahead and create this context. Then let's go ahead and create the use prompt config hook, which is going to take care of making sure that this hook is called within a prompt config provider, and it needs to return the value, very important. And now let's go ahead and define the type for the actual provider, which is just the children. We've done this a couple of times already. They all follow the same practices here. And in here, we're going to maintain 2 states. First one is mode, second one is model. The default mode is going to be build, and the default model will be whatever we have defined in our shared package, which for me is Claude Opus 4.6. You can command click here and change it to one of the other supported model IDs. Once we have those states, let's go ahead and create a memoized toggle mode function. So if the existing mode is build, the toggle will switch to plan and vice versa. And finally, let's go ahead and return our prompt config context provider and pass along the value which has mode, toggle mode, set mode, model, and set model, and encapsulates the children. Great. So that is our provider. Now we have to go inside of index. Actually, not inside of index, inside of layouts, root layout. And in here, around theme, the root, let's add prompt config provider. The order does matter, so make sure that you do it in the correct place. So prompt config provider. Great. Now, let's go ahead and modify our status bar so that it is connected to that instead of being hard-coded. So this is the status bar. Currently, it's hard-coded. So now let's connect it to that config provider. So inside of CLI, source components, let's go ahead and find our status bar component. And in here, I'm going to import use prompt config, and I'm going to extract mode and model from it. Then I'm going to remove the hard-coded build text here. And instead, I'm going to render the following. And we have to import mode from Nightcode database enums. So foreground will be different depending on the current mode, so either plan mode or primary. And the text will be different depending on the mode, either plan or build. And the last thing, let's go ahead and change the hard-coded text here to render the current model. Just like that. We can save, and right now, out on the start, nothing will really be different. It's still going to look exactly the same. But go inside of prompt config here, and let's go ahead and change the default. How about I change this to plan mode? And how about I purposely do test 1, 2, 3, even though it's going to throw an error? You will see that that's exactly what gets rendered in the status bar. So we have successfully wired those two together. Make sure you revert your changes and save. Perfect. So that is a status bar taken care of. So what I want to do next here is the toggle functionality. So for that, let's go inside of the input bar. And I'm going to go ahead and add the following imports here. I'm going to add use prompt config. I'm going to add mode from Nightcode database enums. And from my OpenTUI React, I'm just going to extend it to also have use keyboard alongside use renderer. So use keyboard, use prompt config, and mode are the new imports that we have added. Now let's go ahead and use our new use prompt config hook, and let's extract mode, toggle mode, and set model. Now let's go ahead and find our handle command function, and let's extend the command context by passing along the mode, and set model. And let's go ahead and also add all of those here. Mode, set model, like that. And let's go ahead and create the toggle function. We can do that. Let's see, where should we render that? How about here? Before this use effect, it really doesn't matter because this is also somewhat of a use effect, which actually just adds the event listeners. So add this use keyboard, which returns early if disabled, returns early if top layer is not base, and only if key name is tab calls toggle mode from use prompt config. And just by adding this, you will be able to toggle hit tab, and you can see this changes. You can see a bug here. This is not changing the color. Let's go ahead and resolve that. So scrolling down here, you can see we have hard-coded it to colors.primary, and we can very easily fix that by checking if the mode is built, then use primary, otherwise use plan mode. Let's try it again. There we go. It's fixed now. Now, let's go ahead and add the proper types to our command context. So for that, we have to go inside of packages, CLI, source, components, command menu, types. And after navigate, let's add our mode from database enums and our supported chat model ID from Nightcode shared. And just like that, if you visit input bar again, you should have no errors in your code because now all of those that we have added are supported and even expected. Great. So now what we have to do is we have to build the models dialog and the agents dialog. Let's start with the agents dialog first. So I'm going to go inside of dialogs and I'm going to copy my theme dialog and paste it, and I'm going to rename it to agents dialog. Let's go inside of the agents dialog and let's go ahead and rename it. So agents dialog content. Let's go ahead and create a type, agents dialog content props. Let's import mode from Nightcode database enums, and let's not import the, let's not import it as a type. Let's import it like this. Let's go ahead and create a little helper, get mode label. So if it's plan, render plan, otherwise render build. And let's go ahead and add some props here. Current mode and on select mode. Inside of the actual dialog here, I picked a bit of a complex component. Okay, let's simplify it. So we have dialog, that's good. We don't need theme, we don't need this, we don't need this, we don't need the use effect. We just need handle select. And inside of handle select, we're going to maintain one thing, and that is the next mode that we are passing. And what's happening on select is very simple. On select mode, something's very broken here. Let me check. Okay. We choose on select mode into that next mode, and we pass along the on select mode into the dev dependencies. And we don't need handle highlight at all. So this is a much simpler component than what we had. Let's remove the use theme. Let's remove use effect and use ref from React. Let's remove the type theme. All that's left is to fix the rendering in the dialog search list. So items are going to be available modes. and we are going to create available modes ourselves. So it's just going to be an array of mode build and mode plan like this. So let's have that. On highlight isn't going to be anything. Filter function will be get mode label. Oops, let's do get mode label and then pass along item. And let's use item like this. So that's how we're going to do it. Get mode label, basically either plan or build, lowercase it, and see if the user's query includes that title. The render item will also be much simpler. So it's just going to be text with a different foreground, depending on if it's currently selected or not. We're going to render a bullet point if the item matches the current mode, and we're going to render its label. For the get key, there isn't any property other than the name itself, so we just return that. And let's go ahead and change the placeholder and the empty text. Search modes, no matching modes. You can also do search agents, no matching agents, because they are technically like agents, right? Let's remove the theme entirely. And once we have this now, let's go ahead and register it in the index here. So from our agents dialog content like that. And let's go ahead and go inside of our command menu, commands.tsx. I'm going to add agents here. Let me add a trailing comma here. And I'm going to, let me find and let me copy sessions. Let me find agents and let me replace the action here. And in here, it will be select agent. And we are simply going to render agents dialog content. Whoops. And let's go ahead and pass in the current mode, context.mode. And on select mode, context set mode. Like that. And now, even if you do agents, you can switch it through there. Now let's go ahead and do the same for models. So I'm going to go ahead and close everything here. And I'm going to copy my agents dialog. And I'm going to rename it to be my models dialog, like that. And in here, let's go ahead and change the type here to be models, which is going to use the supported chat model ID. So models and on select model. Let's remove the available modes constant. We do not need it. Let's remove the get model label helper. We don't need that either. Let's rename the function to models dialog content. Let's rename the props to models dialog content props. Let's change this to be the current models and on select model like that. And let's go ahead and change the handle select here to accept model ID, which is a type of supported chat model ID. Call the on select model and then close the dialog. Items are very simply going to be models. Filter function is going to filter by model ID. So see if user's query matches the model ID. Render item will be even simpler. We're not going to maintain which is the currently selected one. We're just going to render all of them like this. So model ID is selected, as simple as that. Get key can technically stay the same, but if you want to be more descriptive, you can call that model ID. And then we're going to have the placeholder and the empty text here. Great. Now that we have that, we also have to register that in the index. So let me just copy this. Models dialog content from models dialog. Perfect. And all that's left, I believe, is to map that in the command menu commands here. So let me go ahead and copy the action of my agents. Go inside of models and replace this action here. So let's go ahead and see what we have to change. The title here will be select model, and the children are going to render models dialog content, and we're going to import supported chat models from Nightcode shared, and we added models dialog content from dialogues. So these are the existing available models, and on select model we are calling context set model. All right. And now if you go ahead and search for a model, you can see that it is selected. If I hit tab, that gets selected. Brilliant. So we now have a way to call different models. So for example, if you try and do hello world here, I think this might even fail now. Oh, yeah, it's still calling Claude Opus because this isn't really connected. And let me see. I think that there is one more thing that we have to do here. I'm not sure if I planned on doing this later or not, but let me just check. First, let me check all of the changes I did. Import mode, okay. I'm thinking about session shell component. Let me find it. Components, session shell. In here, I have this spinner, and the spinner uses a fixed color. I'm pretty sure I have to modify this. So what I'm going to do is I'm going to import mode from Nightcode database enums. I'm going to give this spinner props, which accept an optional mode. I'm going to go ahead and mark this mode as default of build, and I'm going to change the active color depending on the mode. So if it's plan, it's going to use plan mode. Otherwise, it's going to use primary, and then I'm going to switch the active color to be that. Now, the only thing that I have to check is that inside of session shell here, I somehow passed the mode option. And let me just check how can I do that. I think the simplest way is to just call the use prompt config like this. Just use prompt config from providers prompt config. And now if I go ahead and switch to plan mode and do hello world, yeah, you can see how this now changes to that color as well. So everything is kind of in sync. Obviously, what's not in sync is this, because in the backend, it's not yet persisted to use that plan mode. Okay, so I'm quite happy with how this turned out. One thing I'm not too happy about is how in agents dialog, more specifically maybe in commands, how we have to pass the current mode and the onSelect mode through the context rather than directly doing it inside of the agents dialog content. But I think the reason I did this is because if you import use prompt config here, I think it will break because it somehow gets rendered outside of the composition it's supposed to be in. And what I mean by that is this. The dialog provider, as you can see, is rendered before prompt config provider. So if you attempt to import use provider here, it's going to break. But I think that if you change the order, like wrap this above, it introduces even more problems. So if you were wondering, like, why did I pass all of those actions through the command context, it's because of that. All right, great work. Let's go ahead and commit those changes. So chapter 6, session management configuration, git checkout -b 06 session management and config, git add, git commit, 06 session and config git push -u origin 06 session management and config. Brilliant. Let's go ahead and compare and pull request. And what's going to happen now, since we've added Railway in the previous chapter, is that besides CodeRabbit, we are also going to have our CI/CD happening on Railway. You can check that by going inside of Railway, inside of your settings and environments. And in here, you can see we have a PR environment specifically for 06 session management and config now, and it's being built. And here we have the summary by CodeRabbit. We can now press tab to toggle between build and plan mode. Agent and model selection dialogues are accessible via command menu. Sessions management dialog with search functionality is available. Status bar now dynamically displays the current mode and selected model. We enhanced UI with mode-aware visual indicators, and spinner color reflects the current mode, build or plan. As you can see, Railway has also deployed Nightcode server. If yours hasn't, go ahead and change from your production environment to Nightcode, and you will see a deploy button, and you can just hit deploy, and then you will have this indicator right here, which is really cool that for every pull request, you can confirm that Nightcode server service is up and running and wasn't affected, and it's still working. We have one comment here, and it's telling me that the list contains modes, but the placeholder states agents. Yeah, technically they are agents in a way. Basically, whether you put modes or agents, same thing, it doesn't really matter. So I'm going to resolve this conversation, and I'm going to merge this pull request. And I'm not going to delete any branches, so I can keep track of all of my progress here. All I'm going to do is git checkout main, git pull origin main. And that's going to ensure that I have synchronized all of my changes and that I'm on my main branch. Brilliant. That wraps up chapter 6. Amazing job, and see you in the next chapter. In this chapter, we're going to add tool calling to our project. We're going to achieve this in 2 steps. In step 1, we're going to modify our current way of streaming text, which is basically just a flat text, and we're going to modify it into ordered message parts. These parts can be reasoning, tool calls, or the classic text that we have right now. Reasoning will look like this. It's basically going to display thinking with a dimmed border, and then it's going to display the thinking that the model is doing. Tool call will display the name of the tool and any arguments that it received, such as the path it wants to read. It will also display the status if it's currently calling it or if it has finished calling the tool. Then in step 2, we're going to turn on the mode in the backend. So if the user selects plan mode, we are going to limit for read file, list, grep, and glob, basically read-only tools. And if the user selects build mode, we are going to enable write file, edit file, bash, basically all of these plus all the write functions. Which means we're also going to build our system prompt, and we're also going to work in the agentic loop function, which you're going to see all about in a moment. So let me show you what you're going to have at the end of chapter 7, which is basically the most important part, because this is what enables our harness into becoming more than just a text streaming service. So in this finished chapter, if you go ahead and do something like a switch to plan mode and ask it, what is this project about? It will be able to call various tools, display its thinking, and it will give you the output based on what it reads from all of the files and everything in here. There we go. You can see it gives me back the result. And of course, we will still be able to interrupt that and everything else. So that is the plan. Let's go ahead and implement it. Let's go ahead and start by modifying our chat API route. So we're going to go inside of packages, server, source, routes, chat.ts. in here, we are going to go ahead and import Prisma type from our database. So let's go ahead and just add that. And then we are going to go ahead and extend our shared package imports. Right now, we are only importing type chat stream event. So now let's go ahead and also extract message part. Let's extract tool arguments schema and message parts schema, which we have prepared before. Now let's go ahead and modify our function called stream AI response. Currently, this is optimized to only stream text. Now we are going to modify that. So let's go ahead and add parts, which is basically an array of message parts, which can be reasoning, tool call, or text. This is something we have defined in our shared package in the schemas here with this Zod functionality. Now that we have the parts, we can get rid of the full text for now. And let's instead go directly inside of the persist interrupted message. Let's go ahead and remove this clause. And let's go ahead and simply generate full text by filtering for text only instances of all of the parts that we have, map them, and join them all into a single string. We've done something similar before. So this is how we decide, okay, this is all the text that we have. And then instead of doing the check outside, we're going to do the check in here. So if that text we just created is empty, or in general, if all of the message parts are empty, let's just go ahead and do an early return. I like to explicitly open the brackets like this. What we have to do now is we have to validate our parts. So I'm not just going to blindly return all the parts that we are getting. I want to make sure that they are correct. So validated parts will be a type of Prisma input JSON value. And the reason that we are using input JSON value is because of our schema Prisma. When you look at our message, we store parts in a JSON object simply because they can be too various for us. I meant to say they can vary a lot. So that's why we are making use of Postgres JSON field, because it's kind of dynamic. So we are just using it here. So we have the exact value that our database expects. And basically what we assign here is, again, we check if it's greater than 0, and then we parse them through our message parts schema. Basically a discriminated union, which checks if the part that we received has a type of reasoning, it has to have text. If the part we received has tool call, it needs to have ID, name, arguments, and result. And the same for text. So we are basically using Zod to quickly validate that whoever calls this function, persist interrupted messages, has completely valid streaming types that we can work with, because we have to be careful about what we can store in our database. And now we can just go ahead and add those parts JSON to our database. And since we defined it as an input JSON array, we don't have to worry. Great. Now let's go ahead down here until we find messages, history, abort signal, and inside of AI stream text, let's go ahead and pass along the provider options, which is going to call resolve the model dot provider options. We are going to fix this type error in a second. Let's just make sure we don't forget to add this. All right, now instead of this for loop, let's go ahead and add another if clause after this break check, and that will be if part type is reasoning delta. That means we are currently streaming back what the LLM is thinking. So let's go ahead and get that last part that we have, and let's confirm that that last type exists and that it is reasoning. And if it is, let's go ahead and append last.text to part.text. I mean, vice versa. Let's append part.text to last.text. In the else here, let's go ahead and do parts.push type reasoning text part.text. And then let's go ahead and generate the event we are going to stream back. So this is the event, type reasoning delta, and given that we have this discriminated union, we know, okay, if it's reasoning delta, we need to provide the text or what the LLM is thinking, and that's what we are going to emit right here. So let's go ahead now and await stream write SSE and pass along reasoning delta and stringify the data event. Great, so that is resolved for any thinking, and now we have to modify the text delta. So what I'm gonna do is I'm gonna remove the full text, and I'm gonna go ahead and get the last as I did before, and then I'm gonna do the same thing I did above here. I'm checking if last exists, if last is type of text, and then I'm appending part.text to last.text. Else, we are going to push into parts type text, text part.text. So basically, either add more content to what's currently streaming or start a new part, right? I feel like I didn't explain this properly. This is basically grouping it, right? So if the previous reasoning was already happening, right? If the last part of the streaming was reasoning, we're just going to append new text to it because it is still a reasoning, right? So we don't have to display an entirely new section in the terminal saying thinking, 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 thinking. We can just show thinking once and then just append new lines one beneath another. That's why we are checking. Hey, is the last part still reasoning? If it is, we can just append the text. But if it isn't, then we have to push a new part, right? We have to like stream back something new. That's what this logic is doing. I feel like I just went through that without explaining it. My apologies. So same thing here. If we know that it's currently rendering text, we are not going to create any new sections. We're just going to keep appending that existing text. But if the last part was reasoning, well, in that case, we have to push a whole new part and a whole new variant. That's what that is doing. Okay, so that is text delta. Now, let's go ahead and add a tool call here. So what happens if we hit a tool call? The first thing we are going to do is making sure that the arguments can be validated. So part.input, can we validate that against our tool call argument schema, which is a very broad definition object, but at least we can parse something so we know it's not something completely random that will break the app immediately. And let's go ahead and push that part. So type tool call ID, part tool call ID, name part tool name, and the arguments. And since it's tool call, we know that that's everything we need here. Now that we have that, let's go ahead and construct the event that we are going to stream back. Here we have it. And let's go ahead and actually stream it. So stream write SSE event tool call and stringify the event under data. Make sure you didn't misspell any of the tools here. But even if you do, you will get an error because of our extreme type safety that we are following here to make it easier for us to code. So that is tool call. And now we have to handle tool result. Basically, we have to modify the streaming in a sense that it started calling a tool and then it finished calling a tool. So we have to update that indicator. So let's go ahead and define the result string to check if type of part.output is a string. If it is, use part.output. Otherwise, stringify whatever is passed in part.output. So this depends on the provider and on the LLM model that we are using. So we are basically now creating some functions and some checks to make whatever our LLM is returning within the tool result into text. because they can return objects, they can return a bunch of things. So we're checking, is it just a normal string? If it is, let's go ahead and just output it. If it's not, let's stringify it into something readable. And now we have to go and find an existing tool part, which we started streaming here and appended to our parts.push. We have to find it by ID, and we have to update by giving it, let me show you, by giving it the result. You can see how right now there is no result. Why? Because at this point, we are just initiating the tool call. So in the tool result, what we have to do is we have to find tool call part using parts.find. In here, I'm doing kind of an ugly TypeScript, but it does help with the strictness here. And essentially, within parts, we are looking for a part. Let me show you how this looks without TypeScript, so you can see that it's not such a complicated function, actually, right? It's just this. But if you define this, then it will be very strict onto what P can be, and then this will have more sense. So we are looking for part type, which is tool call, and part ID matches the current part tool result tool call ID, because the tool call ID is going to be identical to this one, which started the tool call event and is now calling the tool result event. So now that we grab that TC part, let's go ahead and append the TC part dot result to our result string. And now let's go ahead and construct an event, tool result with the result string. And let's go ahead and write SSE, event tool result, and stringify back the data. Great. So we now have that. Let's go ahead all the way down here until we find elapsed in milliseconds. And let's go ahead and add another full text string here by querying over all the parts and only filtering those that are actual text. Let's go ahead and do another validated parts here. So we are again using Prisma input JSON value. We are checking if parts.length is greater than 0. If it is, we are running it against our Zod message parse schema validation, and otherwise we are marking them as undefined. And then once we have validated parts, we can go ahead and pass it in the database create. So parts, validated parts. You've probably noticed that this is almost identical to what we've done before. Let me try and find where we are doing that. I think somewhere up here. Basically, because we need to handle the interrupted message part. Yeah, we did it in here. It's the same thing that we did here. But this is for the persist interrupted message. So if user presses escape, we are going to trigger this function. And then that it has to, again, capture all of the text and separately capture all of the parts that have happened, right? And then store that into message, which is interrupted with parts and with content full text. That's one scenario. And then all the way down here, we have to do the same thing with validated parts and full text for the normal assistant message complete status. And if this is confusing you, it's perfectly fine, because it's a very, very complex function, because we have to kind of modify it. Usually this would be much simpler if we were on the web, but because we are within OpenTUI, we have to re-implement the use chat hook, which means that we have to modify the return events like this manually. But it's an extremely good practice to kind of see the inner workings of those great SDK tools like AI SDK. Great. So that is it for our API. We can now display tool calling, and we can now display thinking. So what I want to do now is I want to resolve this error that we have right here resolve the model dot provider options. The reason we have added provider options is because you have to specify, or should I say, enable if a model should be thinking or not. So without this, the models will never start reasoning. So let's go ahead and resolve that. So I'm going to go ahead inside of my server source lib models.ts, and I'm going to go ahead and import type provider options from AI SDK provided provider utils. Let's find the resolved model, and after model ID, let's go ahead and add optional provider options. And then I'm going to go ahead and do the following. I'm going to create an object, Anthropic provider options, which is going to be a partial of object Anthropic model ID, so supported ones, combined with the provider options. So inside of this object, I'm going to go ahead and specify my first ID that I want to modify, Claude Opus 46. And I'm going to go ahead and choose what provider options I'm modifying. So my AI SDK tooling can tell me if something I'm trying to add here is wrong. So I'm going to add thinking here. I'm going to enable it, and I'm going to set the budget tokens to be 10,000. And then I'm going to go ahead and do the same for Claude Sonnet 4.6. Let me just see if this is properly indented or not. This is incorrectly indented because I have to end this here, and then I have an extra one here, like this. So Claude Opus 4.6, Claude Sonnet 4.6. Okay. Pause the screen and double check that you have correct indentations and everything here. So for now, I'm just going to do it for these models. If you're using different models, let me show you and kind of try and give you a guide on what to do here. So you have to specify it for one of the models you have added in your shared package source models.ts in this array right here. So if you added some Gemini model or Google model, you have to research whether it supports thinking. And if it does support thinking, in here, you are not going to use Anthropic model ID. Instead, you will have, I don't know, maybe a third one like Gemini model ID, and provider will be Gemini or Google, maybe something like that. Then you will create your own Gemini, Anthropic, my apologies, Gemini provider options, and modify this type to be Gemini. And in here, you will map the model that you are using, write Google or Gemini, whatever is the provider, and then you will enable thinking. And what I would highly, highly, highly suggest is having Vercel AI SDK open so that you can actively look at the provider. So for example, Google Generative AI, Google Generative AI provider. And in here, you will be able to, I'm pretty sure, find the provider options and how they work. So in here, let me try and find if we have, you can see there are some thinking options. So thinking budget, yeah, you can see Anthropic specifies thinking like this, but Google specifies it in another way. For example, let me find OpenAI and how they specify thinking. So if I scroll down here, let me try and find. So provider options, OpenAI. So that's what we are doing here. This is the provider options, and then you have to specify Anthropic or OpenAI or something like that inside. But let me try and find the. Okay, in here, it's reasoning effort, right? I think. I'm going to try and enable it for OpenAI simply so you can see the changes that need to be done. Reasoning output. See, OpenAI reasoning summary detailed, right? So let me go ahead and finish what I wanted to do with Anthropic here, and I would suggest you do it as well, regardless if you use Anthropic or not, simply so you have this finished. Go ahead and find Resolve Anthropic Model, and in here, add provider options and pass along Anthropic provider options model ID. Like that. And by adding this, if you go back inside of your server routes chat.ts, you will see that provider options are no longer a problem now. Great. So we now have that finished here. So for example, if I want to copy this and paste it here, I would do something like OpenAI provider options. I would use OpenAI model ID, which gives me an error here. Perfect. So I modify this to GPT 5.4, for example. I don't know if the other ones support thinking, so I'm not going to enable it. I have to change this to OpenAI, and I'm pretty sure that this is incorrect provider options here. So I think it could be reasoning summary that I need. I'm not sure about budget tokens. So I would add something like this, OpenAI provider options. And then I would find resolve OpenAI model, provider options. And then again, I'd choose model ID here. And everything works just fine. So that's how you would do it for another provider. I haven't tested if it works with OpenAI. I mostly use Claude models, but we'll see. It will be a good exercise for us to try. Great. So we now have that, and now we have to do the equivalent of what we did in chat route into use chat hook. So let's go inside of use chat. And let's go ahead and find client message part. And what I'm going to do now is I'm going to add another type called client tool call part. Type is tool call. It has ID, name, arguments, optional result, and a status of calling or done. Again, this is something that you can probably infer from Hono. A lot of things here can be inferred from Hono. Perhaps it might be a good idea. We are writing too many custom types, except maybe these run stream params, submit params. Those are our custom ones, but okay, it's message, client tool call part, and client message part could probably be inferred either from our shared package or from Prisma or from Hono. We'll see. I'll see at the end if this is something we can improve. So now that we have that, let's go ahead and also modify the client message part to be a discriminated union. So client message part can either be type reasoning with text string, or client tool call part, or type text with text. Now, let's go ahead and find use chat hook right here. Let's find our switch case. Here it is. So switch event dot type. And let's go ahead and add our reasoning delta so we can stream back when that happens. So reasoning delta has to look at the last part. And just like on backend, we have to confirm that the last part is reasoning. If it is, let's just append text to that last part. Otherwise, if it's not, let's go ahead and push an entirely new part. And then we have to emit those parts and break. And now let's go ahead and add some other cases. So let me see, where do we add? Well, it doesn't really matter where we add them, really. Let me go ahead and add case tool call. This one is simpler because tool calls are all individual. They don't like continuously happen. So we can just go ahead and push a tool call, and we can emit immediately and break. And for tool result, we once again have to look and have to find for the tool ID that was previously called. So again, we have to find the tool call by searching through the parts. And again, this is a very simple function with a with a complicated type, or maybe not so much. But basically looking if part is tool call and if part ID is equivalent to event tool call ID. And if we are able to find that part, we can go ahead and append the result and change the status to done. And let's go ahead and emit parts and break. So essentially what we were just doing on the back end, we're now doing on the front end. Great, so we now have that. And what we have to do now is we have to modify our bot message component to be able to handle displaying that, because there is currently no way for it to do that. If you take a look at messages, bot message, it has no way of rendering any thinking or parts. It can just render text. That's all it can do, because what we do here is we filter through just text. So what I'm going to do here is I'm going to add empty border, make sure you have it. Then I'm going to go ahead and add from use chat my new type, client tool call part. Then I'm going to go ahead and create a fun little util to format a tool name. This can be done in like a billion ways. I found a regex that does it, and when I say found, I mean I asked AI to generate it for me. Basically, it's a case converter, right? So if the tool is something like read file, it will return back read file. If it's something like grep, it will return back grep. If it is create file, it will return create file. That's what this regex does. You can pause the screen to copy it, or just ask AI to generate this exactly. Now let's go ahead and create a function to format tool arguments. It accepts client tool call part, returns a string, and it maps over each value of the arguments, and it returns them into a string. So you can exactly see what file a tool is working on. Let's go ahead and create a type, part group. Type is client message part type, so reasoning tool call or text, and parts are client message part and then an array. Great. Now, what we have to do is we have to create a function that will group consecutive parts. This is a little bit not so functional as much as cosmetic, simply because if you group consecutive parts together, they look much better than if you constantly have like thinking, then you have another spacer, thinking, another spacer, thinking. Basically, it just doesn't look as good. So let's go ahead and just group consecutive parts together. So if we have 3 parts and all 3 are thinking, let's display it in one container rather than each of them being its own container. For that, we're going to use a simple for loop over all the parts that we have. Let's get the current part that we are iterating over. Let's go ahead and find the last group that we know of. And let's check if the last group type is equivalent to the current part we are iterating over type. If it is, let's simply push it to that group. Otherwise, if it's not, let's go ahead and define the key for the new group. So if part type is tool call, then make it group tool call part ID, otherwise group part type and just the index. And then finally, let's just go ahead and push that new group with type, parts, an array, and then a single part inside and a key. And finally, return groups. Great. Now that we have that function, Let's go ahead and modify how we actually render messages inside of the bot message here. So what I know I can do is I can now get rid of this. We are no longer filtering by text only. And what I'm gonna do now is the following. So let me just see. Okay, we can remove this part. I'm pretty certain that we can. And let's instead iterate over grouped consecutive parts. So for each group that we receive, let's go ahead and create a container like this. Let me go ahead and properly close it. So each group will have its own box with a group key, its own padding, and full width. And then for each part of that group, we can iterate further. For example, in this part, let's go ahead and check. If part type is reasoning, let's go ahead and return the UI for displaying reasoning. That's going to be a box. I'm going to show you exactly what the code is in a second. Here it is. Key, reasoning, border left, border color, colors thinking border, custom border characters. We are doing the little empty border trick. This is purely cosmetic. You don't have to do it if you don't have this character. But I think we reused it somewhere already. You can just do it without this. It will work just as fine. It's just cosmetics. We'll give it full width and padding inside. And then inside of here, we render the text. We give it the attributes of dim, and we give it foreground colors thinking, and we render the text. Great. Now let's go ahead and do another if. Parts.type is equal to tool call, not parts, individual part.type. So if it's tool call, let's go ahead and learn how to display that. So again, we're going to do a box. So let me go ahead and close the box and let me close the return. Let me show you the attributes. So they are almost identical, if not the same. We are again using thinking border here. Again, the little trick, padding is 2. I think it's identical. The only difference is the key. And inside of this box, we are once again going to render text. We are going to render the formatted tool name. So if we receive something like read file, we're going to render it as read file. And we are going to format the tool arguments immediately after. And then if the status is calling, we're going to add 3 dots. Otherwise, we're not going to add anything to indicate that it's finished. Okay. And let's go ahead and add the last type, which is text. And in here, we do the simple return. And finally, let me see, I have some mistake. Well, the last one will be return null, but obviously I'm having something here. Am I missing an extra here? Okay. So I had an extra parenthesis and I was missing a curly bracket. Just make sure that you didn't do, yeah, you need to close this, you need to close this, you need to close this, and you need to close this. So yes, this is how it should look like at the end. Great. So I think that this should be enough for us to see some thinking because we don't have any tool calls yet. So if I go ahead and run dev server now, and if I do, I'm going to test on Opus, and I will do hello, how are you? I think I should see some thinking displayed here. Let's see in a second if this is correct or not. It is still creating this in the database. Perhaps I have some network issue because it is taking a while. So let's see if this will work or not. And there we go. You can see we now have thinking. The user said hello world, a simple greeting. I'll respond in a friendly way. Brilliant. So I'm not sure if we implemented the ability to switch models, but can I try with this? Hello world again. I'm not sure if this will. It still triggers Claude Opus 4.6. Okay, I think that's what we're gonna do next. We're gonna add the ability to switch models, but you can see that now we have thinking and we can see exactly what AI thinks at the moment. Brilliant. So that is step 1 finished. And now we are on to step 2. Let's go ahead and create the general system prompt. We're going to do that inside of packages, server, source. And in here, I'm going to create system-prompt.ts. Let's go ahead and start by importing the mode type from database enums. Let's go ahead and create the system prompt params, which can accept the path and the mode. And then let's go ahead and export a function called build system prompt. It will accept the path, the mode, and it has to return a string. Let's go ahead and define the parts array. And let's go ahead and start with the very first part. So your best bet is to either pause the screen and read through and copy, or simply go inside of the source code or the free assets and copy. Or ask AI to build it for you, because it is relatively simple. Now let's go ahead and check if we have path passed. If we do, we can tell LLM what is the user's current directory. And now let's go ahead and do an if clause. So if mode is plan, we have to tell the AI it's in plan mode, like this. You are in planning mode. Your job is to analyze, research, and propose solutions, but not make changes. Use your available tools to explore the codebase, present your analysis in a clear plan of action, explain trade-offs, and ask for clarification when needed. Else, if we are not in tool calling mode, we are in build mode, which means that we can make changes. So let's go ahead and explain AI that. You are in build mode. Your job is to implement changes directly, read and understand relevant code before making changes, use write file to create new files, edit file for targeted modifications, use bash to run commands, tests, builds, git operations. After making changes, verify the work when possible. All right. And now let's go ahead and append to the system prompt what tools are available. So this is what we're going to pass here. You have these tools available: read file, list directory, glob, and grep. For the rules, be decisive. Use glob grep to find what's relevant. Never reread files you already read. Batch your tool calls. Call multiple tools in parallel when possible. Read 5 files at once, not one at a time. So just some general guidelines here. All right. And then let's go ahead and do a similar thing for build mode. So this is it. If we have CWD and the mode is build, let's go ahead and show it exactly which tools are available. Read file, write file, edit file, list directory, glob, grep, and bash. Rules: be decisive. Never reread files. Batch your tool calls. And basically the same thing, but with the addition of all the new tools it has access to. Let me just indent these. Brilliant. And what we have to do now is make sure to join all of those parts. So the end result is just a big string. So we are basically modifying the system prompt depending on if we have the directory the user is in and if we have specified, what mode we have specified. Great, so that is the system prompt. Now let's go ahead and start building some tools. So we're gonna go inside of source and we're gonna create tools. And in here, let's go ahead and create a new file. let's start with the bash tool. So we're going to be using tool from AI, and we're going to be using Z from Zod. I'm going to specify some defaults, max output and default timeout. And let's go ahead and create a function which passes along the current directory we are in. And let's go ahead and return the tool and the tool's configuration. You can find the API for the tool using Vercella's AI SDK. So not providers, if we scroll down, we should find, how do I close all providers and just focus on the tools? Here are the tools. And in here, you can basically find how they are written. Weather tool, description, get the weather in a location, input schema, what we need from the user, and then the execution. In here, you would, for example, call an API or something like that with the argument. So in our case, the weather tool is the bash tool, the argument is the user's directory, and the location is the ability to read files, right? Something like that. So let's go ahead and write this one together. Description. Then let's go ahead and add the input schema. After that, let's go ahead and write the execute method, which is asynchronous, has command and timeout. Let's go ahead and open the try and catch method. Inside of try, let's go ahead and use bun to spawn some processes. Let's go ahead and set the timer. Let's go ahead and get some of the responses. And let's just build the entire thing to the end here. I would suggest looking through my source code when you build these tool calls. They can mostly be improved by using other AI tools, and I would highly recommend doing so. And make sure you capture the error. And that's, for example, one of the tools we're going to have. Let's go ahead and do another tool. So I'm going to copy this and paste it. I'm going to call this edit file. Let's go inside of edit file here. Let's go ahead and update our imports. Resolve, relative from path, read file, write file from FS promises, tool from AI, Z from Zod, and we no longer need these constants. Let's go ahead and change this to be create edit file tool. Then let's go ahead and modify the tool configuration here. So take a look at the new description I have added and take a look at the new input schema that I have added for here, which means that the execute function is also going to be modified. So I'm going to go ahead and replace this with path, old string, and new string. And now in here, we're also going to go ahead and write the new execute function. So I'm going to go ahead and clear everything I have inside. So the execute function will start by resolving the current path. And if the whatever was resolved does not start with what we have passed as the argument, it means that the path is outside of the project directory and we are not going to allow the LLM to do anything with that file regarding file editing. So just some safety here. Now let's go ahead and attempt to read the file that we're trying to edit. Let's find the occurrences. If there are no occurrences, let's go ahead and throw an error. If the occurrences are greater than 1, it means we found too many of them, so we need more context, perhaps another tool call to specify which file we need. Other than that, we have updated the file by replacing the context. So let's go ahead and write that file and let's return the success. And in the catch method, let's go ahead and grab the error here. And let's go ahead and return the following. Great, another tool finished. Let's go ahead and continue by building the glob tool. I'm going to go ahead and copy bash again, and I'm going to rename it to glob. So for the glob tool, let's go ahead and change some patterns again. Resolve, relative tool, Z, max results. Let's go ahead and change this to be create glob tool. Then let's go ahead and modify all of the parameters here. So take a look at the new description. Take a look at the new input schema, which I have added here. Now let's go ahead and change the execute method. So the execute method is going to be working with pattern and with path. Let's go ahead and start by resolving things first. So check if we are outside of the current directory. Then inside of try method, let me go ahead and try to clean everything inside of the try method quickly. So inside of the try method, let's go ahead and get bun.glob running. Then let's go ahead and run an await here for match of glob scan. Let's go ahead and skip node modules, for example. This is where you would improve the tool even further. Let's go ahead and make sure we don't go over the maximum amount of results. Return paths relative to the project root. That's all for the loop. And now inside of here, let's just run files.sort. And let's go ahead and return. There are many opportunities for improvement over these tools. This is just to give you the basic idea of how they work, of course. Beautiful. That is our glob tool. Let's go ahead and copy glob, paste it. Let's go ahead and add grep tool. So our grep tool will once again have a constant, but it's going to be max matches. The imports are all going to be the same. The function name will be different. Create grep tool. And let's go ahead and modify the description and the input schema. So take a look at the new description and the new input schema. Now let's go ahead and extend this with include and keep the pattern and the path. The first check stays the same. And then inside of try and catch here, let's go ahead and do something different. So I'm going to clean up the try method. I'm going to start by defining the arguments. And then I'm going to go ahead and add the special case if we have include. Let's go ahead and spawn a bun process. Let's go ahead and read the output. Let's go ahead and await process exited. Now let's go ahead and just do some edge cases here. So I've added these two if clauses. Now let's go ahead and prepare some lines we are going to print and some matches. And we are going to append them by running a for loop over all of the lines. Let's go ahead and wrap up the for loop by specifying the format that we want. So whenever we grab something, we are going to display it in the following format so that the user can see what the tool is currently doing. All right, and then in here, let's go ahead and return the matches, and let's leave the error as is. Great. So now let's go ahead and add 3 more tools. I'm going to speed up this process a bit. So I'm going to go ahead and go inside of this, create write file.ts. I'm going to go ahead and add all of the imports. Then I'm going to go ahead and add the function once again. And I'm going to return the tool instance. And then we're going to go ahead and I'm just going to write the entire execute. And then I'm going to slowly go over it just so we speed up this process here. So this is the description, the input schema. And here is the execute function. So again, we start by resolving the path. we go ahead and attempt to write the file very simply. We even do new directories if needed. I really chose the shortest one to speed up. Yeah, this one is not even that complicated. And the error catching is exactly the same. Great, that is a write file. Now let's go ahead and do read file .ts. So again, I'm going to go ahead and add imports. So these are the imports which we are going to need. I'm going to add a constant maximum file size. I'm going to rename this to create read file tool. I'm going to replace the description and the input schema. So take a look at the new description here and the new input schema, which means that we only have access to the path here because this is a read file tool. And again, I'm just going to replace the entire execute method so you can see how it looks like now. Okay, so take a look at the description and the input schema. And this is the new execute method. So we have path, we resolve the current path, and in here we are checking if the path is outside of the project directory. To make this easier to read for you, I'm going to go ahead and just collapse the if clause like this, so you can see what is the actual condition here. So we return an error here if it's trying to read outside of the path directory. Then we do the classic to ensure we are still within it. And then inside of here, we attempt to read file with some limitations regarding the maximum file size. And we throw errors in the exact same way. So again, I recommend just using my assets file or my source code to get access to what I have written here. But of course, you can just pause the screen if you want to write it yourself. All right. And there is one more tool left. And since we've already written like, I don't know how many of them, I'm just going to one-shot this one. So this one is called list directory.ts. And I'm just going to paste the entire thing inside and we're going to go over it. So these are the imports. This is the function name, the function description, the input schema. And now we get to the execute part. So again, we are working with path only. We check that we are within the current directory. We open the try and catch block. In here, we do whatever we have to do to list directories here. We sort the directory and we return the path, the entries and results. The error stays the same. And let's go ahead and save read file. Beautiful. Now that we have all of those files, let's go ahead inside of tools and let's create index.ts. Now in here, we're going to add all of the imports that we need. And then I'm going to go ahead and export function create tools. I'm going to specify read-only tools, which are read file, list directory, grep, and glob. I'm going to go ahead and specify if mode is planned to only return those. And otherwise, I'm going to extend the read-only tools with write file, edit file, and bash. Now that we have all the tools in place, let's go back inside of our server routes chat.ts. I'm going to go ahead and expand my imports for AI with step count is. And I'm going to go ahead and import my new function called create tools. And I'm going to import my new function build system prompt. I'm going to go ahead and define stream params here. And I'm going to extend it by adding the current directory like this. I am then going to go ahead and find where we destructure that and make sure that we extract the current directory now here. And then what I'm going to do is I'm going to define the tools by checking if we have current directory, then go ahead and create the tools by passing along the current directory. Otherwise, undefined. Then I'm going to go down to where we actually call the AI stream text. And in here, I'm going to extend it by passing along the system prompt. Then I'm going to pass along the tools. And finally, I'm going to go ahead and define a stop when. And then if we have tools, I'm going to increase the step count. I think that the default step count is 20. So in here, we kind of more than double it. So it provides for a better user experience. So yes, if after 50 steps, the LLM still can't reach the result, it will most likely fail. In my experience, this is more than enough for almost everything I needed to do. But you can, of course, play around with it. All right, now let's go ahead and search for stream AI response because we have an error here, simply because we have to pass the current directory now here as well. And there is another stream AI response that we have, so you can just search through it at this point because you will have errors in your code. So just add it. And there is one more. Or maybe there isn't. Yeah, that's it. Sorry, that's it. All right, so those are all of the changes we need to do in our API route. So now the next thing we should be doing is going inside of our session.tsx. Actually, let me see. No, let's go inside of a new session first. Let's go inside of a new session first. So screens, new session. And in here, we can now remove the import for the default chat ID. We no longer need to hard code it, and we can just import mode from Nightcode database enums. And then inside the new session state schema, we can just go ahead and append mode and enum over mode and model, which is z.string. And then we can go ahead and find where we specify the initial message, and we can remove the hard-coded mode and model and make both of them dynamic. So they read directly from the state that is currently set. Great. And we also have to go down to our rendering, and we should add mode to our user message, which we don't yet have, but we're going to add any second now. So while we are in the screens, let's also visit home here. Let's go ahead and add use prompt config and text attributes. And from here, we can also extend the handle submit to include the mode and the model. And we can get the mode and the model from use prompt config like that. And let's make sure to just add these to the dependency array. Let's go ahead and find this box right here. Let's add flex direction column and gap 1. And then after the input bar, let's go ahead and add this box, which simply indicates to the user that they can press tab to switch between the agents. So in here, we are purposely sending this over state. So we extract it in the new session over state rather than using the prompt config here, simply because this is supposed to be a snapshot of what the user just submitted. So that's why we are not calling use prompt config hook here. Okay. Now let's go ahead instead of the user message. So that's going to be components, messages. Let's find the user message here. Let's go ahead and extract mode, and let's go ahead and import mode. Whoops, like that. And let's go ahead and modify the border color here so it matches exactly the mode that the message was sent at the time. So if it was sent in plan mode, keep the border in plan mode color. Otherwise, keep it primary. And now you can see that new session error has completely gone away because it accepts mode. Great. So now let's go ahead and go inside of screens session .tsx, and now we have some errors we have to resolve here. Let's find our Nightcode shared import, and we can now remove the default chat model ID, and let's instead import message parts schema. Let's go ahead and import use prompt config from providers prompt config, and then let's go ahead and go inside of our map database messages here. And in here, when we return the assistant message, let's go ahead and properly send the parts here. So parsed parts, and then let's go ahead and iterate over the parts like this. And then we no longer have to pass along these primitive parts. We can just pass along the proper parts like this. Then let's go down here in the chat message. And in the chat message, we have to pass along the mode to the user message. And then we have to go down to our session chat component. And in here, let's go ahead and add use prompt config and extract mode and model. And let's modify the onSubmit method here to be a bit more intelligent, one can say, by passing submit with user text, mode, and model from the prompt config. Great. So what was super important here is that you actually modify this inside of the map database messages, because it's basically now serializing the database messages that we fetch and making them readable for our component. So at this point, you should be able to do full tool calling. Let's go ahead and check it out. Let's see if this works. So I'm simply going to start by switching to plan mode, and I will ask, what mode are you in? Let's just try something super simple like that. You can see that it knows that it is in plan mode. It knows which files it can use, and it knows what it cannot do. And my message is persisted to be written in the plan mode. You can see that this is also purple. If I change this to build and ask, how about now? Let's see if it will receive info that it is in the new mode. I am in build mode. Perfect. You can see the LLM is not exactly super smart. It cannot distinguish between the fact that it actually was in plan mode before. So I'm going to switch to plan mode just for safety, and I'm going to ask, what is this project about? And let's see if we are going to see any tool calling happening. And here it is: list directory, read file, or list directory, packages, CLI server, database, shared. It's going very deep into our files here. And you can see this is the thing I was talking about. You can see how all of the tool calls are grouped together. And that's what the cosmetic part was about. And now it tells you what Nightcode is. It's a CLI-based AI coding assistant similar to tools like Cursor, Aider, or Claude Code. So we succeeded into cloning Claude Code because we made Anthropic model think that this is similar. Brilliant. I'm very, very, very happy with the result. And let's try a fun one. I'm going to switch to build mode, and I'm going to tell it something like create a foo.js file in my root folder, put hello world console log inside. So let's go ahead and make it do something relatively simple just to check if write file is working. So I can already see that I have another file added here. Let me close everything. foo.js, it's right here. Hello world. Beautiful. And what I want to test now is the ability to switch models. So can I switch to Haiku? And let me do hello world. This one should be significantly faster. And it is. It's much faster. And you can see it's Claude Haiku. Let me try and switch to GPT-5.4. Hello world again. And let's see. Open API key is missing. That is certainly correct. Let me go ahead and let me add my open API key. So I just added my open AI API key, and I think I have to restart my server now because I don't think environment files are handled in hot reload. Let me try hello world again. I have to check if I did the reasoning correctly. I don't know if this is supposed to behave like that. Let me try with the completely blank one. What is this project about? I know so little about OpenAI models that I don't even know if I'm doing this correctly. It's using the tools, which is great. That's great news. I'm not sure I'm seeing its thinking though, but it's definitely working. We are able to, switch models and it's working, but I'm just not able to see it thinking, which tells me most likely that there is a problem inside of our models.ts in server here, OpenAI provider options. You know what would be an interesting idea? To tell it to look at that file. Let me try this. It cannot seem to showcase OpenAI models thinking in my app. Can you look at packages, server, source, lib, models, and look at OpenAI provider options? The same solution is working for Anthropic. Are my provider options for OpenAI incorrect? We are, of course, going to add a file matching system later, but for now, let's just see if this works or not. This will be very interesting. And this is what's super fun about this project. We are technically finished with it now, and we can use it to improve our app. So let's see what's going on. Check the exact version. Okay, what am I supposed to do? OpenAI reasoning summary detailed. Okay, I'm probably gonna do this off screen. You can maybe play around with this. But yeah, it tells me that it looks incorrect. For the Anthropic, it's correct, it's plausible. Yeah, I'm not really sure which one should I use or not. Never mind. Okay, I can't spend too much time on this. I have to end the chapter, but it's super interesting how you can use the project you have just created to help you finish the project you have just created. Brilliant work. So that marks step 2 as complete. So chapter 7, tool calling. Let's go ahead and do git checkout-b 07 tool calling, git add, git commit 07 tool calling, git push-u origin 07 tool calling. And that will allow us to open a new pull request and review our changes. And here we have the summary. We now display AI reasoning and thought process in chat messages. We also added tool execution support, bash commands, file, read, write, and edit, file search, directory listing. We have plan and build modes with mode-specific tool availability. Plan mode is read-only. Dynamic system prompts that adapt to working directory and selected mode. And some improvements. As you can see, we have a successful railway deployment, which is always great to confirm. And in here, we actually have a lot of comments. And most of them are about the system prompt, specifically whenever we use the current directory, simply because the way we are protecting our tools from not going outside of the path guard is not strong enough. I think an interesting way to fix this would be to use the tool we just created to fix itself. I think that will be a very interesting challenge. So for now, all of these comments are the same. Basically, this resolve starts with it's not strong to guarantee that workspace will not escape. That isn't to say this will break our app, but yeah, it could be unsafe if LLM goes awry and just goes over various files on your computer and deletes them, creates them, or anything like that. So there is definitely room for improvement with our tool calling. And now that we have this tool that we created, perhaps we can create some cool tools and improvements ourselves. Let's go ahead and merge this pull request. Once again, I'm not going to delete my branch, so I have all of the history here. And then I'm simply going to go ahead and git checkout main, git pull origin main. So all of my changes are here. Beautiful. Amazing, amazing job. And see you in the next chapter. In this chapter, we're going to complete the user experience by adding file mentions and authentication. We're going to implement file mentions by listening for an @sign, which then calls the findActive mention, which is going to parse the query token. Once we parse the token, we're going to pass it along to a new function, getMentionCandidates, which will read the directory we are in, filter, and sort the results. We will either display a direct match or a recursive fallback with maximum of 32 candidates, skipping the node modules. And we're going to display those candidates inside of a new component called FileMentionMenu, which will have an overlay with a scroll box. Once the user selects one of the options and presses enter, depending on if it's a path, we're going to insert it, or if it's a directory, we're going to traverse further. We're also going to implement a new keyboard layer called mention, which will allow us to press escape to dismiss the file mention menu and arrows to navigate up and down, very similar to what we did with the command menu. And for our authentication, we're going to go ahead and implement a new command called login. Then we're going to go ahead and use clerk's outflow and open the browser to allow the user to create an account, sign in, and allow permissions for our CLI app to use clerk. We're going to use something called proof key for code exchange, which allows us to build secure OAuth flows for public clients like mobile and browser-based apps, or in our case, a terminal app. Once the user is authorized, we're going to redirect to a local callback server, which we are going to host on bun.serve on a random port. That server will receive a code, which we are going to exchange for an access token, and we are going to write it to a config file like this one. We are going to build this file with owner-only permissions, so in case there's any malware, it's not going to be able to steal it that easily. Once we have that token stored, our API client is going to add it to bearer header. And then we're going to implement a new middleware with Hono called requireAuth, which will use Clerk's SDK to verify the JSON Web Token we just stored. If we receive back a user ID, we are going to finally have user scoped sessions and messages and everything else. Otherwise, we're going to return back 401 unauthorized. And finally, logout command is going to clear the auth token that we have stored. Let me show you all of this in action. So first of all, file mentions. For example, what is the content of this file? And in here, I can go inside of packages. I can go ahead and manually type in further. I can go ahead and select. And basically, I keep selecting and I keep seeing the menu until I either press space or until I select something. And take a look at something. If I go ahead and press enter, I'm getting an error. I am unauthorized, which means I have to run login. And in here, you can see we don't have to build the login screen or anything. All of this is handled by Clerk. The social login, the register screen, the sign-in screen, and finally, the permission screen to allow Nightcode to use all of this information from the OAuth scopes that we have selected. And once you select allow, you will see that you are signed in. And you can go ahead and try again. Hello world, what is enums file used for? And you will now be able to create user ID scoped sessions. And you will also, as you can see, be able to tag exact files and get output about that specific selection. So that is the goal of this chapter. Let's go ahead and implement it together. Let's get started and let's implement the file mention functionality. For that, we have to revisit our input bar component. Let's go ahead and add a few more imports. At the top, I'm going to add read directory is absolute, relative, and resolve from node path. Then I'm going to go ahead and add use state to my React import, and I'm also going to add one type ref object from React. Then I'm also going to add text attributes from OpenTUI core, and I'm going to extend my OpenTUI core type imports by also having scroll box renderable, like that. Now let's go ahead and add constants needed to develop our traversing functions. So maximum visible mentions, current directory, maximum fallback mention candidates, mention query character, and recursive mention ignore directories, in which you can put whatever directories you want to ignore when traversing. Let's go ahead and define some types. We are going to need a mention match and a mention candidate. Now, let's go ahead and develop a function is within current directory. This will help us safeguard the searches and traversing so we don't go outside of the current user's directory. Now let's go ahead and develop a function is mention query character, so we don't have to do the regex text test every time. We can just call this function instead. Now let's go ahead and develop the find active mention function, which takes in the text and the cursor offset. Let's start with defining the safe offset. Let's go ahead and do a while loop over the start. Let's go ahead and do the same over the end, but in the opposite direction. This is to ensure that the user is indeed trying to mention a file and not typing like an email or trying to add an @ sign like this. So just making sure of any edge cases and covering them. Let's go ahead and add token, relative cursor, and mention start. Let's go ahead and do an early return of mention if mention start is negative. So again, another edge case we are covering here. Let's do the same for the previous character here. Let's go ahead and check mention end and see if we should increase it like that. And finally, let's do one more edge case check to see if we should do an early return. Otherwise, we are safe to pass along the start of the mention, end of the mention, and the actual query that the user has typed. So in here, in this function, we have a bunch of like edge cases and early returns simply because we want to ensure that the user is indeed trying to, let's say, tag a file and not doing anything else. So that's why the function looks big. Technically, it could be just like this. In here, we are calculating the actual mention, right? So from the start of the query to the end of the query, and we are returning it in this specification like we defined right here in the mention match. All right, now let's go ahead and develop a function called getMentionCandidates, which returns a promise of a mention candidate. Let's normalize the query and let's do an empty array return if it starts with a trailing slash. Actually, that's not a trailing slash, that's a slash in the beginning. So let's return an empty array for that case. Otherwise, let's define if we have a trailing slash at the end, so we know that we have to load more files after that, because it's obviously a folder. So let's go ahead and get the last slash index. Now let's go ahead and get the directory part. After that, let's go ahead and get the name prefix. And then let's go ahead and get the absolute directory. Now let's check if the absolute directory is not within current directory and do an early return if that's the case. And now let's open a try and catch, because we are going to use some node async functions here. In the catch, we can already just return an empty array, as in nothing found. For the try one, let's go ahead and add three constants here: the entries, the lowercase prefix, and the option to show hidden entries if we have a dot in our name prefix at the start. So now we have to first develop the direct matches. So the direct matches are going to be the exact files that we have found that match, that user can select. And then later we're going to have to implement recursive fallback so that folders are shown as well. So for the direct matches, we have to filter them. First, we filter by hidden entries, and if the name doesn't start with a dot. And then we filter by checking the lowercase prefix. Once we did that, let's go ahead and sort. So we sort files first and directory last. And then let's go ahead and map. And depending on if it's directory or not, we go ahead and return that exact label in path and kind here. Now, let's go ahead and check if we can return the direct matches by checking if they are greater than 0 and some other edge cases here. And now we have to do the same, but for fallback matches. So let's define an array here. And now we're going to develop a recursive function called visit, which will be able to call itself until it reaches the end of a folder. So it's going to take in two arguments, absolute directory and directory part. We're going to start by grabbing the entries from the absolute directory. And then for each entry that we find, let's go ahead and traverse through it. So first things first, we go ahead and do some early continues here. So in here, we check if it's directory and if it is supposed to be ignored. So we do an early ignore here, like node modules. Otherwise, we go ahead and we extract the path and the kind of the entry. So let me go ahead and show you how this one is supposed to look like so you can easily copy it. Now let's go ahead and check if the entry name starts with the prefix. If it does, we are going to push it to fallback matches, and we are going to immediately limit if it has reached 32, which is the limit we have set up. Now we have to check if the entry is directory, and if it is, we have to visit it again. So essentially, we are recursively calling the visit function itself until it reaches the end, or in other words, until it reaches 32 candidates. So that's how we are going to find all of the other ones. When I say all of the other ones, I mean all matches which are not direct matches. And now we have to call the visit function for the first time with the current directory, and then the visit function itself can call any subsequent directories that it needs to call. And what we have to do at the end is return fallback matches, because we are awaiting them, which means that we can return after this line, and fallback matches will be an array in which we can then sort our paths. And in the catch, just do a return like this. Great. So now that we have this, we have to develop the file mention component. So let's go ahead and add the props for the file mention. Then let's go ahead and develop the file mention menu component. In here, we're going to assign the colors, and we're going to assign the visible height to know when to trigger an overflow. Let's do an early return if we detect that the candidates are 0, so we can immediately show to the user that there's nothing to be seen here. And let's go ahead and return a scroll box. So let me add the close tag for the scroll box here. And within the scroll box, all that we're going to do is we're going to map over our candidates. So let's keep track of the candidate that is currently selected, so the user knows what they are highlighting and what will be selected if they press enter. And in the return here, we are going to go ahead and render a box with a key, some flex and padding, the background color, which changes if the user hover over the current option. on mouse down, which triggers the on select, and on mouse move, and on mouse down, which will actually execute that path. And within the box, we're going to have one container for the candidate path, which again is going to be different depending on if selected or not. And then next to it, we're going to have another box, which will simply indicate if this is a folder or a file, with again, different foreground color if selected or not. So we show a contrast. Great. So just as we've seen in the initial demo. Brilliant. So that is actually it for the file mention menu and these functions above. But what we have to do now is we have to implement all of the keyboard layer logic and basically all of the user experience that comes in with hovering with your cursor and your keyboard up and down. So basically the same thing we had to do for the command menu. So this is where it gets a little bit complicated, but it's all worth it for a good user experience. Let me go ahead and add some new refs here inside of the input bar. Active mention ref and mention scroll ref. Then I'm going to go ahead and find the keyboard layer and I'm going to add push and pop to it. Then I'm going to go ahead and I'm just going to add some new states here. Active mention, mention candidates and mention selected index, null, empty array, and 0 as the initial values. Then I'm going to go ahead and define a constant of which tracks whether we should show the mention menu or not. So similar to how we have show command menu, I'm going to keep track if I should show the mention menu by checking if I have an active mention. Now, let's go ahead and develop a function called close mention menu. So I'm just going to go ahead and put it here. It's going to reset the mention ref, set the state to null, reset this to an array, and it's going to remove mention from the keyboard array. And we have to add pop to the dependency array here. Now let's go ahead and develop a sync mention menu component. So sync mention menu accepts a text and a cursor offset. And in here, we're going to call our functions above to find an active mention. We're going to go ahead and add previous mention, and we're going to detect whether a mention has changed or not, because sync mention menu can be called from various places. Let me just indent this properly. Let me just check, am I doing this correctly? I think I am. Okay, so we have the next mention, we have the previous mention, and with those two, we can detect whether a mention was actually changed or not, because if it's not changed, in that case, we can just close the mention menu like this. Or we can do an early return. Now, let's go ahead and set the active mention ref to the next mention. Let's go ahead and set the state, set active mention to the next mention. And let's go ahead and push it to the keyboard layer. And finally, if the mention itself has changed, we also have to reset the selected index to that new mention at the top. And we have to scroll to the top as well. So basically what this means is, are there any new mentions? Did the user type in anything new, so that we have to basically synchronize the mention menu? So we are basically checking, right? Is there anything new? If it is, let's go ahead and push those changes now. Great. So in the dependency array, make sure you have close menu and make sure that you have push here. And let me just check, is this properly indented or not? If I do it like this, yeah, I think I have to like indent all of this one back. It doesn't matter for functionality. I just like my indents to be correct. Okay, so we now have that. And now let's go ahead and find handle text area content change. So make sure that this function is below your sync mention menu, because now every time text area content changes, we also have to pass along, we also have to execute that function, sync mention menu, and we can extract the text from text area plain text. And we now have to populate this dependency array here with handle content change, which we should have had before, and sync mention menu. Brilliant. So we now have that. So handle text area content change. That looks good. Now let's go ahead and implement a new method called handle mention execute. So I'm going to do that right below handle text area content change. All right. Dependency array like this. Let me fix the indentation. And here we are. So handle mention execute. In here, we are going to basically define what happens when the user decides to execute a mention. So they've selected it and they've pressed enter. What happens? For that, we need the text area, we need the mention ref, and we need the candidate from the mention candidates. And if any of those are missing, we cannot proceed with this function. So now let's go ahead and check what kind of insertion this is. So if it's directory, we are inserting the entire path. Otherwise, we are stringifying the path. And using that, we can also generate the new text inside of template literals, where we insert text area plain text. And then at the end of the @ sign, we go ahead and insert whatever we got from the insertion. And we now have to replace that here. And we have to move the cursor to the end of that insertion. And then we have the sync mention menu. And depending if this is a path or a file, it will trigger the visit function recursively again and display even more directories. So that's why we have the sync mention menu. And let's make sure to add mention candidates in the sync mention menu to the dependency array. All right, and now let's go ahead and implement another function called handle text area cursor change, which gets the text area and simply calls the sync mention menu. That's it. So like an easy way to sync mention menu every time something changes. Now let's go ahead and find our use effect. Here it is. So wire up the text area submit handlers so it always reads the state. So find this use effect right here. And let's see what we have to add here. So we have onSubmit ref.current. So this isn't properly indented. That's why it was confusing me, or not. Wait, let me check. Oh, no, we have to do it in the onSubmit ref. My apologies. Okay, so after we do this return, before we trigger handle submit, in here, we should check if we have a mention menu. And if we do, we should find the active candidate. And if the active candidate was found, we should trigger handle mention execute and then do an early return. Basically, if the user hits enter, but we have a selected candidate, we have to run the handle mention execute function and not the handle submit function. So that's a crucial difference. All right. Now, let's go ahead and let me see how many use effects do we have here. Okay, so we have this one. But do we have any other one? Use effect. Register the base layer. Let's implement another use effect here because we're going to need it to keep the file picker in sync with the current mention token. So let's go ahead and open the use effect. And inside of here, what I'm first going to do is do an early return if there is no active mention. And then I'm going to reset my array. Then I'm going to go ahead and add a cancelable ignore here so I can cancel in case an unmount happens. Now we have to define an asynchronous function called load candidates. And for that, we are going to treat our get mentioned candidates similar to how we would a fetch API endpoint, right? Just get us the new next candidates. Now we have to, before we set any states, we have to do an early return. And now, if that has passed, we can successfully set mention candidates, and we can go ahead and set the mention selected index. And now we have to actually call load candidates, and we mustn't forget to unmount at the end. And let's go ahead and pass the active mention in the dependency array. So that is our new use effect, which keeps that in sync. Now let's go ahead and register the base layer responder so that we can start controlling this file mention menu with our arrow keys and everything else. So I'm gonna go ahead and see what we already have here. So we have a set responder to base, we have text area. Everything here actually looks good, but we now need to create a completely new use keyboard here. So let me go ahead and add it. And perhaps let me check if I have any existing ones, which I should have, right? So let me see. I have this one, is top layer, base, return, and I have this one. So just two of them. All right. So in this new one, I'm going to go ahead and check if we are disabled and do an early return. Then I'm going to check if show mention menu is not shown, and if top layer is not mentioned, in that case, I'm going to return. Then I'm going to handle the escape scenario. So if the user presses escape, I'm going to close the mention menu. Then I'm going to do an else if, which is basically what if user presses the up button. If the user presses the up button, we're going to prevent the default. And then we are going to go ahead and set mention selected index. We're going to look through the current index and we're going to calculate which is the next index and scroll to it. And that is actually it for this if clause. Let me see if my indentation is correct. That's weird. Okay. Oh, that's what's weird. Got it. That is for the up direction. Now we have to do the same for down direction. So what happens if we go down? We start with the key prevent default once again, and then we go ahead and calculate our index once again. But we have to do it in an opposite direction, of course. So first things first, let's see if we can just return 0 if there are no mentioned candidates. Otherwise, let's go ahead and calculate the next index. Then let's go ahead and get the scroll box. If we are able to get the scroll box, let's go ahead and calculate where we should scroll to. And finally, let's go ahead and return next index. Great. So now what we should do is we should render our new file mention menu. So just like we do show command menu, let's see where that ends right here. We are going to make sure that show command menu is not open and show mention menu is open instead. We're going to render a box in which we want to display our file mention menu. So this is the box. And in here, we are going to go ahead and render the actual file mention menu. Let's go ahead and insert the file mention menu inside. And then let's go ahead and modify our is disabled by also checking for is top layer, like this. Let's go ahead and check it here. So packages, server, source, tools, bash, what is this function? Let's switch to plan mode. And if it works, I mean, it already works. The rest is on LLM. And you can see how the LLM will now precisely only read that file. Brilliant. So that marks the end of step 1. And now we go on to the step 2, which is clerk out. Using the link on the screen, you can create a completely free clerk account, and you're going to get 50,000 monthly recurring users for free. That isn't 50,000 signups. Those are actual users which sign up again and again. So your free tier is not going to be used up by people who drop off after one day. So you have more than enough resources to handle an application like this. And that includes B2B authentication, OAuth, which we're going to do now. Let's go ahead and check it out. So after you create an account using the link on the screen, we have to create a new application. I'm going to go ahead and call this Night Code. I'm going to add an indicator too, simply because I have one already, so I don't want to get it confused. You can add as many of these as you want. All of them will work just fine. I'm going to keep it simple with Google for now. Let's go ahead and create an application. And now what I want to do is I want to go inside of configure, and I want to go down until we hit developers, and in here find OAuth applications. Go ahead and click add OAuth application. I'm going to call it Night Code. And for your scopes, make sure you have email, profile, OpenID, and offline access. And make sure it is set to public because we're going to be using proof key for exchange flow. So let's go ahead and click add. Now go ahead and copy the client secret as you're not going to see it again. And now that you have that secret, let's go ahead and immediately add it to our .environment file. So I'm going to go inside of .environment here, and I'm going to add clerk OAuth client secret like this. Beneath it, I'm going to add OAuth client ID. So I'm ready for what's next, and that is to copy the client ID from here. In case you forgot the client secret, you can always regenerate, but keep in mind that that's going to break any existing apps. All right, so we now have clerk OAuth client secret, clerk OAuth client ID. What I'm going to do is I'm also going to add them to my .environment file here, simply so we have documentation about what's needed. And I'm just going to separate. So these are my AI keys. This is my database URL. This is a generic API URL, just so I have some separation here. And I'm going to do the same here. All right. Now let's go ahead and add the rest of the configuration that we need. So one more key that we're going to need is JWT secret, JSON Web Token secret. And this is something that you generate. But for the sake of simplicity, I would recommend just using some string. So it needs to be something. It cannot be empty. But for now, you can just, either use something to generate it or simply use something like JWT secret. Besides that, we are also going to need to get our clerk frontend API. So let's go ahead and copy that from here. So that we have a bunch of URLs here. You can find your frontend API URL on various ways, actually. But yeah, for now, let's just go ahead and use the simplest one. So developers, let me see, where was I? OAuth applications. Okay. So in here, let's just copy the entire link for now. Let's paste it. And let's just remove everything besides accounts.dev. So basically, this is your clerk frontend API. And now we're going to need to prepare two more things, clerk secret key and clerk publishable key. You can find that on the overview screen if you haven't connected yet. So let's go ahead, and it's automatically selecting Next.js, but we are actually, I think, closer to using Express here. And then you will see the type of keys that we need without the next public prefix. So you can copy both of them actually and just add them here. So clerk publishable key and clerk secret key. And in your environment example, just make sure that you add all of these so that you know what you have to add if you were ever to reinitialize this application. Great. And you can leave JWT secret as JWT secret just to indicate that this is something that you have to define yourself. It's not something that you get from any dashboard. Brilliant. So now that we have that ready, let's go ahead and build some utils that are going to help us with the OAuth login. So in the backend package, we're going to need to add one thing. Let's go inside of packages, server, and let's do bun add clerk /backend. So that's the one we are going to need. And in the CLI, bun add open. So just open. Open is a package that we're going to use to, oops, I triggered something. Open is a package that we are going to use to safely cross-platform open browsers through a terminal. Otherwise, we would have to implement our own solution. So let's start by implementing the auth lib in the CLI package. Inside of packages, CLI, source, we have lib, and now let's create auth.ts. Inside of that file, let's go ahead and add the imports that we need. Let's define the type for auth data. Then let's go ahead and define the auth dir and auth file. So I'm going to store this inside of .nightcode, and the file name will be auth.json. So very, very similar to my, where do I store my theme? Theme, index, theme. Let me see. Yes, config dir, nightcode, preferences, JSON. So in the same place, .nightcode, but auth.json. So the first thing we're going to do is create a function called getAuth. And it's going to either return the auth data or it's going to return null. In the try method, we're going to try and read file using UTF-8 encoding. And then we're going to parse the data as auth data. We're going to return a parsed.token if it's a type of string. Otherwise, we're going to return null. And if there are any errors with reading the actual file, we're going to return null once again. Now let's create the equivalent function for saving something in the database. So save auth. And the first thing we have to check if is the auth directory exists. And then we are going to create an owner-only permission so other users on the machine can't read tokens, which is just a basic safety precaution here. So this is the mode that we're using to create that file, that directory. And then inside of that directory, we use the exact same mode to write the file in it. And finally, let's go ahead and create a clear out function, which basically just unlinks the file, or an empty cache, because this just means the file doesn't exist. Now let's implement our OAuth util. So again, instead of lib, create a new file, oauth.ts. This is where we are actually going to have all of that logic happening, right? So OAuth flow, which opens the browser, local callback server, exchange code, and finally calling the save out file. So we are going to start by importing open from open, which we've just installed, save out from ./out, a login timeout in milliseconds. Then we're going to define the OAuth state. We're going to add a helper function to base64 URL. Then we're going to create a function that's going to create the challenge for PKCE, and it's going to accept a verifier, and it's going to use crypto to create a proper challenge. Now let's go ahead and create a helper function to encode state. Now let's go ahead and create a function to decode state. So let's go ahead and first throw an early error if it's invalid. And otherwise, we can go ahead and parse it. Now let's go ahead and grab a helper to get an error message from an error. And now let's import the actual perform login function. So in here, we're going to need to set up three things first: the Clerk frontend API, client ID, and API URL. So double check that all three exist here. What I recommend doing is literally copying things. For example, I'm going to copy Clerk frontend API and paste it here. I'm going to copy Clerk OAuth client ID, find it and paste it here, just to double check that there are no misspellings, because misspellings are often subtle and you don't realize what's wrong. Great. And in case any of those are missing, we're going to throw an equivalent error. Let's go ahead and set the nonce variable. Let's go ahead and create a code verifier. Let's go ahead and set up the code challenge. Let's go ahead and set the settled variable to be false. And now let's go ahead and return a promise with some expected types. And let me just fix this. There we go. And what we're going to do in here is we're going to start that bun server so that we can accept the token from a successful OAuth login. We're going to use port 0, which is going to randomize the port. And then we're going to go ahead and call a fetch function. And inside of the fetch function, we are going to set up the URL. Then we're going to check if the URL path name is not callback, and then we're going to return back not found. So this bun server is exclusively listening to callback, nothing else. That's its only purpose, okay? And now let's go ahead and extract the error, if any error exists, from the search params. If the error exists, we have to handle it. So let's go ahead and generate, or should I say extract the message from these search params. Set the settled to true because we are done with this request. Reject the promise and set the timeout and then stop the server. So we give it a little buffer and return new response authentication failed with an appropriate status. If we succeed without an error, we can extract code and state from the params. Now, in case there is no code or state, that means we are in another invalid state. So we can call settled true once again. We can reject, we can set timeout and stop the server and return an early request. But if that's not the case, let's go ahead and actually verify. So we are going to open try and catch. And we are going to establish the payload by decoding the state. And if payload.nonce isn't equivalent to our crypto random UUID, we're going to throw a new error state mismatch. Let's go ahead and grab the error here. And in case anything errors, we once again set the settled to true. We reject, we stop the server, and we return back invalid state. What we have to do now is we have to exchange the authorization code for clerk token. So open another try and catch. Inside of this one, let's go ahead and set up the redirect URL using our API URL /out/callback. And we can get the token response by awaiting a fetch request to clerk's frontend API OAuth token. And then we have to pass along some options. So how do I know it's going to be OAuth token here? You can double check that your clerk's frontend API is this, and then you can go inside of clerk. And if you go back inside of developers, OAuth applications, night code, and in here, you should find all of the variations. So here is OAuth token. And that is exactly what we have constructed here, OAuth token. Now we have to specify what kind of fetch request this is. So the method is post, headers, our content type, application x www form URL encoded. And then we have to pass the body that we are sending to the token request. So use new URL search params, then pass along the grant type to be authorization code, pass along the code, pass along the redirect URL, And finally, pass along the client ID and code verifier. Be mindful of the states. Great. And if the token response is not okay, we then have to await token response.txt so we get the details of the error, or we fall back. Now let's go ahead and extract the token data if await was successful. So we can await token response JSON and we can cast it as the object we expect. And at this point, everything is going well. So we can set settled to true and we can save out and pass along token data.access underscore token. We can resolve the promise with the exact same object, and we can stop the server after a timeout. And finally, we can return new response authenticated. You can close this tab. But in case any error has happened, we do our usual. We again set the settled to true. We reject the promise. We attempt to deconstruct the error message. Then we go ahead and stop the server. And finally, we return a response authentication has failed. And once you do a return for every scenario, all of your errors should go away. Great. So now let's go ahead and make sure that this is finished. And we now have to build a state with port and nonce. So let's go ahead and extract port. Let's go ahead and check if port is by chance incorrect. And if it is, we are going to stop the server. We're going to reject and we're going to return. Now let's go ahead and define the state and the redirect URL like here. And now let's construct the authorize URL. So clerk frontend API OAuth authorize. Again, something that you can double check here, OAuth authorize. And now we have to set the search params for all of our types. So I'm just going to add all of them here, and then you can pause the screen and see what they are. So response type, client ID, redirect, scope, OpenID, email and profile, state, prompt, code challenge, method. There we go. And then let's go ahead and add void, open authorize URL to string. And finally, let's go ahead and add set timeout here using login timeout in milliseconds. And if it wasn't settled within that timeout, we are going to set the settled to true, stop the server, and reject that the entire thing has timed out. We can no longer log in. Brilliant. So that is the most complicated part of this implementation, the OAuth and the exchange of the codes that we need to perform. So what we can do now is we have to modify our API client. Let me go ahead and show you. So inside of packages, CLI source lib API client, we now have to import clear auth and get out. And we now have to modify the entire API client here. So what I'm going to do is I'm going to add a second argument here and open an object like that. And then I'm going to add my own fetch here. And that's going to be an asynchronous function, which will accept an input, which is going to be parameters. And inside of parameters, we are going to add type of fetch. Then we're going to get the first item from there. In the second, it's going to be an optional init parameter. Again, using parameters, type of fetch, and then the second one, like that. And that's going to be an arrow function. And inside of that arrow function, we are going to initialize the headers. We are going to get the auth. And if auth exists, we are going to set the authorization auth token. And then we're going to go ahead and get a response from whatever the user intended to call. And in case the response is 401, we are always going to clear our auth token because it means it has become invalid. And finally, let's return response. So we can make this input more readable by collapsing the parameters here so you can see how it looks like. Great. So now every single API client is passing along our auth, whether it has one or if it hasn't. So far, nothing will really change simply because we are not changing our API at this point. So let's go ahead and go inside of packages. Let's go inside of CLI, source, components. Let's go inside of a command menu and in commands. And at the top here, I'm going to add perform login and I'm going to add clear auth. I'm going to find the login method and I'm going to change this action and make it asynchronous. I'm going to leave the toast as is. And then I'm going to go ahead and open a try and catch at a method. Inside of try, I'm going to perform login. And after it awaits, I'm going to successfully show that it's been logged in. Now, in case any error happens, regardless, timeout or user denies permission, we're going to try and show that error message to the user. So let's get the error message. And then we're just going to go ahead and show that to the user in an error variant. Now let's go ahead and find the log out. And this one will be even simpler. So just clear out, as simple as that. So let's go ahead and try it out. So go ahead and let's go to the root first. Bun run dev CLI. And you should now have a logout, which will simply clear the file. Nothing should happen here. And you should have login, which should open the browser. Now I'm going to show you the error that I got. So the request is missing a required parameter, includes an invalid parameter value, includes a parameter more than once, or is otherwise malformed. The redirect URI parameter does not match any of the OAuth's pre-register redirect URLs. So what are we doing wrong? Well, we forgot to add our callback URL, which I defined here. Actually, I didn't. Oh, yeah. So we forgot to define our callback URL. So let's go ahead, go inside of our OAuth here, and let's ensure that we support HTTP localhost 3000 auth callback, and click add URI and click save. So HTTP is the protocol, 3000 is the port. Let's go ahead and try once more. And this time it appears to be successful. So I'm going to go ahead and log in. And after I've logged in, you can see Nightcode wants to access Nightcode 2 on behalf of whoever you logged in with. Make sure that you trust this. And let's go ahead and hit allow. And looks like I'm redirected to a 404 not found. So let me check if I forgot to do something here. It should have redirected me to not found, but instead to an auth callback, which says successfully logged in. So I think I might have started the demonstration too early. I'm pretty sure we are missing some things. So we are missing the entire auth callback server. This entire thing doesn't exist. My deepest apologies for that. For some reason, I thought we were ready to try. Let's go inside of packages, server, source. Let's go inside of lib and let's create our auth utils here. So we are going to need create clerk client. Let's go ahead and do some checks in case our environment variables are missing. And once we know they aren't, we can create the clerk client. And then we can go ahead and create a function authenticate OAuth request. In here, we can grab the request state by using clerk client, authenticate request, and accept an OAuth token. In case it isn't authenticated, we return null. Otherwise, we go ahead and get the auth property, and then we check if the auth property is valid. So if the type is not OAuth token, or if it doesn't include user ID, let's return null. Otherwise, let's go ahead and return the proper user ID. Now let's create the callback route. So inside of routes here, I'm going to create auth.ts inside of routes. I'm going to import Hono, and then I'm simply going to create one single route that we need, the callback route. In here, I'm going to extract code, state, and error from the query. I'm going to get the error description if I have one. If the error is present, I'm going to do an early return here with the error description. If I'm missing code or state, let me fix the indentation here. If I'm missing code or state, I'm missing something. You can see login finally timed out. Now let's go ahead and open try and catch. Inside of try method, let's go ahead and get our encoded from state. If encoded is missing, let's throw invalid state. Let's go ahead and get the payload parsed. From the payload, we can deconstruct the port where our temporary server is serving through bun. If that port is incorrect, let's throw. And now we have to construct the redirect URL using localhost port callback and pass along the code, encode it, pass along the state, encode it. And then let's go ahead and redirect the user to that redirect URL. And in the catch method, let's go ahead and return invalid authentication state. And finally, let's export default app. So don't confuse this localhost port with our server, okay? This is where OAuth is going to redirect after we log in. This is the callback. And then the callback is going to redirect us to this, OAuth.ts, to this bun server that we are running, right? So we get the port and then we construct it for the OAuth request before we go ahead and do the OAuth token and before we open the browser and everything, right? We send all of that through the URL. And then when the OAuth returns that back to us here, we can deconstruct the port and then we can redirect to that temporarily open localhost. And then we do a proper exchange. So it's a little bit complicated flow, but that is actually the same standard that you see in open code, that you see Codex doing. Alternative is enter an API key, but it's kind of boring. I thought it was a much more interesting thing to do, to allow browser login, which somehow automatically tells your CLI, yeah, he's logged in. You can only achieve that by using callbacks through OAuth flow, which then redirect to a bun serve that's been initiated through the CLI app itself. That's kind of the only way you can do it. The alternative is device flow, but that's a whole other story. But basically, you need to have an app running, a small server running, not to be confused with our Hono server. So just a small bun server running, initialized through the CLI package. And because then this server is basically waiting for the code and the state to tell us that everything is okay, right? So that's the only way it can immediately save the token, and it can immediately tell the user, hey, you have successfully logged in from this entire other application, because we are now making two applications communicate, your terminal app and your browser. So that's why it's complicated. Great, so we now have that. Now that we have our API route, we should probably register it. So let's go inside of index.ts. I'm gonna go ahead and import auth, and let's go ahead And let me chain all of these. There we go. Let me just do proper indentation. So now we have auth. Perfect. And I think that at this point, we can probably try it again. So let me go ahead and try it with /login, which opens the browser. And after I click allow, there we go. Authenticated. You can close this tab. And I missed it, but there was a success message here that popped up. If you have it side to side, you are probably seeing it. Beautiful. So that worked, but we have a problem. If I hit log out, nothing really changes. I can still load all of my sessions. I can still send new files, everything, right? So that isn't how it should be. If the user is logged out, they shouldn't be able to do anything. So let's go ahead inside of server source. Let's create a new folder, middleware. And inside of middleware, let's create requireauth.ts. Inside of here, we have to import create middleware from Hono factory and authenticate OAuth request. Let's create a type, authenticated environment, which gives the user ID variable to every context. Now let's go ahead and create the actual middleware, which returns back the authenticated environment. So we do an asynchronous function with context and next. We go ahead and open a try method. In the try method, we attempt to authenticate OAuth request using c.request.raw. If there is no auth, we throw back an error. Otherwise, we are simply going to set the user ID variable to the context. So every subsequent request will have it. And we proceed with the next middleware in line. And in the catch, we simply throw. And now that we have the middleware, let's go ahead and assign it where it needs to be. So I'm going to go inside of my index.ts, and I'm going to import requireauth. And let's go ahead now above the routes here. And let's just make sure that every route from session and every route from chat uses requireauth. So just by doing this, if I do hello world, I now have an error. And I'm not sure if you, all of our errors are caught, so we're not seeing any. If you try to load sessions, you have an error. Anything you try to do, you get an error, except, of course, looking at the models and looking at the agents. So now to make it actually work, we have to go back inside of our routes here. For example, let's go inside of our sessions. And we now have to add type safety for the user ID thing. So find the new Hono and simply extend it with authenticated environment from the middleware. So we have user ID because that's what we set, user ID. That's where we store it if it exists. So what you can now do is everywhere you need to query by the user, you can extract the user. So we are no longer loading all sessions, only those in which this user belongs to. And now let's go ahead and find the individual get ID one. And let's also include user ID, a composite index. Now let's go ahead and do it in the post request down here as well. So we get the user ID, and we no longer use mock user. Instead, we simply use user ID or shorthand operator like this. And if I search for mock, there are only comments. Perfect. So now sessions can only be created and loaded by a specific user. So let's go ahead and check it out. If I do hello world, nothing works. But if I go through the outflow, you can see I'm now signed in. I did it in my other monitor and I do hello world. This should be my first session tied to this account. And as you can see, this time I'm not getting any error. So there we go. And now if I go ahead and go through my sessions, you can see that I can only see one session here, which is the first session that I did in this account, because every other session has the mock user as the user ID. So technically, only if we ever create a user with that ID, we'll be able to read all of those previous sessions. Beautiful. Amazing, amazing job. Now I just want to wrap it up by adding user ID to a few more places. So let me just copy this definition. Let me go inside of chat.ts. And in here, we create messages. So let's go ahead and add that here. Let's import this like that. And for example, if we want to resume a session, we're going to make sure that the session whose we are resuming matches the currently logged in user ID. And let's go ahead and do the same thing in initial session ID here, like that. And let's extend it right here. So nothing much should really change at the moment. If I go ahead and type, can I type? You can see that it works perfectly fine, but it worked before as well, but technically someone could abuse the API. Now they can't. They have to be logged in here as well. Beautiful. I believe that marks everything that we intended to do. So that is step 2. Let's go ahead and review the changes. So chapter 8, completing the user experience. Let me go ahead and git checkout b08 user experience, git add, git commit 08 user experience, git push -u origin 08 user experience. And by pushing the branch, we should be able to open a new pull request, and we should be able to review all of the changes. Let's go through the notes from CodeRabbit. So our CLI now supports OAuth login and logout with browser-based authentication flow, which is exactly what we wanted to achieve. We added file and folder mention suggestion in the CLI input bar using the @ symbol with keyboard navigation and selection. All session and chat endpoints now require user authentication. We also have a successful Railway deployment here. We can go ahead and check it out here. Perfect. So we know everything is running smoothly. And the cool thing about Railway is that it knows how to watch for a specific package in your monorepo. You can see these are the watch paths. So even when I create a pull request, which didn't include server, it's not going to rebuild it. So only if it reads the watch path and detects it, that's when it's going to rebuild it. Brilliant. And we have some comments from CodeRabbit. So this is some lint order warning of the environment keys. I don't really know anything about that. Feel free to reorder. Of course, a weak JSON Web Token secret, but we are aware of that. In here, it's giving us a tip that recursive fallback search is too eager for per keystroke updates. So this line runs on every mentioned query change, and that can walk the project through recursively until there's no direct route match. The ignore flag only prevents stale writes. It does not cancel file system traversal, so typing can lag on large repos. Okay, so if you are interested, this is the solution: a tiny debounce and avoid fallback for tiny prefixes. Really cool, actually, because yes, as you try this in a bigger repo, it could lead to lag depending on what machine your users are on. So pretty good advice from CodeRabbit. Feel free to implement this if you feel like doing that. In here, again, a very good advice: validate token response shape before accessing access token. That's what I was thinking of immediately when I did a cast here. We could definitely use Zod validation, like a Zod schema, and then make sure we have parsed data correctly. So again, great comment by CodeRabbit here. In here, it gave me a critical issue, but it was incorrect. So it told me that if I use middleware this way, it won't cover sessions, but it absolutely does. I tested it myself, and in the guide of Hono, you can see the example is here. So now it's cool because it knows this from now on. Brilliant. And in here, it's also telling us to harden the port validation before redirecting. So again, we should probably just ensure that port, I mean, we already do some hardening here. I guess we can do it even more. Yes, okay. There's a range that has to be supported. Got it. Again, a very good suggestion by CodeRabbit. If you want to, feel free to improve that as well. Brilliant. So I'm going to go ahead and merge this pull request. I'm not going to delete the branch. Instead, I'm going to go ahead, check out to my main branch, and then git pull origin main. So everything is up to date. Brilliant. That marks the end of this chapter, which means we should now have 8 branches here. Brilliant. Amazing, amazing job. In this lesson, we're going to implement billing. We're going to do that by introducing the upgrade command and the usage command. The upgrade command is going to open the checkout screen in the user's browser, and user will let them know how many tokens they have left. We're going to achieve that by using Polar SDK. We're going to implement a new middleware on the server called require credits balance, which is going to allow the request if the user has enough credits and deny it if they don't. We're going to use this to guard API endpoints like sessions, chat ID, and chat ID resume. Whenever AI streaming is finished, we're going to extract total usage tokens, and we're going to develop a calculate credits for usage function, which will extract input and output tokens and multiply them by our pricing multiplier. For that, we're going to use ingest AI usage function, which will use Polar's unit economics layer to calculate how much to bill this user. We're going to do this for completed messages, but also for interrupted messages. Whenever our API endpoint has been hit and whenever we occur any costs, we're going to calculate how much we should bill the user for that same action, making our app profitable and monetizable. Let's start by creating an organization with Polar. Head to the link on the screen or just polar.sh and create a new organization, which will look something like this. It doesn't really matter what you enter here because once you actually create your first organization, you're going to click here and you're going to click Go to Sandbox. And once you are in Sandbox, you're going to have to do it all over again. So in here, I'm going to create a new organization and I'm going to call it Code Tutorial. You can select any payment currency you want and just make sure to agree to Polar's terms. Using it in here, in the sandbox, allows you and gives you the freedom to try whatever you want without fear of doing something live. You can see the big banner here. The changes you make here don't affect your live account. Payments are not processed. So now that we have this dashboard, let's go ahead and set up everything we need to do. Let's start by creating a new meter. So we're going to go inside of products, meters, and let's go ahead and click the plus button here. Let's give it the name of Code Credits. And let's go ahead and create our first filter. The filter condition group is going to look for name equals, and then we're going to type Nightcode_usage and press enter. And that's going to select it like this. And for the aggregation, select sum over property name credits. Both Nightcode usage and credits are important to be named exactly like this. And then we can just leave this to be scalar. Later, we might actually change it to something else, but for now, let's leave it like this. And make sure that you have this very simple Nightcode credits meter. Now that we have our meter, let's create a benefit. So again, click on the plus button and let's call this 1,000 credits. And let's go ahead and select meter credits as the type. Select a meter, Nightcode credits, and give the user 1,000 credits or 1,000 credited units. Depending on your choice, you can roll over unused credits into the next cycle. I'm not going to do that for simplicity. So let's just hit create. And just like that, we now have our benefit, which uses the meter which we have just created. Finally, let's create a product. So click on products once more, new product. Go ahead and give it a name of 1,000 credits. Make sure it is a one-time purchase. Select whatever currency you prefer, and then select a price. I'm going to set it to be $20. And for $20 of fixed price, you're going to get 1,000 credits using our meter, like that. If you scroll down, you can find metadata, which we don't need to populate ourselves. We can do this programmatically. For the customer portal, select private. So this is only purchasable via a direct checkout link, which is generated using the API. And in here, you can customize by adding an image and description, which I'm going to skip for simplicity. And just like that, we have our first product, which uses the benefit, which uses the meter. Now let's go ahead and prepare the environment variables, which we're going to need to extract from Polar and add to our example and environment. So I'm going to start with environment.example here. We're going to need to set Polar access token, Polar product ID, Polar server, which we can already hard code to sandbox here, just like we did for JVT secret, for example, and Polar credits meter ID. So let's go ahead and add these, and let's immediately copy them and then add them to our real environment file. So I am adding these to my .environment in the root folder. All right, so let's first obtain the Polar access token. For that, we can go inside of settings here, scroll down until you find developers and hit create token. I'm going to go ahead and call this night code development. I'm going to set the expiration to no expiration. And since this is sandboxed and just for development, I'm going to select all of the scopes. And down here, I'm going to hit create token. Then I'm going to copy this token here and I'm going to paste it in the environment file. Now let's obtain the product ID. So I'm going to go inside of my products here and I'm going to click copy product ID. And I'm going to paste that here too. We can leave the Polar server to be sandbox. Now let's obtain the credits meter ID. This one is a little bit tricky because usually this is intended to be identified using the filter condition group and the name night code usage. You can see that it doesn't really give you an option to copy the ID, but you can copy the ID from the URL. If you take a look up here, you will have products and then meters and then an ID here after the slash. So just copy it here from above and paste it here like that. Even if you end up not managing finding the meter ID, you can still finish this by using night code usage filter to find your meter. Great. So now we have everything we need in regards to the environment file. Now let's go ahead and install the Polar package into our server. So go inside of packages, server, and in here, let's do bun add Polar sh SDK. So just like this. Let's go ahead and confirm it's been added into the correct place. So inside of server, I have package JSON, and in here I have Polar sh SDK. Now let's create all of the helpers which we're going to need to implement this billing functionality. So I'm going to go inside of packages, inside of server, source, and here inside of lib, I'm going to start with polar.ts. I'm going to go ahead and import Polar from Polar sh SDK. I'm going to create a type for Polar server union. I'm going to create a helper function, which will help us check if the environment variable exists or not. I'm going to add get Polar access token function. Then I'm going to add get Polar product ID. And finally, get Polar credits meter ID. So these functions are used to check if we have the proper environment files set in our project. Then let's go ahead and create a function get Polar server, which returns a Polar server. So in here, we have to obtain the Polar server environment variable, which if not set, will simply fall back to sandbox. So that's technically in line with all of these other ones that we have, but with a fallback. Great. Now let's go ahead and actually initialize the new Polar like this and give it the access token and server from our helper functions. Let's go ahead and create a function has status code so we can properly parse the errors. Let's go ahead and create the create checkout URL params function, type. And then let's actually create a function create checkout URL, which uses those params type here, accepts the customer external ID and request URL, and simply uses Polar checkouts create, selects specific products, so the one we have in our environment variable, and in the success URL redirects to billing success and passes along the request URL. It maps the external customer ID and adds metadata, which you can or don't have to have. It's just useful for logging. Now let's go ahead and create a similar function, but for invoking the customer portal URL. So this one. Very similar. Instead of Polar checkout, we do Polar customer sessions, and we again extract it, we scope it using the external customer ID. Now let's go ahead and develop a function for getting the available credits balance. So we're going to open a try and catch function in here, Let me show you what we're going to do. So inside of try, we're going to get customer state. We're going to get matching meters by finding by meter ID and using getPolar's meter ID. If we cannot find it, we're going to throw expected exactly one matching polar credits meter. And then from that credits meter, we're going to get it and extract the balance. And in the catch, we're going to check the has status code with the error. And if the status code is 404, we return back a negative and we throw the error otherwise. Now let's go ahead and develop a function, ingest AI usage params. And let's make this function here use it. So ingest AI usage will accept external customer ID, event ID, and credits. And it's going to use the ingest AI usage params. If it doesn't have credits, it's going to return. Otherwise, let's use polar events ingest. And this is important. It needs to call nightcode underscore usage because that is exactly what we've set in this meter. Remember, so open your meter and check that it has nightcode underscore usage, okay? It needs to match exactly. And the metadata credits need to match exactly. It cannot be misspelled, right? It needs to be credits because we aggregate over credits. So these two strings are extremely important. All right. So that is our polar.ts file. And now let's go ahead and create some other ones. Now let's create another helper here in the lib folder, in our server lib folder called credits.ts. Let's go ahead and add the imports that we need. So from nightcode shared, we need supported chat models, find supported chat model, and type model pricing. And we need to import type language model usage from the AI package. Then let's go ahead and import a type, calculate credits for usage params. Let's create billable usage type. And let's create a type token counts. Next, let's go ahead and define the following: tokens per million. So this is the reasoning behind this. Nightcode charges in internal credits instead of exposing provider pricing. We currently peg 1 credit to 1 cent, so credits stay easy to reason about, like cents, while still being granular enough for small AI usage. Change this constant if product wants a finer unit like 0.01 or a coarser one. So let's go ahead and define here US dollar per credit. So this is why I mentioned earlier that maybe we could change the unit here, because at the time when I developed this actually wasn't an option, but you can see that this controls how prices are formatted for display. For example, selecting token shows prices as $20 per 1 million tokens instead of a raw per token amount. So I'm not sure if this will change anything mathematically for us, or if it's just for display, because it technically could be useful for us to use it as a token. I mean, it's not that difficult to just create a new meter later and test it out. But for now, I want to stay true to how I did it the first time. All right, so once we have that, let's go ahead and develop a function called getTokenCounts. So getTokenCounts will accept the usage and return token counts. From usage, we can extract input tokens and output tokens, throw an error if any of those is not defined, and then just return them. So more like a parser, right? Now let's go ahead and develop a function called getModelPricing. GetModelPricing will accept the provider and the model and return model pricing. We're going to find the supported chat model. If there is no model or if there is no provider, we're going to throw that this is unsupported. And same thing if it can't find something else. And basically once we 100% ensure that we support this provider, and if we support this model, only then go ahead and return its pricing, which we define for each model in here. Now let's go ahead and create a simple function, estimate cost in US dollars, which accepts input tokens and output tokens and returns this calculation. Now let's go ahead and create a convert US dollars to credits function, which accepts estimated cost in US dollars and it returns back into credits. And finally, let's go ahead and return calculate credits for usage function. This function will accept provider, model, and usage. It will get token counts, pricing for the model, estimated cost in US dollars, and the credits. And finally, return the credits. And that is all we need for the credits.ts helper function. Now let's go ahead and create our middleware. So instead of server source, let's go inside of middleware and let's create a new file called require credits balance. billing.ts. Now inside of here, I'm going to add create middleware, the type authenticated environment from our nearby middleware, and get available credits balance from our new lib polar. Now let's go ahead and prepare our new middleware here, which is called require credits balance. Let's go ahead and make sure that we inject authenticated environment here. So this context actually has an authenticated environment which holds the user ID because we're going to need it here. Let's go ahead and open a simple try and catch block here. And inside of try, first things first, we extract the user ID, which we can do in a type-safe manner. You can see when I hover over user ID, it tells me it's a string. If I misspell it, it throws an error because of this. Now that we have the user ID, we can use it to extract their credit balance. So I'm going to go ahead and add a little comment here. So this is a simple launch time gate. Only start new work when the customer still has credits left. It does not reserve the full eventual cost of the request. So low volume apps may tolerate small overspend on edge cases, just for your information here. Let's go ahead and simply throw back an error if credits balance is less or equal than 0. Otherwise, let's simply go to the next middleware, or in our case, API route. And if anything else fails, if we are unable to establish how many credits the user has left, we have to throw again. We cannot let them spend our cost and incur costs on our side just because we cannot verify how much they have left. Great. So now we have a middleware and we are ready to start making API modifications. Let's go ahead and create a new route instead of the server source routes. I'm going to go ahead and create billing.ts. Instead of the new route, billing, import Hono, import authenticated environment from require auth, create checkout URL, and create customer portal URL from lib portal. In here, let's define a new Hono app, but make sure to inject authenticated environment inside of it. And in here, let's go ahead and chain a post request checkout, which is an asynchronous one, which is able to extract the user ID from the context and simply return await create checkout URL and scope it via customer external ID to the user ID and request URL to simply be see request URL. Then let's go ahead and chain portal once again. Let me remove the semicolon here. So post portal will do a very similar thing, but instead of checkout, it will generate the customer portal URL. Great. And finally, let's create one hard-coded endpoint success to which all of these endpoints redirect back to. So they simply show the user success. You can now close this tab and return to night code. And let's not forget to export default of this app, or should I say of this billing. Now let's go ahead and register our new billing route by going inside of server, source, and let's go inside of index.ts. I'm going to go ahead and import billing from routes billing. And then I'm going to register these routes. So I'm going to go ahead. Let's see. I'm going to first register the middleware here. So billing checkout will require auth, and billing portal. Both of them are going to require auth. And then let's actually register the route here. So it doesn't matter where you do it. Route billing. All right. So billing checkout. Technically, oh yeah. So we're purposely not protecting the entire thing because there is one here which we want always to be available without auth added here, okay? So that's why we are explicitly protecting these two. Now let's go ahead and let's adapt our existing route in the server called chat.ts, and let's make it work with our new billing system. So for that, I'm gonna go ahead and add require credits balance, calculate credits for usage, and ingest AI usage. Also make sure you have the authenticated environment, which we seem to have from the previous chapters. Besides this, let's also import type language model usage from AI. Now let's go ahead and find the stream params down here. And besides session ID, let's extend it with user ID. Let's also go ahead and create a brand new type here before this function stream AI response called ingest usage for message params. Now that we have the user ID, we can actually extract it here in this function. And let's go ahead and create a new variable here right after the resolved model called completed usage, and give it a type of language model usage or null. And by default, it's going to be null. Then go ahead and find this await database message create. And instead of await, let's do return. Scroll down to where it's finished. And in between the try block and that function here, we're going to go ahead and develop a new function called ingest usage for message. It will accept message ID and status using our params from above. First things first, if there is no completed usage, let's do an early return. Now, let's go ahead and open another try and catch block here. Inside of try, we are going to generate billable usage using calculate credits for usage, passed along the provider, model, and usage. Then, let's go ahead and do await ingest AI usage. External customer ID is very important. Event ID, not so much, but useful for logging, and credits are extremely important. Inside of the catch, which will receive an error here, let's go ahead and simply do a console error, so it's useful for us to see if something goes wrong and why. Great. Now let's go ahead and add one more function after this one, still before we enter the try block, called persist interrupted message and usage. So if we get an interrupted message, let's go ahead and await persist interrupted message, and let's await ingest usage for message with the status of interrupted. Now let's go inside of the try block here. Let's go ahead and find provider options. And in here, we're going to capture the onFinish event. Once we get the onFinish event, assign the completed usage, which we have defined above here. Let me go ahead and find it. Here it is. And set it to be, let's see, event total usage. Now let's scroll down until we find stream.aborted right here, or if aborted controller signal aborted. And let's go ahead and call a different function instead of this one, persist interrupted message and usage. Okay. Now let's go ahead and go to the end here, right before the done event. And in here, we're going to await ingest usage for message with the message ID from the assistant and status complete. Let's go inside of the catch error here. Here we are, and let's find if abort controller signal aborted. Let's replace this function again with our new one, persist interrupted message and usage, like that. Now let's go ahead and scroll down for the resume method. We have authenticated environment here, so that is great. Let's see, what else do we have to do here? So we already have the user ID, and we make sure that sessions are loaded by user ID. But let's see if everything is truly finished here. So I'm going to scroll down until I find stream AI response, and we can see an error here. So after session ID, make sure that you add user ID here. There we go. We had that error. Now let's scroll down until we find the post session ID here. And so whenever we want to submit something to a specific session ID, we're going to use our new require credits balance middleware. So let's make sure we use that. And in here, we already do this, but just double check that you are finding the session that belongs to this user. Brilliant. And down here, we should have one more error. Again, with stream AI response, go ahead and simply add the user ID. Brilliant. So that is it for chat.ts route, and we can now go ahead and implement billing in other places. Now let's go ahead and quickly visit our sessions.ts route, and let's go ahead and import a new package which we've just created, require credits balance middleware. And let's also get rid of this Nightcode shared find supported chat model, and instead let's go ahead and use is supported chat model, which we can extract from .lib models. So is supported chat model, a simpler function here. Okay, let's make sure we have these two. Now let's go ahead and find this, and let's make it simpler by replacing this entire thing and just adding is supported chat model in the refine. And then down here, not in the get, but in the post method here, to allow the user to create new sessions, they need to have some balance. So let's make sure we add this middleware here. Brilliant. Those are all the changes we need to do in the sessions.ts. Now let's head to our CLI package. inside of here, let's go inside of lib, and let's create a new file, upgrade.ts. In here, let's import open API client and get error message. Then let's go ahead and create a new function here, open upgrade checkout. In here, we're going to communicate with our new billing endpoint using Hono RPC, so billing checkout post endpoint. We're going to check if the response is okay, and if it is, we're going to use our cross-platform open package to open the user's browser with the return URL, which will be the checkout screen, and throw new error if anything else happens. And then we're going to create a pretty much identical function, but for the billing portal, which targets API client billing portal post request. Great. So this is the only lib which we're going to have at the client. Now let's go ahead and actually wire this into our command prompt. I mean our command popover. So for this, we are going to go inside of CLI, inside of source. Let's go inside of components, command menu, and let's find commands.tsx. In here, let's import open billing portal and open upgrade checkout. Let's first find the upgrade command, which we should already have here. So upgrade by more credits, which right now doesn't really do much. Let's make sure the function is asynchronous, and let's leave this toast message as is. And let's go ahead and open a try and catch function here. So inside of the try function, we're going to await open upgrade checkout. And after we successfully await it, we're going to trigger toast show success, checkout open in browser. Otherwise, if we catch an error, we're going to obtain to parse the error message, and we're going to show an error toast with the error message. So that is for the upgrade one. Now let's go ahead and find the usage one, which we should also have. And this one will be pretty much identical. So make sure it's an asynchronous function. You can leave the existing toast message as is. And then in here, we're going to add another try and catch method. We're going to attempt to open the billing portal this time with a toast of success if it successfully awaits. And if we catch any error, it will simply toast with an error. Great. Now, I'm pretty confident that we have everything we need to test this out. So make sure that you are in your root repository. So change directory if you are inside of server. Make sure you are at the root. And in here, let's go ahead and start our server. And then in the other one, let's go ahead and let's start our CLI. So first things first, I'm going to make sure that I am logged in, because if I try with hello world now, you can see I'm getting an error because I am unauthorized. So I have to log in first. Once I successfully log in and allow all the permissions, I should be able to send a message. So I just want to confirm that, but you can see that now I have a different error. So try sending a message even if you're logged in. You should get no credits remaining. So that is exactly what our middleware is protecting us from. So let's hit upgrade, which should redirect us to this, a checkout screen. In here, I'm going to enter a dummy test card, an expiration that's in the future, any cardholder name, any country at all. So I'm going to choose Croatia here. And you can see that for $20, I'm going to get 1,000 credits. I don't think email matters. Let's go ahead and hit pay now. Okay, so it does matter. So type in whichever email you want here. Let's go ahead and pay. And this should then redirect us to a success screen. Let's give it a moment to finish. And yeah, make sure that you are in the sandbox mode, of course. All right, I'm going to pause and okay, here we are, done. You can close this tab and return to night code. Brilliant. So at this point, I should also be able to open usage. And in this usage here, I can see my benefits. So I can see that I have 1,000 credits here. And what's more useful is the actual usage tab, which tells me how much I have left. But more importantly, does this work? So let's go ahead and try hello world. And I can see that I no longer have any errors, which means that this is successfully working. Now, keep in mind that these credits aren't going to be immediately updated, so give it a minute. This is asynchronous, right? Because we're not exactly querying this ourselves. This is their page, so it depends on how often they refresh this. But you can see after a few refreshes, I now have 998 instead of 1,000. So 2 credits were spent using our ingestion calculation here. Amazing. So we have successfully implemented billing in our project. Amazing, amazing job. So let's go ahead and create a new branch and commit these changes. So I'm going to do git checkout -b09 billing. I'm going to do git add git commit -m09 billing and git push -u origin 09 billing. That should push the branch in here. I should be able to open a new pull request at this point, base it to main, and create a new pull request. And let's go ahead and review our changes. Now let's go ahead and review our pull request. So here's the summary. We added new upgrade and usage commands in the CLI to access the billing portal and check out flows. We implemented credit-based billing system that tracks AI token usage and converts to credits. We added credit balance requirement for chat sessions to prevent overuse. Great. In here we have our Railway deployment, and something I remembered is that we probably have to upgrade the environment variables. So we can do this in two ways. Instead of .environment here, we can simply copy these ones that we need here. So let's go ahead and take a look at our current environment variables, but keep in mind that you're right now in the preview environment. So I actually wouldn't recommend doing it here unless you really want this preview to work as expected. I would recommend just doing it in production instead. So switch to production mode here, open this, open variables, and open the raw editor here. So let's take a look a little bit. We have API URL, we have database URL, and we have Anthropic API key. So immediately here I can see that we are missing the open API key. So I'm going to add that. So you don't have to do this, right? But I'm making sure that we have all the environment variables that we need. Polar is entirely developed on the server, so I know that it needs to have all of the Polar ones. Now from my clerk ones, I'm actually not entirely sure, but here's the thing. We don't really lose anything by adding them. So I'm going to add all of them as well, including the JVT secret. And then I'm just going to hit upgrade variables, and then I'm going to redeploy. Great. Now let's go back to our pull request here. And let's see a comment that we have. Validate token counts as finite non-negative integers. Line 34 currently only checks for missing values. If token values are not a number, infinity, or negative, credit calculation can become invalid and produce bad billing output. So instead of our credits.ts, let's quickly review that. So instead of if input tokens here, let's quickly check where is that function exactly. In here, so get token counts, okay. And how does it suggest we do that? Okay. I'm guessing that, yeah, that could be an improvement. So if you want to, you don't have to, but if you want to, you can add these changes, or maybe even simpler, if you have CodeRabbit, you can probably just tell it to do that, committable suggestion. You can see for you, it's going to do it. It's going to add an if here and throw an error. So we could just update this like this, commit changes, suggestion applied, and then it should re-review the code. You can see that this is now resolved. Great. So I'm just going to pause the video and wait for my deployment and everything to finish, just to confirm that nothing else was broken with this merge. All right, I can see everything is successful. So I'm going to go ahead and merge my pull request here. There we go. I'm not going to delete the branch, so I have a clean history here. And just like that, we are now up to date. So let's go ahead and go back to our main branch and git pull origin main. So we pull that new merge back here, just like that. What I always like to check, you can see how now I have that change applied from CodeRabbit here. So I can see that this all works well still. I like to go inside of here, open the graph, and I just like to confirm that everything's okay. So you can see that in here I have 09 billing. In here I have that commit from CodeRabbit. You can see he was the author. And in here I have merge pull request number 9. Brilliant. So I believe that marks the end of this chapter. Amazing, amazing job, and see you in the next one. This lesson is going to be very different in comparison to all other lessons we've had, primarily because we are not going to be implementing any new feature, but instead we're going to rewrite our chat logic. You're probably asking, why are we doing this now? at the end of this project? Well, that is because I realized by reviewing the code that we have a critical mistake that makes this entire project useless. And I'm not kidding when I say that. Let me go ahead and explain what I mean. The biggest problem is that right now, our tool execution is entirely run on the server. And you might be thinking, why is that a problem? Well, let's go ahead and demonstrate the current state of our app, and then let's change our API URL to target our deployed server instead of our local server. So what happens right now? In one terminal, we do bun run dev server, which is running on localhost 3000. Then in another terminal, we do bun run dev CLI. Notice how both of these commands are being run from the same repository, Code. Now I'm going to go ahead and just do the usual login here. I'm going to continue. I'm going to select my account. And after I allow, I'm going to get redirected back here and I'm authenticated. So if I switch to plan mode and if I do something like, what is this project about? Everything will work as expected. And that is why I didn't notice until now that we have a huge problem in this project. The reason this is able to read all of these files and perform all of these tools is purely accidental, because bun run dev server is also run from the same repository as bun run dev CLI, making it seem like our CLI is executing these tools, but it isn't. In fact, we can ask our AI exactly that. Where is tool execution happening in this project? And you will see that it's going to do whatever it needs to do, but eventually it's going to conclude that all tool execution is happening on the server. This is a huge problem for us because the goal of this project is for the server to be entirely separated. The server needs to be hosted somewhere else, and the CLI should be invoked inside of the user's machine, right? That is the whole idea of this app. Let's take a look at the output here. So I'm going to scroll up a bit to see if there's anything useful. Here is the analysis. All tool execution happens on the server. The CLI is purely a display layer for tool activity. So the tool definitions are actually made on the server. Each tool is made using Vercel's AI SDK. Cool. Tool assembly is made on the server. Create tool function is on the server. Tool invocation is where inside of chat.ts, again on the server. And I completely missed this. I'm not sure how I even did this. When I attempt to build the system prompt, I actually send the directory on the server. And this whole time I was convinced that all this is normal because it worked, right? But it worked on accident. I'm going to demonstrate now by asking something else here. What happens if we decide to host the server on something like Railway or Vercel and then attempt to run the CLI in a specific directory on my machine? So just to conclude this critical issue that we have, let's see what it's going to answer. This is a critical architectural issue. So this is definitely broken. Let me prove that to you. Here it is. It would be completely broken. If we host this server and run the CLI locally, tool execution would operate on the remote server's file system, not our local machine. So the only reason this works right now is because bun run dev server is tested locally from the directory where we are developing this tool here. That is why I am dedicating this chapter to refactoring. To further demonstrate this problem, this is what I'm going to do. I'm going to find my Code server deployment. I'm going to go ahead and copy the URL here. And I'm going to go ahead and find what environment variable is responsible for communicating with the server. So I'm going to go inside of my CLI package lib API client. In here, I can see its API URL. So let's go inside of .environment and let's change the API URL to be this, and let's remove the trailing slash. So exactly like this. Now I'm gonna go ahead and go inside of my clerk, find your auth application, and go inside of redirect URLs. Then once again, copy this and append auth callback here. And let's hit add URL and hit save. Okay, now that that's been saved, let's go ahead and close this, and I'm going to shut down my server because in production, we wouldn't need to have the server running, right? This is supposed to be a production app. So let's go ahead and do run dev CLI. We would have to perform login again because we now have an entirely different API URL. So if you've configured this correctly, you should see successful clerk here. If it doesn't work, if you get some kind of redirect URI is missing, it means that this wasn't properly saved, or maybe you have a typo in auth callback. So just make sure it's this, okay? And click allow here. So I'm successfully authenticated, great, so that works. But what if I try to do what is this project about? Let's see what happens now. My server is not running locally anymore. So apparently it's reading something. Oh, but what happens now? It appears the directory and then the full path to my directory doesn't exist, or it's empty. This could mean that the project hasn't been initialized, the path is incorrect, or the project was recently deleted or moved. It has completely no idea what project am I talking about. So if we were to actually deploy this server, which we are, and then build this CLI as a distributable app and let people download it, whoever tries to run the app would get the same response, but with their path here, because we just send the path to the server. So I completely messed up this logic because it worked because both server and the CLI were being initialized and run locally in the same directory. So by testing that I did, everything worked fine, but I made a critical mistake. So just to show you how you can revert this, go ahead and change this back to localhost 3000, shut down run dev CLI, go ahead and now run the server again, go ahead and run CLI again, and once again you will have to log in now because you have a whole new server now. So you can leave inside of clerk here both your localhost and the actual deployment URL. And once you log in here and you allow the permissions and try again, what is this project about? It will all work. So I guess this is fine if this is a local only project, but that isn't fun, right? That isn't what we intended to build. That is why I'm making this chapter by rewriting the entire chat. But I don't want to scare you too much. The end result is mostly going to be net negative when it comes to writing code, meaning that we're going to remove more code in this lesson that we are going to add. Because along this mistake that I've made, I also made sure to research the entire project and find all other mistakes or complications that I've implemented, which I can simplify. So remember how we implemented our own use chat. And in here, we do tool calling, tool result, text delta, all of that. Same thing in chat.ts route. We stream the response and we carefully stream every single reasoning delta and all of these things. That is because I thought that it wasn't safe to use chat instead of OpenTUI. But turns out we can actually use this, which means we can simplify the entire code base that much. You will not believe how much simpler all of this is going to be. And by doing that, we can officially call this project finished. I simply couldn't leave you with a broken project, so that is why I researched all of the things we can simplify and make better so that you can proudly show this project and share it with other people. Let's get started. Let's go ahead and first add some new packages and remove some packages we are no longer going to use. So I'm going to go ahead inside of my packages, inside of CLI. And in here, I'm going to add AI, SDK, React, and I'm going to add AI. So these two packages right here. Then I'm going to go ahead and remove event source parser and nightcode database. So I'm no longer going to need these two. And then let's go inside of our shared package. So inside of shared, and inside of here, let's do bun add AI once more. So let's take a look at the state of our changes now. So inside of here, you should have changes to your CLI in form of addition for AI SDK React and AI, and removal of event source parser and night code database. And in your shared, you should just have AI like this. And once you've done that, go ahead back to your root project and just run bun install so it all synchronizes. Next, let's go ahead and modify our schema, because that's also going to be one simplification which we're going to be doing. Instead of maintaining the entire message model, here's what we can do instead. We can get rid of it entirely. And then inside of session here, we can simply think of messages as a JSON field. This way, they're going to be elastic and they can adapt to whatever result we return from AI SDK. All right, so let's go over all of the fields here. ID, user ID, title, and we can get rid of the path here, actually. There is absolutely no reason sessions should know what path it is. So we just have ID, user ID, title, created at, updated at, and we have the messages, which is a JSON with the default of an empty array in quotes and an index for the user ID. Once we have that, let's go ahead inside of packages and inside of database here. And let's run bunx prisma migrate reset. My apologies, that's not the syntax. Bunx prisma migrate reset like this. So we want to remove all data because we just made a breaking change here. So let's get rid of all of our data. This is, of course, development only. You should never do this in production. In production, you should do proper migration. Once you deleted all your data, you can run bunx prisma generate and then bunx prisma database push. So let's wait a second for all of this to synchronize with our remote database. And once it is, let's do bunx prisma. Let me see, is it studio? It is. So after you have studio here, you should see only the session table here with ID, created at, messages, title, updated, and user ID. Those are the only things you should be seeing. Besides the messages table, we can now also get rid of all of the unused enums here. So you should just have model session like this. Let's go ahead and run the commands one more time, just in case, even though most likely the generate is the only one that matters here. But let's go ahead and just in case do a database push, just to confirm that we can successfully synchronize our Prisma schema with the remote database even after we removed the enums, and Prisma database studio, just to confirm, my apologies, it is just studio, just to confirm this command still works perfect. So nothing is broken. Now let's go ahead and go inside of packages, inside of database, source, and in here, find enums. You can see that the entire file has errors. So you can just go ahead and move that to trash. Let's go ahead inside of the index here to make sure there's no errors in the client. And we can just go inside of the package JSON here and we can find the enums and we can get rid of this like this. Now we need to develop the replacement for the enums. So let's go ahead inside of shared, inside of source, and inside of here, find schemas.ts. Now schemas already has some content, but we are going to have to modify some of it. So let's see what it currently has. All of this message part schemas, honestly, tool call schemas, all of this will go away. None of this is really needed. The schemas will become an entirely new thing. So go ahead and add Zod and tool from AI. Define the mode here. Let's go ahead and define mode schema. Let's derive the mode type from that. And now in here, we're going to maintain tool input schemas. So we are going to do this in a shared package rather than on the server so that we can both have the schema for the server, but do the actual execution on the CLI. So it needs to be used by both. That's why shared is the perfect place for it. So for each tool, we're going to go ahead and just add a quick pattern. a quick path like this, and description. Some are going to have a pattern like this, so be mindful of that. So I'm just gonna paste each. You can pause the screen and then see what's written inside. Now let's do write file. Now let's go ahead and do edit file, and let's go ahead and do bash. I'm gonna go ahead and zoom out just a bit in case it's easier for you to see this way. And I'm gonna scroll so you can double check that you've added all of them. Make sure you have read file, list, directory, glob, grep, write file, edit file, and bash. Those are all the tool schemas that we need. Great. Let's go ahead and add as const to the end of this object. Then let's go ahead and define a new object, read-only tool contracts. Inside of here, I'm going to define a read file. Then after read file, I'm going to add list directory. Then I'm going to add glob, and then I'm going to add grep. So let's go ahead and add as const to this as well. Make sure that you have grep, glob, list directory, and read file instead of a read-only tool contracts. So we're simply keeping an object here in which we are going to keep a list of read-only tools. So these are basically non-destructive tools, okay? So inside of here, we have various kinds. We have read file, list directory, but we also have write file, edit file, right? But in here, we kind of duplicate that, but it's also useful to explicitly maintain them like this. So now let's go ahead and export the following. Build tool contracts. Inside of here, I'm going to spread read-only contracts. And then I'm going to add a write file. I'm going to add an edit file. And finally, I'm going to add bash. And let's add as a const here as well. Then let's go ahead and export type tool contracts. And finally, let's export a function get tool contracts scoped to the mode. So if mode is plan, we can simply return read-only contracts. Otherwise, let's return build tool contracts. So this is a very handy schema file which has read-only, build, and all other tools schemas we might need. So make sure you have all of them here. Notice how none of these are describing or doing the actual execution here. So we are just describing the schemas right now. Now let's modify the system prompt. For that, we're going to go inside of packages, server, source. Let's go ahead and choose systemprompt.ts, and let's go ahead and replace this with mode type import from Code shared. And let's go ahead and replace the mode with mode type, and let's remove the path here entirely. Let's quickly fix what this problem is here. Code shared. Ah, yes. So what happened here? Let's for a second go back inside of here. Let me show you where I am. So inside of my shared, we just developed the schemas file, but I completely forgot to modify my index, my export of the shared package. So this is where we just wrote all of those tool contracts and schemas. Now let's go inside of index.ts, which is just next to it here. And in here, we're going to have to modify our export or return structure. So what has to be modified? Well, pretty much everything from the schemas file, because everything was modified. So we now have mode, we have mode schema, tool input schemas, get tool contracts, type tool contracts, and we have type mode type. So all of this should be exported from shared index.ts. While we are here, we can also take a peek at package.json and just confirm we have the AI package here, though I believe we added this at the beginning. So what we can do now, once we have the proper export here in the index, in the shared, we can go back inside of system prompt, which we started fixing. So instead of server source system prompt, you can see how we no longer have the error for importing this. So we can assign that to be the type of mode. And inside of build system prompt, what I want to do is I want to get rid of the path entirely. So I only have a singular mode here, okay? So how are we going to modify what we have here? Where very simply, we're just going to remove it. We are not going to let the system prompt be aware of anything regarding the path, right? So let's get rid of that. Let's scroll down here and we can again just leave if mode plan, as simple as that. And down here, if mode build. That's it. Nothing else here needs changing. So now our system prompt has a very, very clean build. Now let's go ahead and delete all of the tools on the server. So if you go inside of your packages, server, source, all of these tools here handle execution logic. You can see how they're actually looking through the file system. But as we deducted, all of this is unfortunately problematic and completely wrong because it's reading the file system on the server, where it should be reading the file system wherever the CLI package is running. So we can just highlight the tools folder and we can delete it entirely. So you can see that you should have all of these files deleted. All right, now that we have that, let's add some code for a change. Now that we deleted all of the tools from the server, let's go ahead and build the actual execution logic inside of the CLI. So inside of CLI, source, inside of lib here, I'm gonna go ahead and create local tools.ts. So we explicitly know what this is. Let's go ahead and add some imports. So all of this from fs promises, all of these from path, and all of these from our nightcode shared, which has now been modified and it's ready to go. Let's add all of these constants here. And let's first create a simple function called resolve inside path. So this is kind of a guardrail to ensure that whatever the user is trying to search for by using agent tools is inside of the path that we want it to be. Now let's go ahead and add a simple truncate helper function here. And then let's go ahead and create a factory of tool execution. So a function called execute local tool, which accepts a tool name, input, and mode. First things first, we're going to go ahead and check whether we are in plan mode, so we know we have to forbid certain tools. So if mode is equal to plan mode, and if not read file, list directory, glob, or grep. So if it is not any of these, we have to throw an error. Whatever tool you are requesting is not available in plan mode. So this is the guardrail, so that in plan mode, only read file, list directory, glob, and grep can be used. Now let's go ahead and open a switch case based on the tool name. And let's start with a case of read file. So if it's a read file, make sure to read the actual file, call our resolve inside path here, and then simply use the API to read file and return back the content. Now let's go ahead and develop a more complex one, which is list directory. So another case here, I'm going to show you the entire thing. Here it is, list directory. Once again, we get the path, we resolve the path inside of our guardrails, and then in here, you can see that we are reading inside of directory, but we skip node modules explicitly here. And we return back the results. That's the case for list directory. Now, let's go ahead and develop our glob tool. So once again, I'm going to show you the entire thing. Here it is, our glob tool. After the glob tool, let's go ahead and return our grep tool. So I'm going to develop the grep tool in phases because it's a bit longer and I want you to see the entire code. Feel free to use AI assistance for this. It is surprisingly good at this type of things. So let's go ahead and add this. Let's go ahead and establish some arguments here. Then let's go ahead and push those arguments. let's go ahead and spawn the actual process here. So this part. Then let's go ahead and handle return messages or errors. Let's go ahead and define constants for lines, matches, and a truncated let here. Let's go ahead and parse over all the lines using a for loop. So after truncated false, go ahead and add this for loop right here. And then let's go ahead and return all of the matches. And if truncated, let's go ahead and include that in the metadata here, along with the length of the total matches. Then let's go ahead and develop the case for write file. After write file, let's go ahead and develop the case for edit file. After that, let's develop the last one, which is bash. Let me go ahead and slowly show you the entire thing here. So this is bash. I can zoom out just a bit so it fits on the screen. This is our bash tool. Feel free to pause the screen if you want to type it out. Then let's go ahead and add a default case, which is simply to throw unknown tool. Great. So we have now replicated all of the execution logic inside of the CLI package so it can safely be executed here and not on the server. Now it's time to develop the refactoring of our chat.ts route. Unfortunately, the diff is so big that it simply makes sense to start all over. But the good news is that the end result is going to be drastically simpler than what we have now and also much shorter. So let's go ahead and delete the entire thing and let's start with the imports. So we add Hono, validator, and Zod. Then from the AI package, let's add all of these. Then let's go ahead and add our database and let's go ahead and add type Prisma. I'm going to see what the error here is. I think we don't import database. I think we import client, but we're going to see in a second. So let's go ahead and get tool contracts, mode schema, type mode type, and type tool contracts, all from Code shared. Then let's go ahead and import build system prompt from our newly refactored system prompt. Let's go ahead and add some middlewares here. So this one is for authentication. This one is for sufficient balance or billing. Let's import calculate credits for usage. Let's import our ingest AI usage from Polar. And finally, let's import is supported chat model and resolve chat model from lib models. Now let me go ahead and resolve what we have in the database here. So perhaps I need to do run database, Banex Prisma generate. So it's not database. Let me see. How are we importing this usually? Let me quickly check inside of sessions. Oh, database client. My apologies. All good. All right. And yes, we have some errors in the sessions, but we're going to fix that. So yes, my bad about the Code database import. We need to do it with another / client here. So we explicitly request the client and then we get the database. All right. So now let's go ahead and continue developing this. We're going to add a type chat message metadata. In here, we're going to maintain the mode for each message, the model, the duration, and the usage. Let's go ahead and develop a type from that by constructing it by using UI message from AI. In here, we can then append the metadata that we intend to extend the existing UI message with, and some tools here for tool contracts, which we've defined. Now, let's go ahead and develop the submit schema using Zod, which accepts the ID and accepts the messages. Messages are an array of a custom object with a type of Code UI message. And it's a minimum of 1. Otherwise, the validate UI messages will break. In here, we maintain the mode, and down here, we maintain the model. Now let's go ahead and define the submit validator using zvalidator. Let's go ahead and develop a helper function, has pending tool calls. In here, we have to skip all pending or dynamic tool calls because that is otherwise going to hang forever on the CLI. This is easier to understand if we first wrote it incorrectly and then had to fix it. But since I want to focus in this lesson on just bringing you the working version of the code, you're just going to have to trust me that we have to skip certain tools or certain deltas like output available, output error dynamic tool, simply because it's not going to work, because things kind of change now that we execute tools on the client instead of the server. So we have to purposely skip some because as I said, it will infinitely hang on the client and not a single tool would ever be able to be executed. That's why we need this function right here. Now let's go ahead and develop the actual router here using Hono and pass along the authenticated environment here. And let's go ahead and start with a simple post request. So I'm going to go ahead and open the post request. And in here, I'm going to establish the /route, which will essentially be the chat route. For the middleware, we're going to use require credits balance and submit validator. And then let's go ahead and add an asynchronous function here. Inside of the asynchronous function, let's go ahead and extract the user ID as well as all the body parameters from the validated JSON because we are using zvalidator from Hono. Then let's go ahead and load the actual session scoped to the ID and the user ID. And if we can't find any session, we have to throw an error, meaning that we can't do any AI generation because the session hasn't been found. In order to calculate the duration of the messages for the UI display, we have to start a timer like this. Then let's go ahead and invoke all the tools like this. Let's go ahead and obtain a resolved model. Let's go ahead and obtain previous messages or an empty array if we can't find any. Let's go ahead and add a copy of them in merged messages here so we don't mutate them directly. Now let's go ahead and go over each message inside of our messages here. And let's go ahead and create incoming message, which should satisfy Nightcode UI message. Then let's go ahead and find the existing message index using merged messages. And let's go ahead and decide where to assign it. So if existing messages index is -1, we have to push it in the array. Otherwise, we have to put it in place of the existing message index. Outside of this for loop here, let's go ahead then and define next messages using await validate UI messages function from AI and assign the Nightcode UI message type here. Here we are. And alongside messages, also add the tools, so this can properly be validated with the tools it had at the time. Now let's go ahead and load all of the model messages, and let's go ahead and define a constant which will change later, completed usage. Now let's go ahead and define the result. The result uses a stream text API from AI SDK, passes along the model from our resolved model API, the system using build system prompt and the mode, messages from model messages, and the tools. But the cool thing is the tools is only calling the tool contracts, meaning that there is no execution being done here. So we still need to have tools on the server, but they shouldn't be executing anything. We have the provider options here, and we have an onFinish event to calculate the completed usage. Great. Now, let's go ahead and instead of developing our own event source parser, what we can simply do is return AI SDK's one, which will be compatible with the use chat hook. So first things first, let's add original messages here. Now, let's go ahead and add, or should I say, construct message metadata. We need this because I still want to maintain the UI look and feel of our messages. So I have to construct the metadata as it was. Okay, so if part type is start, return mode and model. If part type isn't finish, return undefined. And for all other instances, return mode, model, duration milliseconds, which is calculated with date now minus start time. And if we have completed usage, go ahead and add that as well. Now let's go ahead and decide what happens on an async on finish event here. So in here, first things first, if it's aborted, let's go ahead and do an early return. Then if it has pending tool calls, so this is why we had to do that function. So if it has any of those tools, let's go ahead and do an early return so it doesn't hang forever. After we solve those two cases, let's go ahead and update the database session by updating the messages. Then let's go ahead and do an early return if there is no completed usage. But if there is completed usage, let's go ahead and open a try and catch block and let's attempt to ingest the billable usage. So we can now use our calculate credits for usage using resolved model provider, model ID, and completed usage, and finally get the billable usage. And then what we can do is we can await ingest AI usage from our Polar lib for this user ID for this amount of credits. And if we get an error in this process, it means we were unable to bill the user. So we're just going to log that for us for now, like this. And finally, let's go ahead and add the last line of code here, which is on error, for which we want to simply parse the error and return it. And last but not least, let's not forget to export the app. There it is. That is the last line. So this is our new rebuilt chat.ts route. If you compare it to what we had before, which we can actually do using a git diff here, you will notice that it is drastically simpler. Take a look at how much file was deleted in comparison to how much it was added. So we are pretty much done already here. Take a look at all this file which was deleted. All of this is now handled via AI SDK instead of having to maintain our own version. So I think this was a much, much better solution. Now let's go ahead and fix our sessions route, which will be much simpler than this. Go inside of sessions here, and let's start by fixing the imports here. So we can completely remove the role, mode, and message status from here. And we can also remove is supported chat model. So we only have authenticated environment, require credits balance, Z validator, Zod, database, and Hono. These are the only things we should have. So inside of the create session schema, we can pretty much delete everything but the title. That's the only thing that matters here. And then down here, when we actually load the, let's see, so this one is perfectly fine. I think that this individual one is a bit problematic. Here it is. So when we load the individual session, we now no longer need to include anything. It's included by default because it's now a JSON field here, okay? And then what we should do here in the post method, we should, let's see, we have this initial message here. We don't need any of that. I think we can now just get rid of this. And let's see, user ID, yeah, we can just do data here like that. And we don't need to do this entire thing. And we don't need to add any include. So as simple as this. Let's take a look again. So just data, session, data, user ID here. We can leave this, it's useful for mocking. And you basically shouldn't have any errors in your code. So a much, much simpler version of sessions now. Brilliant. Now that we have a brand new chat.ts and sessions.ts, it's time for us to rebuild our use chat hook. Take a look at how massive this hook is, because it needed to handle all of the things that chat.ts was previously returning. So it was a very complicated hook. Let's go ahead and delete it entirely, and let's build a much more simpler and elegant solution for it. So we're gonna import use memo and use chat, and we're gonna alias it as use AI chat from AI SDK React. Then let's go ahead and add all of these imports from the AI package. Let's go ahead and add all of these imports from our new night code shared. And finally, API client, get out and execute local tool. So we are finally going to be doing this on the client here. Let's go ahead and export the type chat message metadata with mode, model, duration in milliseconds, and usage. Let's go ahead and develop the type for chat tools. Then let's go ahead and export the type for the message. And finally, let's export our use chat function here. It will accept session ID and initial messages. First thing we need to do is we need to define a transport which will be passed to the use chat hook. Well, not this use chat, but this use chat from AI SDK React. So inside of this use memo, let's go ahead and open it. And in here, let's go ahead and immediately return new default chat transport and pass along the message type. Inside of this default chat transport, we have to define which API endpoint we are going to target. So we can use API client chat and request the URL from that, and then go ahead and parse it to string. This is essentially going to target this chat.ts route, which we have been refactoring. So since this is, even though we used API client here, we only use it to get the URL. This default chat transport has its own fetch function here, which means we have to add the headers to make sure it has the auth. So that's why we need to do it separately here. We need to get auth. If it's available, we have to add the bearer token. Otherwise, just pass along new headers. Let's go ahead and further prepare the send messages request. Extract the messages prop from here. Let's go ahead and start by getting the last message. If there is no message, let's go ahead and throw no message to send. Then let's go ahead and obtain the metadata from the message using an optional chain method. Then let's go ahead and define the previous message. And finally, let's construct the request messages by using the message role. So if message role is assistant and if previous message role is user, let's go ahead and make sure we have the proper order here. And let me indent this, okay. And finally, let's go ahead and do a return here. Body with ID, messages, mode, and model, like this. And in the dependency array of this use memo, we need to add a session ID, so it is updated for every new session. And now let's go ahead and actually use AI chat. So instead of having to develop all of those deltas and checking for all of those different things, we can now just use AI chat. And in here, we can pass along a session ID, which kind of serves as a key. So it's going to reset every time the session ID changes. This session ID could be whatever. Messages, basically the initial messages. Transport, which is essentially the fetch client. And then here's where the magic happens. On tool call. This is where we decide that we are going to execute the tools. First thing we have to do is we have to extract what mode are we in, which we're going to use by getting the last message mode. And then we're going to go ahead and call void execute local tool. From the tool call, we're going to pass along the tool name, tool input, and finally the mode. And then let's go ahead and chain a .then here. And I'm purposely using .then instead of awaiting, because if you await on tool call, it can lead to hangs, okay? So make sure you use .then and then use chat add tool output and this information here so we can properly display it in our UI. And the same way we handle .then, let's handle .catch in case any error happens. And then let's go ahead down here and add one more property, send automatically when last assistant message is complete with tool calls from AI. So a handy helper here. And guess what? That's it. That's the entire hook. All we have to do is return the information now. So let's go ahead and return the simple ones first, messages, status, and error. Then let's go ahead and develop the submit method. So the submit method has params, which are user text, mode, and model, and it immediately returns chat send message. So be careful here. Some of you might want to wrap this inside of parentheses like this, which is fine, but then you have to remember to do an explicit return here. I actually prefer this. I always like opening the brackets and explicitly seeing return, because then I understand what this is. So when you hover over submit, this is how it should look like. That's how you know you did it correctly. It should basically immediately be the send message, which is right here, okay? Now that we have that ready, let's go ahead and add two more things, which are abort and interrupt. So this looks useless, but it's because I'm adapting this so our existing code works as much as possible. I don't want to do a huge refactor, okay? So that's why I'm purposely doing this. So it's kind of a backwards compatibility that I'm adding here. And that is it. That is our entire refactor of use chat hook. Let me show you the drastic difference. So the red lines are what we removed and the green lines are what we added. Take a look at this. How many lines of code were removed for a more elegant solution? Because we discovered that we can actually use chat. So you might be wondering, was all of this a waste of time? Well, not really. Rarely do people embark on building their own version of AI SDK, which is essentially what we did. But eventually we came to a conclusion that it's better if we used AI SDK in the first place. Well, we learned that and we're fixing it right now. Let's continue fixing some broken types now. So back inside of packages, CLI, source, components, command menu, and types.ts, you can see we have some errors. So we can now remove supported chat model ID, and we can remove mode, and we can import both from Code shared like this. Let's go ahead and switch mode for mode type here and here. And just like that, we fixed our command menu types. Now let's go inside of our dialogues here, and let's go inside of agents dialog. So similar thing here, instead of database enums, let's go Code shared, and we need to import mode, yes, but we also need to import the mode type. So let's go ahead and set available modes to be this, current mode to be mode type, on select mode param to use a mode type, and the label to use mode type. And down here, once again, mode type. So those are some of the things that we need to do. Let's go ahead and continue by going inside of the components here, and let's find input bar. If you scroll at the top here, you will once again find the import for database enums. Just change it to shared. In here, you don't need to change anything else. You can see that it's all working just fine. Great, so that is those three completed. Let's go ahead and see what else we can do. We should also have messages, user message. So once again, let's go ahead and replace database enums with shared. And let's go ahead and add type, mode type. And let's replace this with mode type. Another easy win here. Let's go ahead and do some other changes. So we have spinner right here, which will once again rely on shared, and we need to add type mode type here. So let's just add it like that. There we go. Then let's go inside of status bar, which is the same. So we need to import from shared, but in here we don't need to import the mode type. So it is actually somewhat simpler. Now let's go ahead again in the CLI source. Let's go inside of providers this time, prompt config index.ts. So I'm gonna go here first, and I'm gonna change this to be shared. Oh, since we already have one shared, let's go ahead and reuse it then. So we have default chat model ID. We have type supported chat model ID. I'm gonna add the actual mode. I'm gonna add the type mode type. And let's see, what else am I gonna do? Okay, so we need to import this before the other types, and we need to add a comma here. Let me just see. So default chat model ID, mode type, supported chat model ID, type, mode type. Okay, I think those are all we need. And now in the context value, change this to be mode type, this to be mode type. down here, find the prompt config provider and find the use state and change this to be mode type as well. I think that is the entire thing fixed here. All right, now let's go ahead inside of packages, CLI, source. I think this is in screens here. Let's go inside of a new session. Yes, we should have an error here as well. So once again, go ahead and import from shared. And this time we're going to need to add mode schema. Okay, so instead of using the enum here, let's use the actual mode schema since we have it now. And then we have to scroll all the way down to create session here. And in here, we can get rid of the path and the initial message. So we only care about the title because that's how we modified the sessions endpoint for, if you remember. And let's go ahead and quickly revisit our navigate here. So sessions, session ID is good. Replace true is good. And let's go ahead and open the state here. So we have session, but we should also have the initial prompt and set it to be the state like this. Let me just confirm that. So this is the state that we are talking about. Okay, so that is another one fixed. And now we have some bigger things to do. But before we go on to those bigger ones, let's go ahead and do one more thing that I know we're gonna have to do. Inside of messages, let's go inside of, actually no, my apologies, inside of session shell. This is the one that we need. So in here, let's find the scroll box, this one, where it encapsulates the children, and go ahead and remove this gap. Simply because what we're gonna do next is we're gonna modify the messages, which are a bit more complex. Perfect. So we knocked out a lot of easy wins, and now we have to do some tiny bit more complex refactoring for the messages, but nothing scarier than the chat route or the use chat. So don't worry. Let's go ahead and refactor our sessions screen. So inside of CLI screens, session.tsx, you can see we have a lot of things we have to fix. So let's start by adding use ref to the React here. Then let's remove pretty milliseconds from here as we no longer need that. Then from night code shared, let's go ahead and remove message parts schema because it no longer exists there. And instead, let's go ahead and import type mode type from there. So we have mode type and we have the supported chat model ID. All right, then let's go ahead down here from the use chat hook and we can remove the unused client message part now because it's much simpler this time. For the enums, we can delete this entirely. We no longer need that. And I think that that's all we have to do. Let me just see. Type message from use chat. It's all here. Okay. A lot of imports, so I don't want to get lost, but I'm pretty confident that we now have everything that we need. Now let's go ahead down here and let's find session location schema and let's add the initial prompt. So it's going to be optional object with a message, mode, and model using these custom types which we have imported above. We can delete the entire map database messages function. We don't need it anymore. So we can now directly go inside of chat message here and let's go ahead and start fixing some things, okay? So the first thing I want to do here inside of message role user, let's go ahead and extract the text part using message.parts, filter for all types which are text, and then simply map all of their text values and then join that array. And once you have that text, you can go ahead and pass that as the value of message. Now for the mode, we have to use the metadata, okay? So we have to go to message, metadata, mode, or fall back to build if we truly don't have anything else to display. Great. Now, about the error, I'm pretty confident we don't need it, but I'm not entirely sure. Let me just quickly check. That is correct, yeah. We do not need the error handled here at all. we can go ahead immediately and fix the bot message here. So parts are okay, but the model should once again be coming from the metadata. So message metadata model or unknown. Same thing for the mode, metadata mode. And guess what? Same thing for the duration. One thing we're going to delete immediately here is going to be this interrupted prop. So we're going to get rid of that. You can ignore the type error here for now, because we are later going to refactor the bot message as well. So it doesn't really matter that much. All right, now let's go inside of session chat and let's see what's different here. So besides having session, we now also have initial prompt. Let's go ahead and add a quick type for that. So here is the definition for what is the session. And beneath it, let's add an optional initial prompt with a message, mode, and model. Great. Now in here we have initial messages, but we have to no longer use map database messages. Instead, we can just use session messages as unknown as an array of messages, okay? And now in here, this is where we use our new use chat hook. So let me just collapse this so it's easier for me to look at it. Session ID and initial messages. And we no longer have streaming, but we do have status. So we can add that instead. We should have submit, we have abort, we have interrupt. All of that looks good. Basically, streaming was removed. Now, right here, we need to add has submitted initial prompt ref, and we have to set this to false. Okay. So now let's go ahead and add, let's go ahead and fix this use effect. So what we have to do is we have to return as in when unmounted and simply do void abort. Remember, we have to adhere by these rules because this abort is essentially message.stop from the use AI chat from AI SDK. Okay, so that's why we have to invoke it like this, because it's their rules now, not ours anymore. Okay, so let's see what's going on with the use keyboard here. So if key name is escape and is top layer is base, so now instead of streaming, we are simply going to have the status streaming, and the logic stays the same. So you can see we are adjusting for the API. We could essentially also do abort here, but we mapped it under interrupt, even though it's the same thing, just so we don't have to refactor too many things. All right, now we have to add one use effect that didn't exist before, which we're going to use to submit the message whenever this screen loads. Because remember, we have that cool thing that once you submit from the home page, it kind of immediately shows you the loading screen, so you don't have to wait on the home screen as you are blocked. So because of that, we need this use effect right here. So this one. Make sure you add initial prompt and submit in the dependency array. Do an early return if there is no initial prompt, or if you have already submitted the initial prompt, and then immediately set that to true so it doesn't happen twice. And then invoke submit using void. Pass along the user text, mode, and model. That's going to automatically submit the user's message, which was navigated here through the initial prompt. Okay, now let's go ahead and take a look at the session shell here. So on submit looks fine, user text, which is text, mode, and model. But for the loading, we do have to modify it. So it's going to be using status. And for interruptible, once again, it's going to be using status. For mapping over messages, it's going to be the same for chat message, but once again, it will be different for bot message. In fact, we are not going to render bot message here at all. For this streaming case, we can just get rid of it. Instead, what we can do here is we can render the error message like this if we have an error. Okay. Now down here we have our, oh, let me see. Looks like error is missing. How did I miss that? Oh, yes, we can get the error from our new hook. So in here, in use chat, go ahead and extract error from here. And that should fix the error rendering. Okay, let's go inside of the session here now. So some slight modifications are needed here, but nothing too heavy. So instead of session, in here, it should no longer be parsed.data.session. So you can remove .session here, okay? And then inside of prefetched here, what we're going to do is we're going to add question mark dot session or fallback to null. Okay, and then inside of the use effect here, we are going to go ahead and do question mark dot session return. So we are explicitly looking for session because data now has the initial prompt as well. So now we have to go down here to where we render the session chat, and alongside session, we also need to pass the initial prompt. And let's make that be prefetched question mark initial prompt like this. And to make this easier to look at, we can collapse these like that. And let's go ahead and do this. There we go. Session chat, key, session, and initial prompt. Great. So I believe that this is everything that we need to do in this refactor. So now let's go ahead and refactor the last component, and then we're ready to try all of this out. And that last component is this bot message. You can see that we have an error here, so that's where we are going to fix it. Let's go ahead and refactor our CLI source components, messages, bot message, which also has some errors here. So we're going to start by changing the database enums into shared, and then we can export the proper type from here, mode type, and we can modify the mode to use the mode type. From our hooks use chat, we can delete both of these types, and we can simply import the type message. Okay. Now let's see what else do we need to have here. So I'm going to go ahead and import pretty millisecond package, which we removed from the other component, so we can purposely put it here. And I think we don't need anything else. Okay, now let's go ahead and develop the types that we need here. So we are going to create client message part like this, message parts, and then a number. Tool part is simply going to extract from the client message part for specific tools, like this, tool part. That makes our props here correct now. So let's see, we have parts, which is client message part. We have model, which is string. Mode was now fixed. And we have to change from duration to duration milliseconds, like this. And let's change it into a number. Streaming can be a Boolean, and we can remove the interrupted prop. Okay, and just by doing this, I'm pretty confident that if you go inside of our previous change, which was the session, you should no longer have any errors in the bot message because we now added duration milliseconds here. Okay, so that is props fixed. The format tool name function is correct, so we don't have to do anything here, but this one, format tool arguments, is a little bit different. And before we can develop it, we need to add a function is tool part, which accepts the client message part, and it returns a part which has to be a tool part. So it has to start with tool, or it has to be dynamic tool. All right. And once we have that, we can go ahead and fix our format tool argument here. So let's remove this function and let's rebuild it like this, format tool arguments. And once we have that, let's go ahead and see what we have to do in group consecutive parts here. All right, so here is the problem. Part type is tool call. Okay, so instead of doing this, we can simply call our new function is tool part and pass along the part. Okay, and instead of part.id, we can now use the new API part tool call ID. All right, I believe all of this should now be fine. Group type index, part type, part, all of this looks fine to me now. Now let's go ahead inside of the bot message and let's see which props do we need, which props do we not need. Parts we need, model we need, mode we need. Duration has now changed to duration in milliseconds, and we can remove interrupted entirely. Okay, so now let's go ahead inside of this group consecutive parts, and let's see. Okay, so we have a box group.key padding is equal to 1. So I want to remove this padding. Okay, And what I want to do is I want to go inside of this inner. Let me just see. It's a bit confusing to look at this, okay? This is what I want to do. So I want to remove padding Y and I want to add dynamic padding. So I have to extract the index from this map here. Okay, padding top. If index is 0, meaning if it's first, then no padding top. Otherwise, padding of 1. So only subsequent messages have spacing, but the first message shouldn't have any spacing at all. So down here, we should pretty quickly find the error, which is instead of using our new is toolpart, we're doing this. So let's simply do is toolpart part. And once again, instead of part ID, we should do tool call ID. All right, so let me just confirm that's all we need to do. I'm pretty sure it is. Okay. So now let's see what's wrong inside of this text here. So format tool name. Okay. Let's see. We should probably construct tool name first. So let's do that in here. If is toolpart, let's go ahead and develop this tool name. So if part type is dynamic tool, you can extract part tool name from it. Otherwise, let's go ahead and remove tool dash from the part type, and then we're going to be left with whatever is the name. And that's what we're going to get here, tool name. Okay. And then we should be able to just pass along tool name in here. Okay. So I don't want to change anything else, but for the output here, we need to make it a little bit different. So it's not going to be status, it's going to be part.state, and we're going to do if not output available. You can see how we have type safety now, okay? So if not output available, we're not done yet. And if part.state is not output error, then we're going to display 3 dots. Otherwise, we're going to display empty string, okay? And then we're not done yet. Below that, we have to handle the error. Okay. So let's see. Do we have anything important here? I don't think so, but perhaps here. Yes, looks like here we do. Okay, so first things first. Instead of padding bottom, let's do padding top and set it to 1 here. Let's see. Okay, well, actually, we can just do padding Y. I think that might be smarter. Okay, so box direction flex row. So, okay, what is wrong here? Oh, so this is for the interrupted one. Okay. So I think it's easier to just delete this text element entirely. And then let's just go ahead and display whatever we need to display for the plan instead of doing the interrupted thing, okay? Then let me go inside of this box here. So text, so it's deciding for plan or build. Okay, attributes, I don't think we need any attributes here. Let me just see. Yeah, let's remove the attributes for now. Yeah, because this is for interrupted, so we don't need that. Okay, then we have this separator here, colors separator. I think that's fine. Then once again, we have this logic for duration or interrupted. So what we can just do is we can check duration in milliseconds. And instead of checking for interrupted, we can just check if not null. So if it's not null, in that case, let's just go ahead and render the duration. I think this should work just fine. Sorry for being so slow here, but a lot of things already exist. I have to look at my fix and I have to think at the same time. Duration millisecond, duration millisecond. This should work, but I'm doing something wrong, obviously. So let me check what it is. Oh, probably because I put an identical here. Yes. So I shouldn't use identical. Okay. But I think this might be it. I think we've done all of the changes. I think that we are ready to try now. All right, for the moment of truth, let's go ahead and try 32 files changed. Let's see if we fixed our big problem. All right, let's get started. So first things first, I want to go inside of my packages and specifically inside of my database, and I just want to have my studio open, okay? So it's going to be open right here. It's very small, but it's mostly just so I see if I get any sessions here. So I currently have no sessions. Okay. I don't think I have to migrate anything. Okay, I'm going to do bun run dev server in this one. So far, so good. Okay. Then let's do bun run dev CLI here. All right, so far, so good. Let me go ahead and perform a login here. So I'm not sure where this is opening. Okay, continue. Let me go ahead and allow my permissions. Okay, and I think I'm good. I think I'm able to log in now. Okay, let's try. What is this project about? Let's see if we get any errors or not. Let me explore the project structure to understand what the project is about. And are we seeing tool calls? Everything looks good. The rendering looks good. The grouping looks good. The duration in milliseconds seems to be working, though it's displaying the milliseconds directly. I wish it displayed it only once it's finished, kind of like an indicator that it's been done. But okay, for now. Okay, I mean, we should be able to figure out how to fix it. But yeah, let's wait for a second and see if this is now working. This is plan mode for now. Great, so plan mode seems to work fine. Let's switch to build mode. If you want to, you can also switch to a different model just for fun. And I'm going to tell it, create a new file, foo.js, with some content inside. So let's see. It switched to build mode and it is using GPT 5.4. It says created foo.js with sample content. Let's see if that's true. Foo.js and sample content inside. Beautiful. So I've purposely switched to a different mode and to a different agent inside of the same session to confirm that is still working. So let's go inside of new, let's go inside of sessions, and let's select this and just confirm that we can actually load a session from history. That works as well. Brilliant. So I can now take some time to look at my database here just to see how this looks. So it's going to be slightly different because we now only have the sessions table, and you can see that messages is now a JSON object here. It's very fluid, which was simply an easier refactor for us to do. You can still use the messages table if you feel more comfortable with that. I will completely understand if you do that, but I hope you understand why I chose to do the simpler version now, simply so we can bring this refactor to an end and so you have a working project. I do see some logs in the server here. Okay, warning logging. Okay, this is unrelated. Okay, so it's warning me that I have some incompatible reasoning parts, but it's not breaking the app. It's just a warning. I mean, just a warning. It's good that we have it here, but that's purposely why I changed a different model and a different mode. Looks like we can still use it, but AI SDK is warning us that some context could be lost, but I am okay with that if it works. If the context is persisted and if we can achieve what we wanted to achieve, which is tool calling, I am perfectly comfortable with that. So the only thing that is tricky right now is the following. So write me a long message. So let's go ahead and switch to plan mode and tell it to do that. And if I press escape, you can see I no longer have that interrupted state. And if I go back to new and if I go into session, you will see that that last one won't be persisted. So that is the only thing we lost. Unfortunately, it is a bit out of scope for this refactor because it does include some complicated logic. I would invite you to try and challenge yourself to implement that using AI. Feel free to do that. I mean, we are building a coding agent, so obviously you now know how they work from inside out, so you will be able to use them that much more effectively. But for the moment of truth, we actually have to try what we did in the beginning, which is attempting to use another version of the server, but we have to deploy it first. So let's do that and then we'll test if it works. So let's go ahead and do this. So I'm going to go back to the root and I'm going to do git checkout -b. This is 10 client side tool execution. I think that is the appropriate name for this chapter, or migration to AI SDK would be another good one. Let's go ahead and add all of the changes here. M10 client side tool execution, git push dash u origin 10, like that. There we go. So it should now pop up here any second. Since this was a huge refactor, I think we're gonna get like 1 billion comments from CodeRabbit. So you can just add CodeRabbit pause, because I don't want to see the review right now. I mostly want to see if it works first. Okay. So I'm gonna go ahead and do merge pull request anyway. Let's just confirm the merge, and we can fix it later if something doesn't work. Do not delete the branch. I mean, if you care about that, you can see I maintain all of the changes here. So you have branch 10. And now that this has been merged, what's happening here is that production is being rebuilt. So since we didn't add any new environment files, I think everything should be perfectly fine. One thing that I removed from here is the API URL, even though I think it absolutely doesn't matter if you have that in the server. So don't worry if you don't see it here. I removed it because it's only used in the client, but it won't hurt the server. If it does, you can remove it and redeploy, but I highly doubt it would. Okay, so I'm gonna wait until this finishes. All right, so this is now deployed. So I'm going to click here, okay, not found. All of this looks good. We already have this added here, so I don't think we really need to do much. What's important is that this is at the newest version, so that it's merged. And let's try it out now. So we shouldn't need to run our server now. The only thing we would need to do is modify our API URL. Just remove the trailing slash like this. And then let's see, bun run dev CLI only. That's the only thing we need. So I'm going to log in again because we are at an entirely new backend now, right? So let me log in here so we get a new token. Let's allow access. Great, successful login. Let's go ahead and try this out. So this time the CLI is running locally, but the server is hosted somewhere else. So this is the production case, right? What would happen now? What is this project about? So I am running Nightcode inside of my local machine. So let's see, is tool execution now happening on the client, or is it happening still on the server? You can see by the amount of read files and list directories, we have successfully fixed this extremely problematic architectural issue that we had, which unfortunately didn't allow this project to read anything other but the server's file system. But now we can thankfully execute tools on the client, meaning wherever you run this CLI is the place where it's going to be reading the files. So we fixed that huge architectural issue that I've added. My apologies for that once again, and congratulations on this huge refactor. Now let's go ahead and just do git checkout main and git pull origin main. So all of these changes are synchronized and you aren't on that branch, but you are on the main branch with all of the changes. And remember, if you want to develop, you have to revert this back to localhost 3000. Otherwise, it's always going to use your production server. So choose which use case you want to be with at the moment. And for the end, I want to teach you how you can run Nightcode in any repository on your machine. So just like you can call open code, for example, and it opens anywhere, it would be cool if we could do the same for Nightcode. Well, we can do it. So first things first, make sure that you actually use your deployed API URL so you don't need to have the server running. Then let's go ahead and do bun add .environment. So in the root of your project, your package JSON here should now have .environment. Next, let's go ahead inside of CLI, ignore the bin and dist folders. So I have them because I was just testing things out, but you probably don't have them, so feel free to ignore them. But go inside of package JSON of the CLI. And in here, first things first, let's go ahead and create the launcher using bin Nightcode and then target this bin folder Nightcode. Then let's go ahead and create the actual build script down here like this. So bun build source index outdoor dist target bun. Okay. Now that we have that, let's go ahead and create a bin folder, and inside let's create a launcher Nightcode like this. And in here, let's go ahead and paste this. So we have shebang here, we import .environment, and we simply inject the environment file inside of here, and we import the index tsx. So right here, this is the launcher, okay? So it should be exactly like this path here, bin Nightcode. Usually you could do this directly from the script, but because of bun, it has its own banner, so this shebang breaks entirely. So we need to develop it as a launcher. And this dist is simply where the thing is going to be built. You probably don't have this yet, but you should have the bin now because we just created it. And then go inside of package.json, so back here, and go ahead and add the following. Add a comma, and then bun, build CLI, and then beneath it, go ahead and add link CLI. So what build CLI in the root package.json is going to do is it's going to filter for Nightcode CLI. So make sure that instead of CLI package.json, it's actually the name of the package, because that one is going to find it and run its build script. Okay, so make sure that this is called build and this Nightcode CLI. And link CLI is going to run this command which I just described. It's going to change directory inside of CLI and run bun link. So let's go ahead and try this out now. So in the root here, bun run link CLI. There we go, everything seems to be successful. Let's try now Nightcode here, and there we go. But let's make it more fun and let's switch to some other project. So this is Resonance. This is my open source 11 Labs alternative, my previous project. And what happens if I run Nightcode here? Let's switch to plan mode and let's ask it, what is this project about? And let's see if it will be able to run independently. So I don't have my server running. It's deployed on Railway, and here it is, Resonance, open source alternative to 11 Labs. Beautiful. So we officially came to the end of this tutorial. So what could be the next steps for you? Well, obviously there is a lot of polishing that could be done. For starters, you could commit this and deploy it, of course. What I would recommend doing is challenging yourself and using maybe AI to adapt this by adding a whole new script which will allow you to distribute this using GitHub releases to your users. I think that would be a fun challenge, and you're practically halfway there. The other part is just a script which allows you to install something using another shell script. So feel free to give yourself a challenge to do that. You now have Nightcode available on your machine, and you can use it just like you can Claude Code, Open Code, or anything else. Congratulations on finishing your very own coding agent, and thank you so much for watching. See you in the next tutorial.